I see us on Facebook.
Okay, cool.
I see us on Facebook.
Okay, cool.
I
Okay,
see us
cool.
on Facebook.
Okay, cool.
I
Okay,
see us
cool.
on Facebook.
Okay, cool.
I see
Okay,
us
cool.
on Facebook.
Okay, cool.
I
Okay,
see us on Facebook.
okay, cool. Okay, cool.
I see us on Facebook.
Okay, cool. Okay, cool.
I see us on Facebook.
Okay, cool.
I see us on Facebook. God, what it was.
Okay, I can see us on Twitch. Thank you. Someone said it's awesome. Okay, so we are live now, and it's 30 minutes to go. So what do we need to check the other room, right? Yeah, okay, let's go. Oh no, I will connect as a host from the another machine, and then I will be able to join your room. I cannot hear you because you're muted.
Oh, okay, okay.
Okay, so I am here. Oh no, what did I do? Okay, it's gonna take a while. Okay, 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 okay. Why is it echoing? Okay, I figured. Maybe I didn't. Is it any better? I cannot hear you.
Yeah, it looks like.
Okay.
Right.
Sorry, guys. It was awful. Okay, so now I'm gonna, I cannot leave this meeting, can I? Okay, now the conference is the host. And I'm gonna leave the meeting. And you do too.
Yeah.
Hello.
Hello, I can hear you.
Okay, nice. I can hear you too. Do you want to check real quick your slides and your video?
1 second, let me kill Twitch. It's confusing me.
Okay.
Okay, slides. I posted them in the channel, the Slack channel.
Yeah, I mean, can we check them here? Can you share?
Oh, here, sure. Sorry, let me pull them up. Slides.
Just because we have only 5 minutes after my opening words.
Yeah.
Yeah, it's better
Okay,
to check
I'm
now.
presenting, and then I need present on. Here we are.
Okay, perfect. Let me see them on Twitch. Who am I? Yes, perfect. And I can see you. Okay, thank you.
Sure. Yes, we're in business.
Yeah. Okay, you can stop sharing.
Okay. Video. Stop share.
Okay, cool.
Cool.
See you in a sec.
Yep.
Hi, I can still hear you. Can you mute yourself, please?
Oh, sure.
Thank you. Hello, everyone. We're starting in 3 minutes. And do you mind start some kind of audience participation? Tell me where you're from in the chat. So that I would know that you're Mexico, Italy, Russia, hello, Bay Area, Ukraine, UK here, India, France, Spain, Germany, Norway, Russia, Turkey, Finland, Hawaii, Italy, Austria, Russia again, Sweden, Switzerland. This is cool. So many people. I'm so glad I can connect to all of you. Yeah, Czech Republic. So that means you can hear me well. Belarus, Colombia. I'm excited, guys. Like really, really, and I'm so happy. India, hello. France here, Spain. Some people commenting on Twitch too. On Twitch, yeah, Brooklyn, Brussels, Iran. I'm not sure I will be able to look both at this chat and love from Bellevue. Yes, I am from Bellevue too. See, a lot of love for you. Okay, 1 minute. See, I'm a little bit trembling. Hi from Tokyo. Yes. Yes. Just 1 more minute. Can we watch back the recordings later? Of course you can. We're going to record everything and then edit it and post that on our YouTube channel. All right. This is awesome. Welcome everyone to my home. Welcome everyone to my first conference, my very own conference. You know what? It's unprecedented times. It's a stark reminder that the health and well-being of our loved ones are truly the most important thing. One of the most important things that we can do in the light of the global pandemic is to stay home if we're fortunate enough to hold positions that facilitate remote work. An unfortunate byproduct of this has been limited conference attendance. After many conferences sadly needed to be cancelled, I thought it was heartbreaking and decided to organize my own conference. I called it Scala Love, not only after my podcast, but also to celebrate the unity of our community and compassionate during tough times. I prepared a small tour of our conference. Let's take a look. It's somewhere here. I hope you can see the presentation. Can you drop me a message in chat that you can see it? Okay, can see. So this is Scala Love. Please tweet about that using hashtag Scala Love. And I am the organizer, Oli. Follow me on Twitter, Oli_Kitty. And I want to say a special thank you to my best friend, Elena Kuznetsova. Without her, that wouldn't be possible. She helped me plan everything. She helped me to think about every little detail, how that can be engaging and funny conference. And funny Fact about her, she's Java developer, and I spent last 3 years trying to convince her to change her mind and switch to the light side, to Scala. Hopefully, this conference with the Scala Love will switch her on our side. I also want to thank my program committee, Grigory Pomachin and Nicholas Ronaldo, who spent tremendous amount of hours trying to go through the all submissions that you posted and carefully considering all of them. We've got more than 50. Then I want to thank Ida Bzowska for creating all newsletters, Twitter decks, and just supporting me in everything I'm doing. Also, we have super wizards. These are 3 people who, if you have any problem, please don't hesitate and bother them on Slack or in QA room. Sandeep and Valentin are moderating those rooms, and Rebecca is just for you on Slack whenever you have the problem. And track owners, these are people who will be helping you and speakers to enjoy the conference. And of course, I couldn't put all the speakers on this slide, but you just know there are 30 plus people who are taking their time, put their effort into creating the best presentations for you. Slack channels. There are general channel talks, support, Sam and Rebecca again, Number Devil and Valentin Casas if you have questions. Then incidents. If you have non-technical issue, something is happening, please don't hesitate to report it. You can use anonymous bot if you want to keep your name secret. And also, I know that there are a lot of people who lost their job during these times, and I've created a channel called Jobs so that you could exchange if you're looking for a developer or if you're looking for a job. Then rooms. This is the Joy Room. And we have another room, Happiness Room. You can watch them on Twitch. Also, we have 2 QA rooms, and track owners will give you links to join those rooms after each talk. It also can be used as a hallway track. If you want to skip 1 or 2 sessions, just join there and talk to people. Don't hesitate. We need to create some networking. And Harmony track. It's more innovative and interesting topics curated by JetBrains. It's a separate track. It starts a little bit later today, but you can find all the information in Harmony channel. So stop sharing. I want to say one more time, welcome. And the conference you're about to enjoy is filled with love of many people. Please enjoy, get inspired, and just spend next 14 hours learning about Scala. Thank you. I want to hand the microphone to our first track owner, Chris Berry. Chris, please make sure that your setup is working.
Hey, thanks, Ollie. Lee, can you, hi, sorry, can you hear me?
Yep, I can hear you loud and clear.
Okay, cool. I don't know if you want to start sharing your first slide now. Maybe that would be a good way to
Sure.
for people to know that it's this room and they can see it when they join.
Sure, let me do that. Start video. Share screen.
Oh, you're in San Francisco now. Amazing.
Maybe my laptop is. Okay, can you guys see this?
Yep, looks good to me.
Okay, great. Cool. Yeah, I guess I'll just wait till 3:15 before starting properly.
Yeah, no worries. I'll probably start a minute beforehand and give you a bit of an introduction.
Sounds good. Meanwhile, I'll mute my
Okay, welcome everybody to the Joy track for Scala Love. For those participants joining us on Zoom, please feel free to ask any questions using the Q&A option that's on your client. That's the Q&A option, and I'll be asking those to the speaker at the end of the talk if we have some time. If not, don't worry. I'll also be posting a link to a breakout room that our speaker will be joining after the talk. So if you have any more questions or anything you just want to speak to them about, feel free to join that at the end. And now it's my great pleasure to announce our first speaker for the day, Lee Haoi. I'm sure many of you already know Haoi, but he's a major contributor to the Scala community. He made many popular open source projects such as Ammonite Scala REPL and the Mill build tool. Haoi has used Scala professionally to build distributed backend systems, programming languages, high performance web applications, and much more. And today, Haoi is going to be taking us through Mill, a build tool based on pure functional programming. Lee, are you okay to carry? Haoi, are you okay to carry on?
Hello. Yeah. Sorry, let me get set up here. One moment. Okay, you guys can see the screen.
Yep, we can see it.
Okay, cool. So hi everyone. My name is Howie. This talk is going to be about Mill, a build tool based on pure functional programming. So I'm currently working at Databricks. We are a heavy user of Scala, the Bazel build tool, millions of lines of code in a bunch of different languages and frameworks. Previously, I was at Dropbox, and throughout this whole time, I've been doing a bunch of open source work. So many of you have used tools like Ammonite, Mill, FastParse, Scala tags, etc. I'm curious, how many of you guys are using different tools? Like, can you comment in the chat? Let's see, like, who's using Ammonite, who's using Mill, who's using Scala tags or FastParse. How do I see the chat? Chat. I don't know how to see the chat. I see someone on Twitch is using Request Scala. Someone else using Ammonite. I guess lots of people like Ammonite. Glad you guys like it. So let's move on. So the agenda for today is we'll cover what's a Mill build tool, what's functional programming, how a build tool is similar to functional programming, how a build tool is not similar to functional programming, and how the Mill build tool uses functional programming. So first, what is the Mill build tool? So Mill is an embedded Scala library built on top of Ammonite Scala scripts. It's heavily inspired by FDT, Bazel, Scala RX, and other things. Mill was not built in a vacuum. It's built on top of many other previous projects and made great strides forward. And to a large extent, it's just plain Scala. There's a bit of a star there. It does a few funny things, but by and large, it is just plain Scala. So if you look at a simple Mill build, it looks something like this. We have a build.sc file, some imports. I define an object that extends a module and define a Scala version. So this object foo creates a module in the foo folder, sources in foo/source. There's a resources folder in foo/resources, and so on. And I set the Scala version to 2.13.1. So this gives us the ability to run mill foo.compile, foo.run, foo.assembly. And these commands do everything a modern build tool should do. So if I run foo.compile twice in a row, I don't change the sources, it will not recompile because it's already ready. If I then run foo.run, it does not need to recompile because it's already ready and it'll just run it straight away. If I then change the source code and run foo.run again, it will then recompile automatically before running foo.run, before running your application. So this kind of incremental computation where it only does as much work as it needs to do is crucial for any modern build tool because many of these compilation steps, minifying steps, tree shaking, bundling, all of these are slow and you do not want to do them more than necessary. Mill also supports test suites. So in this example, we are adding a test module here, object test extends test. It's just another module, which is this object is another module within the foo module, and it lives in foo/test. The module is in foo/test. The source code is in foo/test/source. And to make the test work, I need to add a test framework and define which test run I'm using. And this gives us the ability to use mill foo.test, mill foo.test.compile, foo.test.assembly, and so on. Mill supports multi-module builds. So here we have an example of 3 modules which share the same configuration. So configuration is defined as a trait app module, extends Scala module, and I have object shared extends app module, object foo extends app module, which depends on shared, And object bar extends add module, which depends on shared as well. So this gives us a small dependency graph with 3 modules, 2 of which depend on the shared module. And I can compile, run, and assemble all of the modules independently. And it automatically gets wired up. So if I compile foo, if shared is not yet being compiled, it will compile shared. Mil makes it very easy to wire up things. For example, let's consider a bit of an awkward use case. I want the foo module to have the bar module's assembly jar, like the self-contained Uber jar, as a resource. Why might I want to do this? Maybe I want to deploy it to a different server. Maybe I want to write it to a file somewhere and then execute it as a subprocess. So I don't want it as a dependency in my class path program and my program, but I want it as a file I can go chuck somewhere. So Mil makes it very easy to just override the resources and copy the file in. And after that, when you bundle foo, when you run foo, everything will be taken care of automatically. So I'll go into a bit more detail what this syntax here means in a moment. What does Mil do? Mil does everything a modern build tool does. And for JVM, that means I resolve dependencies, I compile source code, code generation, test things, zip things. All of this, all the things that SVT does, Mil also does as first approximation. Mil does not depend on SVT. Mil just re-implements all of this from first principles. It turns out that zipping files into jars and shelling out the Scala test to run your tests is not a particularly challenging programming problem. You just implement it and it works just fine. So why is Mil interesting? First, because Mil is fast. So Mil uses a background daemon by default, which keeps the JVM warm and responsive. And so when you run commands at the command line, the response times hover around 200 milliseconds or so of overhead. And because the JVM is warm, compilation is fast, bundling is fast, everything is much faster than many other build tools. Mil has out-of-the-box functionality, meaning that you can do a lot of what you need without any plugins. What do you need to do? You need to compile things, you need test things. How do you deploy a thing? You want the Uber jar executable assembly? Mil gives you that. You want to publish something to Maven Central? Mil gives you that too. No plugins required to provide everything you need. And everything's a bit of a star. Obviously, depends on exactly what you need, but Mil provides a lot of things built in without needing to fiddle with plugins. Mil is pretty well battle tested. So this is not just a case of, oh, this might work. Mil's used heavily in a lot of big projects. Like my biggest project, I think, is Ammonite, which due to all the cross builds has 179 Scala modules within it. And I can run them all, compile them all, test them all, publish them all. Now we just got the ability to do it in parallel. You can see 8 cores or 20 cores running in parallel, compiling Scala in this huge multi-module project. Mil supports Kotlin, Java. I use it for my blog. You can incrementally generate your static blog for you or static website. You can construct asset pipelines in the web. Maybe you need a version file layout with content address hashed file names. You can do that in Mil and have it cached and incremental for you. Or you can do things like construct PDFs. There's a Apache PDF box Java library. Just import it into Mil and you can start constructing PDFs as part of your build. So the thing that's most interesting about Mil, I think, is that it's intuitive and trivially customizable. So the point of Mil is that you just write plain old Scala. So within each build step, just write your Scala code, create your files, compute your values, and all the other stuff you get for free, like caching, file watching. Now you get parallelism in the latest master. Your code does not need to care about that, but you can just write plain Scala and you get all the good stuff. And I like this quote from Rex Kerr, which says, "I am so happy every time I have to tweak a little build stuff and find that my project uses Mil. Build system easy mode for the win." So I haven't seen anyone else say this about other build tools, but people do say it about Mil. It is really quite a nice tool to use and makes things really easy. So that's a lightning summary of what Mil is. I didn't go into usage documentation. There's a lot of documentation online about how to use it to do various things. This is a summary of what more or less Mil is and why you should be interested. Next, what's functional programming? Before we talk about what's functional programming, it may be worth discussing what are functional programming languages. These are a bit less contentious. So everyone agrees that Haskell is a functional programming language, or Camel, Clojure, Scala, F#, Scheme, all of these are functional programming languages. If we agree that all of these are functional programming languages, what do these languages have in common? So it's not really macros or metaprogramming. Sure, Scala has macros, but they're not the main thing in the language. It's certainly not parentheses because Haskell or F# don't have it. It's not type systems. Most lists do not have a type checker. They're untyped. Not all the languages use monads. Not all languages are going full on writing interpreters within interpreters like the Scala or Haskell folks do. In fact, if you look at most interpreters, the Python interpreter is written in C, the Ruby interpreter is written in C. So that's probably not something specific to functional programming either. And what about constructing programs at runtime to execute? That sounds quite high level and fancy, but I've been doing that since 2010 in PHP templating my JavaScript. That was not a great experience, and it's not the same joy you get from functional programming. So what do I think functional programming is about? So as an example, I'm going to use a case study, which is my favorite tiramisu recipe, Michael Chu's classic tiramisu from the Cooking for Engineers website. So this recipe comes in two representations. One is a traditional imperative sequence of steps. So we begin by assembling the ingredients: 4 large egg yolks, half a cup of wine, 2 tablespoons of sugar, etc. You whisk the egg yolks, pour them in sugar and wine, whisk them again, step by step until you finish it and you have a tiramisu. Represented in pseudocode, I'm using Python-like pseudocode for now. It looks something like this: make tiramisu, do a bunch of steps. In the end, I return the eggs, which after being mangled so much, they are now a tiramisu we can use. So what's wrong with this? Well, this works and it's on the website. You can use it. You can follow the recipe. But the difficulty comes if you want to change the recipe. You want to refactor the recipe. Why would you want to refactor a tiramisu recipe? But if you have 2 people to work on tiramisu, can you make it faster? What can you do in parallel? Or what if after halfway through the recipe, I realize I bought the wrong kind of cream? I messed up. What do I need to do to recover? Do I need new ingredients? Which new ingredients? And what steps? Or if I spill the bowl on the floor halfway, a bunch of my ingredients are gone and I need to repurchase them and reassemble them. What do I need to do? So these are all questions that you can answer from this representation, but it is non-trivial. But realistically, you often have to do it if you're in a busy kitchen with many things happening and you want your dinner to come out as soon as possible. Michael Chu's classic tiramisu has another representation, which is kind of like a flow chart. So it says, well, I start off with egg yolks, granulated sugar. I beat the egg yolks, beat them with the granulated sugar and masala wine, whisk them. Then I beat them with mascarpone cheese. Then I fold them into the heavy cream, and et cetera, until you refrigerate it. And on the right side comes out the tiramisu. So if I look at this as a graph, this is basically like a data flow graph, or maybe you can call it the food flow graph of where the food is going and where the tiramisu comes out on the other side. And if you represent this as code, it might look a bit like this. So this is a bit of an awkward, like nested function calls code. But if you draw the arrows of where all the variables are going, you'll see that this graph that appears here is exactly the same as a graph that appears here on the flowchart. It's just in a slightly different direction. And it's a straightforward method to just assign local variables to the intermediate computations, give them names, and you end up with quite a reasonable looking piece of code. Except now, instead of having an imperative piece of code, I have a functional piece of code. So imperative versus functional, they kind of look the same. What's the big difference between them? So imperative code is a sequence of steps, while the functional code is kind of a dependency graph of steps. So in imperative code, it's usually unclear where the ordering matters, where it doesn't. And anyone working in a large imperative code base has seen a problem where, oh, I reordered 2 statements and some weird thing happened because the ordering mattered, but I didn't figure that out. Whereas in the functional code, it's usually trivially obvious which steps must happen before which other steps. If I compute a variable and I pass it to you, then clearly I must happen before you. And if your computation output gets passed to someone else, you must happen before them. So in imperative code, the dependencies are implicit in the ordering, while in functional code, the dependencies are explicit in the structure of the graph. Whether it's the data flow graph or the definition and identifier graph in your program, it's the same graph in the end. So coming back to refactoring, if I want to refactor this recipe to answer these questions, it's much easier. So although here I have a sequence of lines of code, it's straightforward to go back from that sequence to this data flow chart or this graph. And from this graph, it's trivial to see that, well, if I have multiple people to work on the tiramisu, these 4 sections can be done in parallel, no problem. Instantly, I can see this. If after I beat the eggs and cheese, I realize I bought the wrong kinds of cream, instantly I can see that I need to get new cream, re-whip the cream, but all the eggs, mascarpone, masala, wine mixture are unchanged, are still usable, and espresso and granulated sugar are also still usable. Lastly, if I spill the bowl after beating mascarpone cheese into egg mixture, what ingredients do I need to recover? I can just look, I messed up here. I go to the left up the graph. I need egg yolks, granulated sugar, masala wine, and mascarpone cheese. So we are thinking about dependencies between parts of your program rather than lists of steps to be done. That's what functional programming is about. It's about the data flow rather than control flow. So it makes things like parallelization, reordering, and incremental recomputation trivial. And this doesn't matter whether you're trying to incrementally recompile your Scala code or you're trying to incrementally reconstruct your tiramisu because someone dropped the bowl on the floor. It's kind of the same thing, and you need to do the same reasoning to get your answer. So while we often serialize a functional program, the dependency data flow graph into a linear sequence of lines of code, the core structure is a data flow graph. And anyone who looks at the lines of code will be able to figure out the data flow graph. Your compiler will take the lines of code, turn it into a data flow graph, and then compile. Your editor, your IntelliJ, will take the lines of code, turn into a data flow graph, and then do the analysis. And you, the programmer, are probably doing the same thing in your head. And that's why working with functional programs is often easier than working with imperative programs. So next, how are build tools similar to functional programming? Here are a bunch of build tools from the Java ecosystem. We have Ant, the oldest one, Bazel, Pants, Mill, the newest ones, and SBT, Maven, Groovy in between. Java build tools all more or less do the same things. So these are things that Mill does. You look at Groovy, you'll have the same things. Look at Bazel, for the Java side, we'll have the same thing. SBT will have the same things. What's notable about these steps is that they all follow the same pattern. Resolve library dependencies to make dependency jars. Compile source files and dependency jars to make class files. Test class files and dependency jars to make test results. It's always do thing to foo and bar to make output. So not everything in the build tool matches this template, but I would say maybe 99% of the things the build tool does will fit this template. So things like Scala formatting of source files doesn't really fit. Things like uploading to Maven Central doesn't really fit, but most things will fit. And if I take this from English-like SQL or COBOL-like code and turn into, let's say, Pythonish pseudocode, it becomes this. Output equals do thing to foo and bar. I pass foo and bar to a function do thing, and it spits out an output. And this is exactly what functional programming is about. You take things and you spit out outputs, and there are no side effects. I'm not mangling them in place. I'm not doing weird things for network. Take inputs, spit out output. Take input, spit out output. Do the same thing over and over until you have a final output that you want to be able to use. It turns out that build tools and kitchens making tiramisu have often very similar requirements. A build tool may want to parallelize build steps so you can see your code running faster, and a kitchen may want to parallelize different cooking steps in order to get your tiramisu out the door. If someone changed the source file and I want to regenerate the artifacts affected, that's the same as someone changing one of the ingredients and having to reassemble the different components that I need. If someone wants to figure out, given these tests I want to run, which input files I need to watch, that's the same as saying, given this build step which I messed up, what are the ingredients which I need to recover from that, input ingredients. So although very different contexts, the requirements are actually very similar. So how are build tools similar to functional programming? Build tools are largely, with a star, largely made of pure functions. Output equals do thing to foo and bar inputs. And the ease of which functional programming allows refactoring, parallelization, analyzing, and computation is exactly what the build tool needs to do. So while functional programming helps humans do it and a build tool needs to do them automatically, it's really the same thing when you take some unrelated computations, run them on separate threads, or you take an incomplete computation and want to complete it without having to redo a bunch of unnecessary work. So we've seen what's Mill, we've seen what's functional programming. We've talked about how build tools like Mill, but others as well, like Bazel and others, are similar to functional programming. Let's now look at how build tools are not similar to functional programming. So if functional programming is so good and build tools are so similar, why don't we just write all our build tools in raw Haskell with no libraries? After all, it's a functional programming, right? Functional programming language, right? It turns out that build tools have some very specific requirements that are very poorly satisfied or not satisfied at all by naive functional programming. Build tools need introspectability. Build tools need persistence. Build tools need some kind of long-lived worker process daemon things. And build tools need ad hoc overrides. And we'll go into these one by one. First, let's look at introspectability. Consider this snippet from our earlier tiramisu recipe. I'm just going to use the first 3 lines. I beat the eggs, I beat eggs, sugar, wine, and wine to make the mixture, and then I whisk the mixture to make the whisked mixture. So if this is a pure functional program, there isn't that much you can do with it as a program. Pure functions tend to be opaque. You can run them, and that's about it. You pass some parameters, they run, something comes out the other side. It's not like an object where you can look at the fields of an object, inspect the fields, reflect on this, reflect on that, maybe poke at some getter methods. Functional programs tend to be full of pure functions, and things you do pure functions, you run it, and that's about it. On the other hand, what does a build tool need to do? Build tools do not just run your entire build over and over. That would be exceedingly slow. Imagine if every time you wanted to change a line of code to add a print line, you had to delete every single compilation artifact and recompile the world from scratch. Now, that would be unacceptable. So build tools need to be able to inspect the structure of computation, to parallelize steps that can be parallelized and don't depend on each other, to incrementally recompute steps that without having to recompute the ones that are still valid. And if you're using something like mil-watch, SVT tilde, or like Bazel-watcher, you need to be able to inspect the graph to figure out what inputs to watch. I want to run these tests and inputs change. What are the inputs? I need to know. Next, persistence. Pure functions have the intermediate values live in memory. Beat, eggs, mixture, whisk, everything except the return value of this function lives in memory. And they either go away when they are garbage collected, or they will go away when the program terminates. This is very good if you want to avoid side effects, because there are these little things encapsulated perfectly in memory. No one else can poke at them, and you cannot poke at, and they cannot poke at anyone else. Great. Build tools are very different. Build tools need to have every output for every intermediate step serialized and saved somewhere, so the next time someone runs a build tool, we can reuse them. How are they serialized? Where do they get saved? We need to answer those questions. Maybe it's messy, maybe it's tricky, but if the decision is between waiting 1 hour to recompile universe from scratch or accepting a bit of messiness in the build tool, everyone will pick up the messiness. Everyone will choose the messiness in the build tool in order to reduce their iteration times. So the third thing, long-lived workers. Pure functions have no side effects and can be run any way we like. I can run them once. I can run them 5 times over and over. I can run them 100 times on separate threads or even separate processes. It doesn't matter, they're pure functions. Build tools, on the other hand, are different. The things that the steps your build tool needs to do often require some setup. The setup is often expensive. Maybe your JVM is cold, needs to warm up, takes 1 or 2 seconds. Incremental compilation caches in Zinc need to be populated. That takes a while. First runs will be slow. After that, it will be much faster. And your WebKit HTML to PDF worker needs to be spawned if you want to use this to convert some HTML pages into PDF. And all of these things are often expensive. You want to reuse things. And concurrency is often limited or disallowed. I cannot spawn 100 Scala compilers on my computer. It will explode. So I need to be able to limit it. There's no such thing as such thing as 0 side effects when running out of memory is a side effect. Lastly, ad hoc overrides. So a pure function's parameters contain everything you need to do you can do to customize it. I can change what eggs I pass in. I can change what sugar one I pass in. I can change what wine I pass in, and that's about it. If I want to customize other things, I need to pass in flags. I need to pass in the egg beater I want to use or the whisk I want to use. But if I basically cannot configure anything that is not part of the function parameter list. So this is good if you don't want to configure things that often. And this is bad if you very often want to configure things. While maybe in production code, you don't want to reconfigure things all that often. Your production code is often quite elegant and straightforward. Your build code is usually very, very gnarly. And when you're working the build system, the exception is the norm. Someone will need a custom artifact name. Someone will need special Java options. Someone will need a weird code generation step in order to convert their proto files into Scala source files. And they'll need a second code generation step to mangle the Scala source files with a weird vendored version of Scala PB. And some module somewhere is going to need to turn off incremental compilation because Zinc has a bug in it and we can't figure out why. So there is no elegance in this. Every module, not every module, but almost every module is going to need something special. They're all going to need something different. And we need, as a build system, need to be able to handle that in a reasonable way. So these are the 4 ways that build tools are not similar to pure functional programming. They need introspectability, they need persistence, they need long-lived workers, they need ad hoc overrides. And if you start writing a hello world program in Haskell, these are the 4 things you're missing to turn it into an awesome build tool. So what's next? We've covered what's a build tool. We've covered what is functional programming about, how build tools are similar, and how they're dissimilar to functional programming. The last thing we'll cover is how the mill build tool uses functional programming, but also does some tweaks to it in order to satisfy all the requirements that any modern build tool has. So mill basically takes the naive pure function on the left. Here I'm using Scala pseudocode. I'm not annotating the types of the parameters, but you know what I mean. I take this is the same as eggs. This is a make tiramisu Python function I had earlier, but with some extra curly brackets and vals. And I convert it into a trait tiramisu module extends module. So this is spelled a bit differently. It's a bit more verbose. The function parameters become t.input definitions in my trait. The val intermediate vals become defs which with t blocks. These are often called targets in mill, using the same names terminology that Bazel uses. And references to eggs, beat eggs, sugar one, wine, and mixture become eggs parens, beat eggs parens, sugar one parens, and so on. So things are spelled slightly differently, and there's a small amount more syntax, but the fundamental structure of this mill tiramisu module and on the left side, this make tiramisu naive pure function, the fundamental structure is about the same. So how does mill use functional programming, but with these 4 requirements that we saw earlier? So first, let's look at introspectability. So mill turns the build steps, again, and they're called targets, into a free applicative data structure using the t curly brackets macro. So if I compare these 2 examples, on the bottom, I have the naive pure function. On the top, I have the pure function, but the vals become defs, and the right-hand side of each def, there's a t block surrounding it, and each variable reference eggs becomes eggs to the parens. So what does this funny syntax do? So it's a macro, but it's a very simple macro that does something that you should be able to understand. This macro turns expands into this kind of t.zip map eggs v1 goes to beat v1, t.zip map beat eggs sugar wine v1 v2 v3 goes to beat v1 v2 v3. Different frameworks call zip map a different thing. In Haskell it's called app, just like AP. I think in cats it might be called zip map, or it's like the TIE fighter operator pipe at pipe. But basically this transformation is often called idiom brackets. Again, idiom brackets are not a new thing. If you Google idiom brackets in Haskell, you'll see there's much prior work around it. But the idea is that I can turn this straightforward looking code with a small amount of annotation around the important bits into this kind of applicative zip map code. And in this case, I'm using a free applicative. So I'm not evaluating anything right now. It's not like I'm having futures and running them, or I have like an option monad and I'm propagating the option through the computation. What this free applicative zip map does is it simply constructs a graph data structure. And every node in the graph data structure has a list of inputs and has an opaque function to compute its output value from its inputs. So notably, the structure of the graph cannot depend on the computed value of any node. So this is very unlike monads. If you do functional programming in Scala, everyone talks about monads. This is one step weaker than monads. In monads, like if you're using a future, every time the future computes a value, you can use that value to decide what downstream computation to do, what downstream future you want to start, and so on. Whereas in this applicative or free applicative compute model, the structure of the graph is fixed up front. No matter what values come out of the beating of the eggs or the whisking of the mixture, the structure is as follows here. And this is very useful because it means I can completely ignore the computations and I can still do useful things to the structure of the graph. For example, I can introspect the graph to see what it looks like. Mill provides a visualize call, which will dump the graph to SVG for you to look at. I think Bazel does the same thing with Bazel query -- output equals graph. I think Bazel puts in it as a dot file. You can parallelize things by looking at which steps can happen in parallel and don't depend on each other. You can incrementally compute things by inspecting the graph, looking at where the values have already been computed and starting off from the places where they have not been. So these are all important things that the free applicative data structure gives us. And this is a very conscious choice. It's not that I just happen to anyhow choose a free monad because monads are what makes functional programming functional. I chose a free applicative because the free applicative gives us the ability to introspect the graph structure. And this introspection is exactly what a build tool needs in order to do its work. So that's enough about introspectability. Let's look at persistence. Every mil target defined via a T block, which is a target block, must return a type that is serializable. So in this pseudocode, I have def T. It takes in a type parameter V. The block can compute any value of type V, but that type V must be able to be readable and writable by upickle.default. And in this case, I'm using a upickle JSON like serializer, but it could be any format, doesn't matter. Upickle message pack, binary formats, Circe JSON, Jackson module Scala. The exact serializer doesn't matter. What matters is that the type of every target must be serializable. It could be a file can be written disk, could be a byte array. It cannot be an open TCP socket, because I can't just save an open TCP socket to disk and come back 2 weeks later and reload it. That doesn't work. What else do I need to do with it? Apart from how to serialize things, where do I serialize things? I need to store it somewhere. So every target, in addition to requiring serializability, it also takes an implicit parameter mil.defined context, which contains a context or destination file system path. And what this does is that it is provided automatically for every target inside the module. So if I have a mytiramisu extends module, the beat eggs target down here, this fellow will get automatically assigned a file system path out/mytiramisu/beat eggs. Mixture will automatically get assigned a file system path out/mytiramisu/mixture, and so on. We have nested modules, they correspond to nested folders on the file system. And this is important because it gives this context or destination path gives each target computation a place to put files on disk without risking collisions with other targets who may also be wanting to put files on disk. So remember that this is a build tool. We are compiling things, we are writing the disk, we are downloading things. You cannot avoid the disk when you're working within the build tool. And the problem with working with disk is that when you're working with a file system and I/O, often the problem is shared mutable state. I write to disk, someone else writes a disk, they stomp over my saved data, I get confused. I write over it again, I stomp over their saved data, they get confused. The shared mutable state is what makes writing to disk dangerous and sketchy. And mil does not get rid of the mutable state, but mil gets rid of the sharing part. Every target gets its own folder on disk, and every target can put things in the folder, save things in that folder, read things from that folder. No other target can interfere with it. And that's how mil makes file system I/O and persistence relatively safe, despite the fact that we are still reading and writing huge amounts of data to a shared file system. The third thing that mil needs to provide is long-lived workers. So mil provides a t.worker syntax. In this example, I am removing the hard-coded beat function, and I'm instead instantiating an egg beater worker that may be computed from somewhere earlier and using egg beater to beat eggs. So workers are similar to targets in that they can take inputs. You can pass in parameters to your worker. Your workers get invalidated if upstream targets change. But the difference is that workers, rather than being serialized and saved to disk, are kept in memory and last as long as the mil process lasts. By default, mil keeps a background daemon running, and the worker could last for hours. But even if you use mil in batch mode, the worker could still last several hundred compiles while compiling a large project before being shut down as the process exits. What do you put in a worker? Workers could be things like the Scala compiler. You want a Scala compiler to be kept in memory and hot. Well, you put in a worker, you can't serialize a warm Scala compiler to disk, right? What if you're managing a sub-process? If I'm generating PDFs, I'm using WebKit HTML to PDF binary. That binary has a significant amount of overhead that can be reduced by keeping it warm in memory in daemon mode using some flags. And who's going to manage the daemon? I can use an in-memory worker to manage it. And in effect, depending what what background you're coming from, workers are kind of like objects or kind of like first-class functions, in that you can instantiate them with parameters and then pass them around and call them on other things. The only difference between workers and objects and first-class functions in traditional object-oriented functional programming is that workers enjoy the same automatic invalidation that all targets do in MIL. But otherwise, MIL effectively has a first-class functions as part of the build system, and it works great. And this was the idea I stole from Bazel from my experience working with Bazel at Databricks. I guess before I go into ad hoc overrides, one more thing to mention about workers is because I can compute workers as part of the build system, it means that I do not need to hard code like environmental variables or environmental logic in order to do things. Let's say I'm running MIL, but I do not have a Scala compiler. Why do I not have a Scala compiler? Let's just take it for granted. I do not have a Scala compiler. Well, I could have a MIL target that downloads a Scala compiler from the internet from Maven Central. I could then spawn a worker that will then run the Scala compiler in memory, and I can then use that worker just to compile anything I want in my build system, similar to any other piece of logic I download. So in a build tool like MIL or Bazel, which MIL is inspired by, compilers, workers, linters, packaging tools, these are not special. These are just another target. Maybe they are worker processes, maybe they're not, but they're just another thing that you build as part of your bootstrap process as you go from nothing to a complete application. So that makes, if you don't like the Scala compiler that MIL provides, download your own, download the Dotty compiler. You want to compile Kotlin, go download the Kotlin compiler, put in a worker, and get to work compiling things. This is quite unlike SVT, where compilers and such are these magic environmental meta plugins that behave very differently from most of your SVT code. In MIL, compilers are just another build step, and they're kind of like a first-class build step, and they use them in downstream build steps. Someone on Twitch said they want to work for running a local DynamoDB instance. I don't know if DynamoDB can run locally, but I personally use workers to run local Postgres instances using the org.opentable.postgres test Postgres packages, and it works great. Next, let's go to ad hoc overrides. So sets of similar build steps in MIL are constructed using traits rather than functions. And what's useful about traits is that you can override anything you want in them. So I've eggs, sugar, wine as inputs. I beat eggs. I beat the eggs, sugar, and wine. I whisk the mixture to get the whisk thing. I can pass in different eggs, sugar, and wine. I could also pass in a different step of beating the eggs. Maybe I want to use pre-beaten eggs from a carton. Maybe I want to whisk things differently using, instead of whisking using a whisker, I want to put in the bottle and shake it. There are all sorts of weird ad hoc things that you have to do in any real build system. And it's no good to like shake your finger at someone and say, no, that's bad, you can't do it. Someone is going to need to do it. And the only question is, how painful is it going to be? And so MIL makes it easy for you to override things in your build. You want to change this here, change things there. It's okay. We are all adults here. We will let you do it in an easy and straightforward manner. So that's how the MIL build tool uses functional programming, but with a side addition of introspectability, persistence, long-lived workers, and ad hoc overrides. And these are the things that stand between a pure functional program and a high-performance, convenient, intuitive build system. So what have we talked about? We've talked about what's a MIL build tool. We've talked about what's functional programming, how build tools are similar to functional programming, how build tools are not similar to functional programming, and how build tools use how the MIL build tool in particular uses functional programming plus other cool things in order to do its magic. So what are the main takeaways? Functional programming is thinking about data flow rather than control flow. And this data flow graph is what makes refactoring, parallelism, program analysis, all that way easier than an imperative step-by-step side-effecting program. Things like monads, things like monadic interpreters or finely tagless, these are cool things you can do using functional programming, but they are not the core of what functional programming is all about. Functional programming is about data flow. And if you do a survey of the common functional programming languages, it's about the data flow. Build tools are also all about data flow. And these benefit from all the same things that humans enjoy when using functional programming. Build tools also need parallelism, refactoring, program analysis, introspection, all those things. But build tools have additional concerns that naive functional programming satisfy not at all. Build tools need introspectability, build tools need persistence, build tools need long-lived workers and ad hoc overrides in order to turn them from something that's a batch, inefficient batch process to an incremental, parallel, efficient build tool. And MIL uses a mix of functional programming and object-oriented features to get the best of both worlds. So MIL uses the free applicative data structure with idiom brackets in order to give us introspectability into the program graph. MIL uses the data flow graph MIL uses a program graph in order to give us the nice refactoring and parallelism analysis. But on the other hand, MIL also uses traits in order to give us the ability to template our build system. We have many modules with the same similar tasks to perform, as well as to let us override things ad hoc, because that's something that build tools often need to do. So we did not use these things randomly. It's not that, oh, I need to be functional programming, I'm just going to go and pick up a random category theory concept and use it. But I picked the free applicatives and traits specifically because these are the things that give us the tools we want to satisfy our build tool requirements. And as a result, MIL gives us code that's easy to read and intuitive as pure functional programs for the speed, efficiency, and features that people expect from a modern build tool. And that's how you get to build system easy mode, as one of my friends like to call it. So that's MIL, a build tool based on pure functional programming. One thing you may have noticed is I talked about compiling PDFs using MIL. That's something I've been working on recently for a while, and it works surprisingly well. You can use Scala tags to render HTML. You can render Markdown using the Atlassian Markdown library, and you can render PDFs using WebKit HTML to PDF. And I've been doing this because I've been writing a book called Hands-on Scala Programming, which apart from MIL, covers a whole bunch of other things to give you a practical project-based intro to Scala. So if you like what you saw in this presentation, you like the philosophy, you like the down-to-earth practical approach of doing things, you can go take a look at the website. It's not yet ready yet, but there's a subscription link for you to subscribe if you want to be notified when it's ready. It'll be done in a few months, sometime in summer 2020. So that's the talk, and I will take questions, I guess. How do I take questions? Q&A?
Yeah, hi, how are you? Thanks very much
Hey.
for the talk. I'm sure everyone agrees with that. It was a very comprehensive overview of MIL. I don't know if you can see the QA section, but I'm more than happy to read out the questions if you can't.
Could you read it out? It doesn't want to open for me. I'm clicking on it.
Of course, no worries. So the first one, quite an involved question, actually. So you explained that the target graph has a free applicative structure, and the structure can never depend on the values of the inputs. This question is like, so sometimes we do need to escape that mechanism, and in SBT there is the mechanism for the normal applicative structure. Is this something that MIL does support, and if yes, kind of how?
So the normal applicative structure also cannot depend on the value of the structure of a normal applicative also cannot depend on the value of its inputs. SBT goes beyond that and allows some like monadic structures where it does depend on the value of the inputs. MIL does not support that. So what MIL lets you do is that if you look at this bit of MIL code here, whether the macro-based version or the desugared zipmap-based version, we are constructing the graph at runtime using Scala code. So as part of constructing the graph, we can run Scala code before the graph is constructed in order to decide what we want the graph to look at. And this is used, for example, for cross builds. Maybe you want one module per folder, and a cross build lets you do that in an easy manner. But once the graph is constructed, the shape is fixed. So you effectively get a two-stage computation. One stage, run whatever Scala code you want, and then it constructs a graph. And the second stage, we do this incremental thing over the graph in order to give you a final output. And in the vast majority of cases, the first stage is trivial with not much logic going on. But you can put logic there at the cost of maybe slowing down every MIL command, since you have to reevaluate that code more frequently. This two-stage architecture is a similar architecture to how Bazel works, for example, which also has separate analysis and execution phases. I think that answers the question.
Yeah, okay. So I think we've got time for one more question at least. Someone's asked, what's the overhead of the MIL daemon in terms of like threads, memory, CPU?
I think it's basically up to you. There's like a bash command which spawns it off, it passes in some parameters. I don't believe we customize it, so it probably just uses the default JVM settings on your computer, which works okay. If you want to give it more memory or less memory, I believe there are flags you can pass in to adjust its configuration.
Okay, cool. And another question is it possible to set up multi-project with Mill, with one of the sub-projects being a Scala JS project?
Yeah, so if you go to the Mill documentation, I believe there's an example with Scala JS. If there isn't, you can go look at some of my projects. For example, the Fansi library, FANSI. That fellow is a very, very small one file Scala JVM, JS, and native project. And you can see how the cross build and stuff works. You can also do like client server style Scala JS, Scala JVM projects as well. And we can help you out in the Gitter channel if you need help.
All right, cool. Well, thank you very much again. I'll give you some applause since everyone else can't.
Cool.
I've just posted a link to the Q&A room in the chat on Zoom. If you could go into there, I think one of the other track owners is going to be in there to help you out. And if anyone has any extra questions, then they should be able to go and see you there.
Link to chat.
Oh, sorry. Can you not see the chat?
I think I can see it. I'm opening it right now.
Okay, I could ping it you on Slack if you want.
Hello. Holly is here. Just want to remind our attendees, if you want to ask more questions, join Lihayo at Spoken QA session. I believe Chris just posted this link, so just move to that room for the break and talk to Lihayo. This is the first session, so I was just want to remind you that we have spoken Q&A as well.
Hi, Zainab. Are you able to share your screen and share your slides with us?
Hello, I'm gonna give it a try.
Okay,
Can you
cool.
hear me? Oh, good. Means you can. All right. Okay, I think it's that one.
It does say you've started sharing. I can only see a black screen for now, though.
All right, shall we wait for it a bit?
Yep.
Ah, okay, hang on. It says I need to bring my shared window to the front. Let's see.
Okay, that's looking a lot better already.
Right, just a second. Okay, can you still see it?
I can, but I don't think I can see the whole thing. I can see like the left-hand side of your Explorer window.
Okay.
That's better. I can see everything now.
All right, can you still see everything?
Yes. Yes, I think so. Do you want to go to the next slide just to make sure it's?
Yep, just a sec. Sorry, fiddling around with this speaker view.
No worries.
There we go. You can see a few slides.
Yep. Yeah, I think we can see everything that's on them. We can see the top of your Explorer window as well. I don't know if that's something you're bothered about. We can see your bookmarks.
Gosh, let's see if I can. How do I hide this thing? I'm on a laptop which I hardly ever use. No, that's not what I want. I don't particularly care about the bookmarks.
I don't know. Can you go into full screen mode with it, or is that the thing you're trying to avoid?
I can, but I think I can still see the bookmarks here on full screen mode. So
Yeah. I know. This does look a bit clearer. Like there's less of the screen areas taken up by the tabs and the bookmarks in this view.
okay. Oh, here we go. Bookmarks. This is a bookmark, this tab. I don't want to do that. Oh, hang on. There's something there. There we go. We can tick that. At least that's gone.
Oh yeah, that's good.
Okay.
Okay.
Interesting. So you said that you could see less of stuff. So does that mean that if I unfull screen this, you're seeing something different?
So it's basically the same view, but the tab and the address bar is much bigger. It's taken a much higher proportion of the screen.
Ah, okay. You know what? I wonder if I can just try and full screen this thing entirely.
I mean, we are about a minute away from starting, so I don't know if you want to just switch to the other view and we can live with it, or.
Yeah, we can, definitely can. Cool. All right.
Okay. Cool.
Okay, can you see me as well? I don't think you can. Hold on.
No, it doesn't look like you're sharing your video.
Oh, here we go.
There
Start
you go.
video.
I can see you.
Cool.
Okay.
All right. Okay.
All right. So yeah. So for everyone just joining us, welcome again to Scala Love, and this is the Joy track. For those on Zoom, you can ask us questions if you want on the Q&A section. That's should be an option at the bottom of your client. I am trying to actively monitor Slack and Twitch as well, but primarily I'll be looking on the Zoom Q&A section. If there are questions and we run out of time, I will post a link to a breakout room that our speaker will join afterwards, and then you can go and have a bit of a more interactive session with them then. Now it's my great pleasure to announce our next speaker. This is Zainab Ali. Zainab's a functional programmer, an open source contributor, and she's also the organizer of the London Scala user group. She enjoys learning lots of new programming languages and bringing their ideas into the Scala ecosystem. And today we're going to join her in exploring programming languages used in teaching and how their ideas could influence Scala. So over to you, Zainab.
Thank you, Chris. Okay, thank you everyone for coming. I'm going to be talking about meta teaching with Scala Meta. Now, I want you to imagine that you absolutely love functional Scala. In fact, don't imagine that. You're at Scala Love, which means that you do absolutely love functional Scala. And I want you to imagine that you have a colleague at work called Zeno, and he's not a functional Scala developer, but he is kind of interested in functional programming. And every day you're pretty good friends with him. You've been evangelizing to him about functional programming. You've been telling him how great it is and how he definitely needs to learn it. Now, Zeno's had a lot of time recently. And one day he comes up to you and he says, I want to learn functional programming properly. Can you recommend me some resources? And you're absolutely ecstatic. You go to your bookshelf, you take a look at all the books that you have. There are books that you started learning Scala with yourself and ones that have come out since. You take all of those and you pile them up, you give them to Zeno. Then you think about all the things that you usually listen to, all the podcasts. Scala Love, he has to listen to Scala Love. So you go and you download all those on his phone. And then finally, you go and look online and find, there's a huge wealth of resources available. Not only are there a ton of blog posts that he can go and read, there are also a ton of exercises, there are the MOOCs, so many things. So you make a huge long list of all of these things, and you throw that list at Zeno. He's a pretty nice person. He says thanks, and he goes off. Now, a week later, Zeno comes back to you and he says, I've been reading your favorite functional programming book, but I'm finding this a bit hard. I haven't set up my IDE, I'm using Scala exercises, and I'm getting stuck on fold. Can you help me with fold? So you say, of course I can. And you go and you have a look at the thing that he is getting stuck on. You go to scalaexercises.org, which is a site with a lot of Scala coding problems, and you can solve these problems interactively. You go and you take a look at the specific problem that he is getting stuck on. It's called fold right, and a quick glance shows you that the answer to this problem should be a list of 1, 2, 3. But Zeno is convinced that what he should get is a list of just 2 and 3. So you ask him to explain what he thinks fold right should be doing. And he uses terms like recursion and pattern matching. And as he's explaining this, he sounds quite confused. And as you listen to his explanations, you start to wonder what went wrong. Why is it that Zeno is so confused about this particular definition? Maybe there was something wrong in all those books that you recommended him. So you go and you have a look through the books, you read them again. They seem really logical. Their explanations are very well thought out, step by step. Why is it that Zeno doesn't understand those explanations? Well, Zeno's not unique in this. He's not the first person who's found functional programming challenging to learn. Now, maybe what we need to do here, if we observe Zeno, we can see that he's finding this difficult, and we assumed that he would be able to learn functional programming based on the resources that we gave him. Now, if an observation doesn't match up to our assumptions, we should start to question our assumptions. Maybe the assumption that we should start to question is that Zeno would learn based on all those resources that we gave him. So what we're going to do today is go back to the drawing board. We're going to explore different ways in which Zeno could learn. In doing this, we're going to go and explore other programming languages. We'll take inspiration from languages specifically in the field of teaching. And while we're doing that, we'll find that we'll need to dive into metaprogramming, into programming itself. And along the way, it will get very meta, and hopefully we will understand understanding itself and find out why Zeno's having so much trouble. So in your search to be inspired about teaching, you go to the MIT Museum and you look in some of the display cases and you find this thing. Does anybody know what this thing is? You can type it in the chat, if I can find the chat. It's a mouse, someone says. Really? We're not sure what this is? Oh, okay. So this is a Logo turtle. The Logo turtle, some of you might have heard of Logo. It's a teaching language used to teach children mathematics. It was specifically used around the 1960s, but it's still in use today. And the way that it works is that there's this little robot called a turtle. And it has a little pen under it, and the turtle moves, and as it moves, it draws. You program the turtle to draw pictures. So a lot of people look at Logo and they think, well, that's just for kids, isn't it? I mean, it's just a load of gimmicks. There's a turtle and pictures. How could that possibly be applicable to us? But there are certain things that Logo does do, which are pretty important. If you look at the picture that this girl is drawing, it looks like it might be a teddy bear. She didn't start off drawing teddy bears. She started off, most likely, drawing lines. And after she drew lines, she could draw circles. After she drew a single circle, she probably drew several circles in different places, and then she drew some of different sizes, and eventually she found that she could draw a teddy bear. Now, this technique is what we now know as iterative refinement. It's a technique for problem solving, which is commonly used in the sciences, where you take a problem that seems too big to solve. You boil it down to a single core aspect of it, try and solve that core aspect, and if you fail, you keep trying. And once you've solved it, you make the problem slightly bigger. You add another aspect, and you repeat, you try and solve it again. There are a few crucial things about this. One is that you are expected to fail. So along the way, you need to have a lot of feedback. Another thing is that when you do fail, you'll know exactly what you failed at because it must be the aspect that you've added. So can we apply iterative refinement to the problem that Zeno is struggling with, to the problem of fold right? Let's take fold right and boil it down into 3 iterations. They're going to have slightly different signatures to fold right, so we won't call it fold right, we'll call it collapse. Now collapse, the first iteration is one which has the match statements included. We want Zeno in the first iteration to be able to call collapse recursively to collapse this list, to fold over this list. And we want him to sum these numbers. In the second iteration, we're going to ask him to write this pattern match himself. So he's going to need to recurse over the list and pattern match. And in our third iteration, we're going to go to higher order functions. So he's going to need to do this, but with another function. And we'll see if this helps Zeno learn. Now, in order to do this, he's going to need to get set up with an IDE. We're going to choose to set him up with VS Code so he can play around with this locally. The other thing that we're going to do is write him a Scala program to give him his very own tutorial on fold. And what that program is that it has a Scala backend. It's got a nice front end in Scala.js, which looks very friendly. it will just write this exercise, this collapse function, to a file that he can view in VS Code and fill in. And once he has filled that in, he can click check and go, and this tutorial will go and test what he's written with Bloop. And it'll come back and it'll display the results. We can quickly take a look at what that might look like here. So this is Zeno. He's going in, he's filling his first exercise. We've given him some tests which say that he should collapse an empty list to the number 3. He's trying, no, he's not right. He's got one of them right. If we fast forward a bit. Yeah, so Zeno's now filled in the problem. We're going and checking, and yeah, he's got this one right. Okay, we've now given Zeno his own full tutorial. He's gone and he's going through it. How did he do? These are our iterations again. Zeno's filled them in. In the first iteration, he's got it completely right. He's able to call collapse recursively. But he gets stuck on the second iteration. He calls collapse, but he does not see that he needs to pattern match on this list. He completely misses the empty case of the list. This is really strange, isn't it? Because in the first round, he saw the pattern match. He knew that that was part of the solution. Why didn't he use it the second time round? And this is a really interesting question. Why is it that somebody who is an expert or slightly more experienced than Zeno in functional programming can look at this signature and immediately know that they need to pattern match, that they need to decompose this list based on its structure, and that Zeno doesn't? And this is something that's being heavily researched in computer education. Most people think that it's to do with some idea of pattern recognition. That is, that somebody who is experienced in a particular subject has just built up a huge bank of patterns and knows how those are related so that they can pick the exact pattern to use in the exact situation. A lot of people will be able to look at this signature of collapse and just know that they need to use a pattern match to destructure the list. But Zeno hasn't learned that yet. Okay, so how can we teach Zeno about pattern matches and all the cases in which he can use them? Well, one way of doing so is to just give him a load of pattern matches. So here we have come up with the collapse function again. It's basically the first exercise, but we've come up with lots of different variants. We're collapsing not only lists, we're also collapsing options. We're going to ask him to collapse a list with different functions, not just sum, but also multiply. If you look at this code here, you'll see that there's actually a lot that's shared. In fact, of course, there's a lot that's shared. We're trying to get him to recognize a particular pattern. That pattern should be shared. If there's a lot that's shared, is there a way for us to generate these things? Remember that the way that we're generating these exercises is that we have this, this full tutorial program, which is written in Scala, and we're just writing some strings to a file. So what we can do is that instead of just taking a single string, writing that to a file, we can just reuse parts of this, this definition of collapse and put that inside a function. So in order to create all the different iterations that we want Zeno to go through, or all the different variations of this problem, we can just call this problem function that we've written with different strings. So this takes in a string for the input type, which might be something like option int. The output type that he's collapsing to, that might be something like an int. The name of the parameter, because this is going to be different depending on the type, and the different patterns that he will need to match. Okay, so this is quite nice. It means that when we are generating all these different problems, we can reuse a lot of code. But using strings isn't all that great. Really, what we should be trying to do is use data types to represent these things. So instead of just having a string that's a type, let's have a data type, a case class. to represent a type. And let's do another one for pattern and another one for a parameter name. And of course, we'll need to validate these two so that if we accidentally try and create a type out of something that's an empty string or something that's just a string containing spaces or anything that's not really a valid type, we want to throw an error. So we want to have some validation. So we need a validation function. And this is starting to get pretty, not necessarily difficult, but there's a lot of boilerplate in here now. What we're basically doing is describing Scala's syntax tree in terms of algebraic data types. And maybe somebody's already done this. Well, a description of Scala's syntax tree in terms of algebraic data types is basically what Scala Meta is. Scala Meta is a library, it's a meta-programming library for Scala, which describes the Scala syntax tree, it models it, and it also has all the validation based on that tree. It has other things as well. The best way to really explain what Scala Meta is, and in fact what the Scala syntax tree is to go on ASTExplorer.net and play around with a few syntax trees. So for example, this is the syntax tree for collapse. If you write a collapse function, you can write it on the left on AST Explorer, and you can explore what the Scala syntax tree actually looks like for that. So it might be a block with a match statement, and that might have a few cases in. And this is basically what we're trying to model. So instead of just using strings to describe these things, we can use data types, and instead of writing these data types ourselves, we can use Scala Meta. Now, using Scala Meta, the data types look pretty similar to the ones that we defined. Scala Meta exposes a type, it exposes a term name, and it exposes a pat for patterns. It also has interpolation here. You can see this quasi-quoting with Q and also patterns with P to create the syntax tree. And it's really easy to just go from that tree to a string that we can plonk in our file. Now, the cool thing about this is that now that we have a function which will generate a tree for collapse, we can go even further. We can make this a randomly generated tree. We can have a series of types which we know can be collapsed or folded over, lists and options, but we can also throw in non-empty lists in there. We can have a whole series of base types like strings and integers, and all sorts of different functions that we can use for collapsing, like multiply and sum. Even other ones that are in there, and generate a series of problems randomly, which follow the same template that we want Zeno to recognize. So this is Zeno going through the collapse function. He's just writing a load of, oh, he's solving problem 2. Yep. And he's writing the code to solve this problem. And this code itself was generated using Scala Meta. We also generate some tests too. You can do that in the same way. Okay, so we've given Zeno all these problems that he can work through, which all follow the same structure for him to be able to recognize pattern matches. Now that we've done that, surely he should be able to write this collapse function. He should know that he needs a pattern match here. See how he gets on? Well, no. He does try and use a pattern match. He's almost there, but he gets this error. It says missing parameter type for expanded function. The argument types of an anonymous function must be fully known. SLS 8.5 expected type was int. And he's pretty confused at this point. He's pretty sure what he was doing was right. Now, what Zeno's stumbled on here is not pattern matching, but in fact, a completely different Scala construct called a partial function. And the compiler has assumed that he has meant to write this partial function. A lot of people, when they see the compiler giving error messages like this, start to get a bit annoyed and frustrated and think, well, it needs to output better error messages. But the thing is that The only reason why we're saying that is because we know some additional information that the Scala compiler doesn't. We know that Xeno should not be using partial functions. In fact, when you think about it, there's a whole host of different features which are present in Scala because it needs to be a complex enough language for people to use to create things like the tutorial that we've created for Xeno. There are a whole host of features that it has which Xeno doesn't know about yet, and he might accidentally stumble upon as he's learning. Really, when he's learning, we want him to stick to a very small subset of Scala. That subset should just contain basic functions, pattern matching, and concrete types. And there are all these other things like dependent types and implicits and partial functions that he could stumble across either accidentally or get confused about. Is there anything that we can do about this? Okay, let's go and look for some more inspiration. And we can take a look at the language of Racket. Now, Racket is a Lisp. It's a Lisp which is used in teaching, but it is also used to create some things in production code bases. And the reason why it can span all those different aspects is that it has this idea of language subsets, or teach packs in Racket, in which you can define a very small subset of the language that somebody will work in when they solve particular problems. For example, you might say that when someone starts off programming in Racket, they should only deal with pure functions and very basic functions at that. You can then slowly expose them to higher order functions. And after you expose them to higher order functions, you can walk them through I/O. And after you've done that, they can see the full language of Racket. Maybe they can even go and do some meta-programming in Racket. Okay, is there a way for us to achieve this in Scala? Well, let's see what we can do. We have this tutorial that we've made, which is, so far, it's just writing a piece of code that Xeno needs to fill into a file, and it's going and testing that code. What if we read that file as well and pass it into a Scala meta syntax tree? What if we could get the syntax tree of the answer that Xeno has submitted? Well, if we did that, we could write a load of checks on that tree, also using Scala Meta, to check that Xeno was only using the features that we wanted. In fact, we can even check specifically for partial functions and construct a list of banned features that we don't want him to include. If Xeno's answer contains partial functions, we can do something else. We can reject this answer. So these are the functions that you might write using Scala Meta. They're very simple. Scala Meta has tree traversal functions, such as this one, collect, which will just go through all the nodes in the tree and perform a particular, in this case, it's a particular test. And it will output anything that passes that test. Now, the great thing about this is that if we're checking for very specific features, we can also construct error messages based on those features. So if Xeno uses a partial function, we know that he's not meant to, we can write, you've forgotten to write match. And that's a lot more descriptive to him. He understands this a lot better than he understood the first error message. Okay. Xeno's now been able to solve the second problem. He's stormed through higher order functions. He's now ready to see the definition of fold right. And this is what we show him in the fold tutorial. He should be really happy at this point. He should be have this kind of light bulb moment where he understands what fold right is. But that's not what happens. So Xeno sees this signature and he gets confused. He gets confused because he's been working in quite a small subset of Scala, and there are a few things that are in this that he hasn't seen before. For example, he hasn't seen type parameters, and at this point, he's probably forgotten what higher order functions are. Is there anything that we can do as we're expanding this language subset to help Xeno along? Well, I think we can. We have this list of features, which we know Xeno shouldn't be using. And we have a load of checks to test for those features. What we can do is take any code snippet that we are going to show to him, check that that code snippet has any new features, and if it does, display something more descriptive. And this is what that more descriptive thing might look like. Let's say that he's seen fold right, he's not quite sure about some of the syntax in there, we can explain what a type parameter is, if he's not seen type parameters before. We can give a more descriptive version of what a higher order function is. And we can do this knowing that those things are in the code because we've just checked that code with the Scala meta. Okay. All right, so now we give this to Zeno. He sees the signature of fold right. We send him back to Scala exercises and see if he can understand this problem. And he can. He can go and solve this problem. At least he gets the answer right. But he comes back to us and says, I still don't understand what a fold is. I understood monads when I read that burrito analogy. Can you explain how to fold a burrito? Okay, so the burrito analogy is an analogy that people sometimes use to describe monads. It's been one that people, to be honest, have made fun of a lot, where you take the signature of flat map and you try and construct an analogy that in building up a burrito and adding new things to it, you're flat mapping the burrito. You can go and look it up. But the thing that I want to concentrate on here is not so much the burrito analogy, but Zeno's word understanding. He says, I still don't understand what a fold is, but what does that mean? Well, to understand a fold would really mean this. It would mean that Zeno would be able to, given a certain input to fold right, be able to predict what that output should be based on how fold right should evaluate. And he should also be able to go out there in the world and recognize different patterns that correspond to the pattern of execution of fold right, and be able to then refactor those things into what fold right might look like. And there are a few debates as to how he could do this, but I think the thing that most people converge on is the idea of a notional machine. A notional machine is, you can think of it as a mental model of the way that a computer executes. Notional machines that people conventionally have when they're outside functional programming are things like a stack and a heap. Or maybe if you're in various worlds in object-oriented programming, you might think of a load of objects which are talking to each other by message passing. Now, the notional machine of functional programming, the idea of execution, at least for basic functional programming, is actually just that of functions. And by functions, I really mean just functions. A lot of you have probably been teaching your kids recently, if you're doing some homeschooling. Now, if you go up to a kid of around the age of 12 or 13 and you ask them about some basic algebra, you write down these two functions, f of x is equal to x plus 1, and g of x is equal to 3 times f of x. You ask them what g of 2 is, this is what they'll write down, if they're good at maths. Well, they'll substitute g for x. They'll say it's 3 times f of 2. They'll substitute then f, and they'll say, well, that's 3 times 2 plus 1. And then they'll start evaluating. They'll say that's 3 times 3, and that's 9. Well, it turns out that we really can do the same when we're thinking about functional programming. Let's say that we take fold right. We're folding over this list of 1, 2, 3. We take one step, we substitute the definition of fold right. That boils down to cons 1, cons fold right again. We now substitute fold right. We basically check this list of 2 and 3 on fold right. And that boils down to this. And then we can take another step, and that boils down to this. And we get a list of the elements 1, 2, and 3. And if Zeno walks through all these steps, then maybe he will have a better notional model of what fold right is doing. Now, Racket has a really interesting tool inside it called the algebraic stepper, designed by John Clements. And this is what it looks like. Don't worry if you're not too familiar with Lisp. You don't need to consider about what all the Lisp is doing. You just need to look at the purple and green parts and see the steps. We can step forward and step back into our functional expression. Another interesting thing about this is that the definition of fold right that you step into doesn't necessarily need to be the actual definition of fold right that's defined on your list or on your option. The stepper has a few definitions which are pre-prepared, which it steps into, which simplify things. Well, is it possible to create a stepper for Scala? Well, we can't do that just using Scala meta. We would need a meta tree, but we would also need other things. We would need to substitute a function for its body, which means that we need to go and look up where that body is. Now, I reckon that we could do this if we use something like semantic DB to go and look up the positions of our functions. We'd also need an evaluator. Now, while it's true that you can't evaluate general Scala code, let's say that you do have just a small subset of your language, you can probably define a small custom evaluator for just that subset. So even though we're not at a Scala stepper yet, I don't have one to show you, I'm pretty sure that we could get there. Okay, we've gone and we've explored all the different ways in which we could help Zeno learn. We started off with iterative refinement, which we took from the language of Logo. We explored pattern recognition to recognize very specific patterns. And we used Scala meta in order to generate some of those patterns. We also took a look at how we might achieve language subsets and limit Zeno to a very small subset of Scala while he's learning. And after that, we looked at context-specific errors, which you could generate if you were only using a specific subset. We then also even created syntax guides to help him when he saw code snippets which contained features that he wasn't too sure about. And we explored the idea of understanding itself with notional machines and how we might go about developing a notional machine in Scala. And after all this, after we've stepped through fold right enough, maybe Zeno will understand it. He'll say, well, folding a burrito is collapsing a burrito based on its structure. It's more like eating a burrito. Maybe this is true in his head. Maybe it's not. Maybe this notional idea that folding a burrito is more like eating it is something that will get dispelled later on as he does more and more folding. But for now, perhaps it's enough of a notional model for him to get along with. Okay, thank you for listening. I want you to leave this talk with basically just the takeaway of having more ideas. What we've done here is that we've explored a whole host of ideas. Some of them may work, some of them may not, and we've tried to see how we can apply them to Scala. And to be honest, most of these ideas, I came up and found these in the space of less than a week, just by looking at other languages. I'm pretty sure that everybody here would have a ton of ideas of how we might develop tooling in order to teach Scala better. Now, if you're interested in teaching, go to Noel's talk later on today. Noel, Ellie, and Yifan are going to talk about bringing Scala to a diverse group of students. It's a panel discussion, so it should be pretty interesting. If you're interested in any of the ideas that we explored in our tutorial generation, you can take a look at Kongzi by Yilan Wei. There's a link on these slides. And it's basically a melting pot of different ideas for generating tutorials. It's I would say that the code base is in a bit of a state at the moment because I committed quite a few things there in order to explore some of these ideas in a rush, but we're cleaning it up. Now, if you're interested in reading more, there are a few posts which are really interesting, such as Tips for Teaching Scala by Noel. And there's also, if you really want to go and learn more, go and read How to Design Programs, which is actually a course aimed at teaching computer science students programming. Okay.
Cool. Thanks very much for that, Zainab. It was a really fascinating talk. Unfortunately, we have run out of time for questions in this room, although I can't actually see any. But I am going to post a link now so that people can go and join you in the breakout room for an interactive Q&A. Lots of people saying thank you on Twitch and also identifying a lot with the character Zeno. I think a lot of people feel like or have felt like him before. Just a reminder to anyone that missed it, if you could go to the breakout room, there is a link in the chat session. And yeah, thank you again, Zainab. And if you could move over to the breakout room, that would be great.
Okay,
Cool.
thank you
Very much. Hi, Kai. Do you want to start sharing your slides and everything, just so we can get set up before the talk?
Yes. Okay. Can you see the slide screen?
Yeah, looks great, and I can see you as well, so that's also helpful.
Okay. Okay, it's one screen with one big slide, right?
Yeah.
Yeah.
Yep, it's looking good.
Okay, and is the sound okay? Like no interruptions or anything?
No, you sound very clear. I can hear you well.
Okay, that's great.
Yeah, I'll introduce you and everything about a minute before and go through the usual sort of like what
Yeah, got it.
where people ask questions, etc.
Hi, Kai. How is it going?
I'm fine.
Ready to present about team productivity?
Yep.
I'm happy to listen to you and learn. All right, good luck. Break a leg.
Thank you.
Yeah, I have to say, Kai, you've got the most people saying hi and good luck and everything on Twitch and Zoom and everything that I've seen so far. Clearly a very popular guy.
I have no idea. I mean, if you want to send population phone network, because I don't have no phones.
People saying that they just enjoyed D-Stage.
Really? Okay, that's great.
Okay, I think we may as well start there. So welcome to everyone that's just joined us. This is the Joy track for the Scala Love Conference. Just a little bit of housekeeping. Please do post your questions to the Q&A section if you were on Zoom. And if you're joining us via Twitch, please just post in the chat there. I am trying to monitor that as well. And at the end of the talk, if we run out of time, there will be a link to a breakout room where you'll be able to have a much more interactive session with Kai. And yeah, so now I'll introduce him. Kai is a software engineer at Septal Mind. He maintains and contributes a lot of open source Scala libraries. Some of you may know him from his work on the Azumi family of libraries like DStage, Logstage, Idealingua, and by his and Septimal Minds addition to Zio, such as Zio Tracing and Azumi Reflect. Now, Kai's going to be talking us through Scala, functional programming, and team productivity. Over to you, Kai.
Hi, and thank you for coming. Originally, I was supposed to give this talk together with Pavel Shirshov, the founder of Septimal Mind and great Scala developer. However, he's been too busy to join, so I will get both parts of the talk. As a disclaimer, most of the ideas that are presented are his. So the title of our talk is Scala, Functional Programming, and Team Productivity. It's a war story, a chronicle of what we went through in order to radically improve the development process at our client's company. Okay, so first of all, let us introduce ourselves. We are Pavel and Kai, and we are from Septimal Mind, an Irish software development consultancy. We focus on productivity of engineers and team efficiency, and we're big fans of Scala and purely functional programming. Also, we participate and contribute to a variety of open source Scala projects. As a consultancy, what do we do for our clients? We identify productivity issues and blockers in their software development pipelines, and we create tools to address those issues. Now, it's important to not try and reinvent everything, so we decided to commit to a new tool. Only a single engineer can deliver a working prototype in 2 weeks or less. So let's start with our story. This client, we started working with them in January of 2018. They have millions of users and about 100,000 new installations each month. When we started working together, they had about 30 engineers. The backend consisted of about 10 microservices in multi-repos, some written in Scala and some written in Go. On front end, they've had several mobile apps and a complex web portal. It's also worth mentioning that at the time they were using Scala as Java Plus with Akka HTTP and Juice, and also they had C#, Go, and TypeScript at various points in the stack. So by June of 2019, we managed to reduce their development costs by 50% according to their own estimation. That number was quite impressive when I heard it. I'm going to tell you what led to. You can't actually squeeze a 50% improvement out of an already great process. These numbers appear when you're getting rid of blocker issues. So what was that big blocker holding the team back so much? Late problem detection. The actual integration of the product has been happening only in production. Lots of issues will manifest only after deployment, such as bugs, API incompatibilities between microservices, and incompatibilities between front-end and back-end. The team didn't have enough insight about their product, and it was hard to debug problems after failure. And it was hard to just observe the entire product at once because the code was spread across about 13 repositories with one for backend and 2 for ops. And plus, it was always painful to bring new people on board. A new engineer had to memorize a lot of arcane rituals and set up a lot of stuff before they could get started. I'd say that the primary problem was lack of real continuous integration. And by continuous integration, I mean the full original meaning of the term, that is, automatic testing of all integrations between components after each commit. And it isn't just about running the builds automatically, that's just the beginning. Most of our integrations these days are with other services that are outside of the code base you can't check with your compiler. The problems I mentioned are fundamental, and at some level they will always be present in working software, but we did manage to improve the situation for that team somewhat. What did we do first? We introduced our own interface definition language to automatically generate compatible type-checked interfaces for remote calls between all components of the product. microservices, front-end and back-end, clients and servers. We added better insights using our own structural library log stage. We helped the team set up a better Git flow and move to a monorepo, which in this case was very beneficial. We've put a lot of effort into improving code quality. We've taught the team purely functional programming and adopted tagless final style with bifunctor effect type across the code base, where bifunctor means typed errors, no thrown exceptions, for better control of the errors that happen everywhere. As part of that, we implemented state-of-the-art asynchronous stack traces for Zio. The Zio tracing mentioned by Chris before. Before, using PRFP and asynchronous programming in Scala meant having to say goodbye to stack traces, and that was a blocker for adoption of PRFP in the team. We just had to fix that. But I believe the most important items are next. So for the rest of the presentation, we'll talk about the things in bold. That is, we've added fast and reliable tests and integration tests. We've reshaped the backend into a so-called flexible monolith or a multi-tenant application, which was the key for complete continuous integration. And by doing all that, we greatly simplified onboarding of new hires. So here is a summary table of key problems we identified and the solutions we applied. For now, let's focus on tests and microservices. What was wrong with the tests? First of all, their speed. There were some 600 tests, which required about 20 minutes to run. And of those 20 minutes, about 17 was for component startup and shutdown. And it was hard to run the tests in parallel because of the interference between tests modifying the same records in the database and conflict and breaking each other. Then the external dependencies were slow and hard to set up. And then it was hard to wire the applications with dummy in-memory implementations because Juice. While Juice has overrides, it requires a lot of manual rituals to wire a test with dummy implementations. And what was wrong with the microservices? First of all, it's hard to share and reuse code between multiple repositories. Because of that, multiple copies of the same code appeared in different repositories. It was easier to just copy and paste rather than spend time moving the code snippets into a shared library and then publishing it locally. You could wait, or you could instead wait for a CI to build and for the artifact to appear in the repository. That would also take time, probably more time than it would take for you to build it locally. All that was very far from instantaneous. Then the company had one shared dev environment for all the teams because it was hard to set up the same stuff and set up databases and other stuff and configure it. We tried to correct startup and shutdown procedures, have to take care of many different aspects like action order, configuration variability, preconditions checks, etc. It's notably hard to implement all of that by hand. So our goals were to improve development and deployment workflows and start continuously integrating the entire microservice fleet. Also to improve team collaboration and simplify onboarding. Well, how? The key idea was to merge the many components of the product into a single highly reconfigurable application. We wanted to make the integration process more declarative and let engineers define their product as a set of components and goals and make all the wiring completely configurable and automated. We call this automatic application composition. We're going to show you the open source framework that makes automatic application composition possible. And with it, it allows you to, first of all, test your business logic with dummy implementations and then also test it with real external implementations so that you can check that your logic works very fast and then separately check that your integrations work too. Moreover, it makes writing such dual tests an easy and a natural thing to do always. It lets you correctly share heavy resources between all the tests across an entire mod, not just in one test suite. So test suites can run way faster because you're not starting and stopping the same heavy components over and over again. And you don't have to manage any kind of global mutable state to do this. It lets a new developer check out and start hacking and testing immediately as a consequence of having tests without implementations. You don't need a dev environment to start working. And then it lets front-end engineers set up their own isolated development environments quickly and easily. And you guess that the name of the framework is DStage. Let's see it in action with an example application. This application will have a repository interface with the dummy implementation and the production implementation. Then we have a service class that uses the repository and an application entry point app that in turn uses the service. We're using bifunctor tagless finals, so we have an effect type app with two parameters, where the left parameter is the error type. In app run method, this is a throwable, and the right parameter is the output type, which is app run, which in app run is a unit. Now we may declare our application components in juice-like style. We declare that there will be an app f and a service f. And also there will be two possible implementations of repository f, the dummy repository and the prod repository. We declared one of them to be repo dummy and the other to be repo prod. Tag them. This code on screen is enough to launch the application. Note that here we specify an activation. An activation is a list of choices that tells our application which implementations to choose for those components we declared that multiple implementations for. We declare that we want a repo prod implementation for all repo components. In this case, that means that the application will use prod repository as the implementation of the repository interface. We're also using 0 as our app type, and we parameterize the definition accordingly. So DStage application is a set of recipe declaration. Each recipe takes a set of materials or values and produces a product, which is of value too. In order to turn these recipe declarations into the actual application, you need to provide a set of root products that depend on everything else and the appropriate configuration rules. All the wirings will happen automatically right before the program starts. And moreover, the wiring is computed ahead of time into a value. So you can look at it, print it, or check it for errors without performing any actual instantiations or any effects. Like Juice and other dependency injection frameworks, DStage allows you to turn application wiring code into a set of declarations and automatically order wiring actions. But actually can do much more. Let's look at our application declarations again. There are two definitions of the same component, a dummy repository and a production repository. Both of them implement our repository interface, but they are tagged by the so-called configuration access values, repo.dummy and repo.prod. There may be several configuration accesses used by our application. When we start our application, we'll have to define preferred values for all the accesses that are used in the wire. So in our example, we have one access, repository access, and we wish to run our application with production repositories. So the dummy repository declaration will be ignored. Dummy repository will not be instantiated. You may declare a lot of different implementations for different interfaces and easily reconfigure your application. So this application will now use the prod repository everywhere where a repository app is required. Another important concept supported by DStage is resource. A resource is a functional description of a component lifecycle, which allows you to express startup and shutdown of a component without resorting to a mutable state and without allowing objects to have an invalid, uninitialized state. Resources can be wired into the object graph. Their life cycles will be performed according to the dependency order, and they will always shut down gracefully, even in case of an exception. We also provide a way to use Docker containers as resources and a small library of typical Docker containers used in the backend, such as Postgres, Kafka, and Cassandra. That way you can work with Docker containers as with any other component in your application, and this is extremely convenient. The benefits of using DStage, such as sharing components between tests, will apply to Docker components too. So you'll only have one Docker, again, starting up for all of your tests. Using that, you can launch your application locally with a configuration that uses Dockers. And when it starts, it will summon the entire environment of the services it needs to run inside Docker. So you just get an extremely easy local dev environment stuff. You just have to run the application with an appropriate flag, and you get everything that it requires to boot up, all the databases and C. The next important concept in DStage is integration checks. They allow you to define a simple precondition check, which would prevent your test or your application from starting if the check returns false. On the slide is a screenshot of IntelliJ test runner showing a real test suite where dummy tests were executed, but the tests that required an external Postgres database were skipped. In this case, they were skipped because we did not launch the Docker daemon, so we couldn't start Postgres Docker. There is a code example on screen defining an integration check. As you can see, it's pretty easy to do. Integration checks run before all the startup actions, providing you very fast feedback and allowing your applications to fail as early as possible if an external dependency is missing. Or in case of tests, to skip those tests that can't be run without an external dependency and run the rest. They also help you implement the so-called dual test tactic when you test your business logic twice. First time against dummy implementations and the next time against real implementations. Skipping the tests that can't run without external dependencies really simplifies onboarding. Someone starting with the project doesn't need to set up all parts of the environment before they can start hacking and testing the code. They can clone the repo and start immediately. The approach I mentioned before, the so-called dual test tactic, proves itself to be a very valuable tool. First of all, it allows you to draft your business logic quickly without being distracted by aspects specific to your integration point. And it enforces solid design. You have to create better abstractions to accommodate both the dummy implementation and the real implementation. So it makes your code more readable, easier to maintain, and simplifies onboarding of the new team members. Some say that testing with dummies is not enough because it does not reveal problems specific to the real integration points. This is true, and why we promote dual tests. Then some say that the benefits are not worth the effort, or that it's hard to write good dummies in memory implementations of demand things. In our experience, the return from good dummies is an order of magnitude higher than the investment. Now let's see how DStage helps us implement the dual test tactic. First of all, we write an abstract test suite. Then we define several environment traits. Each environment overrides the test suite configuration. In this example, we define dummy env for tests with dummy repositories and prod env for tests with production repositories. Then we extend our abstract test suite with our environments, and that's it. To reiterate, it's very easy to switch implementations in DStage, or we just declare the preferred choices along the repo axis instead of micromanaging individual components. Note that each DStage test is a lambda where each argument declares a dependency that DStage will provide for the test. In this case, the test do something requests service 0 and it does something with it. The tests are written in purely functional style using your effect moment. In this case, it's 0. Also worth mentioning that if you use 0, you can request your services implicitly using the 0 environment as well. Another important tool is memorization. In this particular example, we declare DB driver 0 to be shared across all our tests in all the test suites of a model, not just this single test suite. As you can see, it's very simple to manage. There are no global variables or GVM shutdown hooks or shady global objects with lazy calls that do side effects when they're used. No such hacks are required. DB driver will finalize immediately after all the test suites finish. Memoized components are shared across all the tests. They shut down gracefully. There are no global singletons involved, and different test configurations have different memoization contexts. So DB driver from production environment will not be reused in dummy environment. The memoization provided by DStage is generally sound and correct. So we just had a quick look at DStage features, which let us write faster and better tests and applications. So to be short, DStage verifies correctness of all the wirings ahead of time. So unlike JUICE, you're not going to have 20 exceptions coming out of nowhere because it somehow can't tell there isn't a dependency. Whereas you can just compute it ahead of time. It supports resources and resource life cycles. It provides a way to define easily configurable apps. It does integration checks before performing any effects, so your application can fail as fast as possible if there are no integrations, or you can skip the test you can't run with your current environment. It can gracefully shut down your application, and it can correctly share components between multiple tests and application entry points. So that's almost everything, though there is one more concept we should look at. We call that concept roles or multi-tenant applications, and that's the last element which enables real continuous integration. Here is a code snippet showing a role definition. A role is just a replacement for a main method, but unlike main methods, there may be several roles in one process running at the same time. Combined together with automatic application composition, roles allow us to easily run multiple components or multiple microservices that compose our product in a single process for simulation or to simplify deployment. We use the term multi-tenant application for applications that can run multiple roles. On the bottom half of the slide, there are two examples of running a multi-tenant application from the command line. The first line would run two roles, users and accounts, with real prod integration points, repo prod and transport prod. And the second line would run them with dummy repositories and dummy transports, which may be very useful for quick simulations, which are crucial for real continuous integration. To be short, roles allow us to have multiple microservices in one process, which gives us more flexibility for deployments and what is especially important for simulations. I want to emphasize that you may have a simulation of your full dev environment, or perhaps a huge part of it as a single process. Combined with the memory dummies, it gives you a way to run your simulations lightning fast, even on a single machine with a single command without complex install step phase. I'm not saying these simulations are perfect or a perfect and precise replacement for a full developed environment, but they don't have to be. Their purpose is to let you continuously integrate your services properly after each commit. It allows you to build cheap automatic filter at the beginning of your delivery pipeline and catch significant share of the issues early on. Also, in case you need it, you may always adjust the level of imperfectness of the simulation by extending your mocks. For example, you may simulate message loss or duplication in your transport layer. And you may use access configurations to easily switch between different simulation modes. Now wish to share the dissenting opinion on microservices. We believe that a microservice fleet is itself a distributed application, and that application is the product, and each individual microservice is no more than a mere component of the product. And we should integrate these components the same way we integrate our program components. Yes, it's hard to test distributed applications, but we can catch a lot of potential issues even if we test our product in a relaxed simulation without the networking aspect. In conclusion, I wish to say that one of our productivity recipes is to turn microservices into roles and allow them to coexist within a single process, to write reasonably precise dummies for every integration point, and to make your applications easily configurable. This will let you make cheap models of your product, enable real continuous integration, and you will experience a lot less failures in production. Roles and multi-tenant applications do not require a monorepo. Our client has migrated to a monorepo after a write of the Go code to Scala, and then we consider it feasible, but it's not a must. Before we migrate our customer to monorepo, we've set up one independent repository with internal libraries using all the microservices, multiple independent repositories with different roles and their individual launchers, and one more repository with unified launcher that merged all the roles together into a multi-tenant application. While we think that a monorepo would be more beneficial because it's a lot easier to extract shared parts and observe the entire product, a multi-repo flow is also possible when you use roles. The only potential drawback is that you have to use a single stack across your roles, but actually such an approach is not a true drawback. It may be very beneficial to use a single language across the company backend, especially the language is Scala. Thank you for listening, and now it's time for your questions and answers.
Okay, thanks very much for that. It was a very good introduction to what you've been doing at Septimal Mind. There have been some questions that I think your colleague's been answering on Twitch, but I'll ask them to you as well anyway, so just for a bit more completeness. And the first question was, what tooling do you use for CI/CD?
What tooling do we use to CI/CD? That depends on the customer. We don't require any kind of special tooling because everything, well, these stages use the Scala library. So all the value added here is at the level of your application. It will work with whatever the CI you use.
Okay.
So,
which one do you find you used more of?
I would say I don't want to reveal my customer details. So
okay, that's fair enough. Yeah, and the next question was, what's the benefit of using integrated tests with dummy services rather than using mocking frameworks?
This is very simple, actually, for me to answer, because when you use mocks, you end up testing mocks. You're not testing your application. All the code bases that use mocks, in my experience that I've worked on, they degraded heavily because these mocks, they get out of date and inconsistent with the way business. They get out of date with the business requirements. They need continuous maintenance, and it's way easier to just write a dummy that, well, actually does all the logic properly, that actual code is logic, than to code expectations. The expectations will change. When they change, you'll have to update everything, and it's just a pointless waste of time, in my opinion. Like, I have, and we have, as a Septimal Mind, a very, very strict prejudice against mocks. That's my question.
Okay, fair enough. Another question we got is, when you're testing, can the tests wait for Docker containers to be ready? Yes,
that's exactly what it will do. Because as the test is a function that accepts the dependencies, the service dependencies as their arguments, it actually cannot be run before these arguments are available. Now, if your dependencies themselves depend on a running Docker container, then the Docker's acquire effect must succeed, and its integration check must also pass to make sure that it's online. So yes, they will have to wait. In fact, there is actually no way they can't wait.
Okay, cool. So another question we've got a bit more open is from a Java developer that really wants to work in Scala, especially fully functional programming in Scala, and they want to know what kind of advice you'd have to convince senior engineers to at their company to move towards it and to take functional programming seriously? What like are the kind of benefits and stuff that they could use to sort of sell it to people much more senior in like from an OP background?
I would say the biggest argument is productivity. You're not going to buy Java developers with talks about beauty or whatever it is that you find you like. No, the biggest benefit is productivity. The biggest benefit is cutting development costs by 50%, and it's not the cut is not from people being laid off. It's from projects being completed way faster, and it's an experience you can that a lot of companies can testify that with disciplined use of Scala, you can get your projects done faster, better. They will stand the test of time. They will work better, and the hiring can possibly get tough, but we will solve this by training people.
Okay, cool. Oh, sorry. Did you want to add more to that, or?
No, I say that both for companies and for individual developers, the answer is the same. Productivity, you get more done with your time and better.
Okay, cool. Another question we've got is what kind of compile time safety discharge guarantees when you're activating the application?
None, but basically this isn't really an issue it isn't really a big issue for us because, as said before, you can compute the wiring ahead of time. So you can put this test on your wiring inside your test as a runtime test. So what happens is you have a very fast test that just tells you if you're missing a wiring or something bad happened that doesn't actually execute anything, that doesn't need your application to run. This is not as fast as compile time check, but it's close enough. Then there's also experimental support for compile time checks. But this support is basically just using a macro to run the same kind of test in compile time. I do not advertise to use it because in combination with incremental compilation, this macro will not be rerun twice. So it's kind of there for show, but you'll be well served by testing your application in runtime. Basically, if your tests pass, your application will run. It's possible to add more compile time safety, but I just wanted to be, it would change the APIs. It would make everything a lot more complex, and the benefit I find not very worth it. Pretty much everyone who is in market for a dependency injection framework is not going to be too concerned about having to run a test. Like all of these questions I get is from people that are very set in their ways of wiring everything manually. Like I don't feel it's a super important battle. Yeah, thank you.
Okay, cool. Another question we got is contract testing integrated in DStage, and are there any ways to configure network timeouts for that?
Contract testing and network timeouts. I don't actually know what you mean by contract testing. I'm really sorry. You'll have to redefine it for me. But actually, if you have any kind of feature that you want to support, you can open pull request or open an issue and request it, and it'll be okay. As for configure network timeouts, yes, you can reconfigure any component in your application. So if you represent your timeouts as a case class with durations, you can just override it in your tests and have a different one, or configure it using Hawk-on, these types of config. So for that.
Okay, cool. Another question we got kind of related to being able to implement these changes. Have you had any kind of pushback from software developers where you've tried to push or destage and things like that on them?
No, and this is mostly because we started with juice shops that gradually embraced functional programming, and this was fantastic for that because we could start using it, and first without really fee, without any monas or anything, and it would gradually grow with us because it supports everything you need for functional programming. So yeah, in this case, no.
Okay, cool. Also, someone's asked, can you clarify a bit more about the dummy services that you're using instead of mocks, and are they effectively stubs is the question.
A dummy service is also called a test double, but what that means is you implement, so you have a repository, like, right? You use the repository pattern, you have an object that represents the queries you can send to your database and the response you get, like get, set, update. And a dummy just means you implement the same interface with the same behavior using an in-memory collection, like a hash map. You can use a mutable hash map, or you can use an immutable hash map with ref, for example, from various FP libraries. It really doesn't matter. What matters is that you have an implementation that basically does the exact same thing that you implemented in memory, that doesn't require anything external, etc. So, and this forces you to design better because you can't, for example, pass around fragments of SQL queries, because what are you going to do? Are you going to write an SQL interpreter in memory? No, you have to make interfaces that are agnostic towards the backend. That means you have a very easy time, for example, migrating databases. And this is not a frivolous concern. We have migrated databases using the same technique. It's not as rare as my thing.
Kind of a related question. How do you test for failure cases with your dummy services?
The same way. If basically, if there are failures that are specific to your database backend, for example, some kind of limitations in your SQL engine or some kind of limitations in your in DynamoDB, well, the first thing you can do is simply have the same kind of, just mock the same kind of failures, add them to your dummy repository, add the same kind of limits, or you can just ignore them and run this part of the test that is very specific only for the production repository. There may be such parts. It's not really, it's not a deal breaker completely, especially if you're checking for, especially if you have a progression, because if you're checking that a failure happens and it's still not fixed, that's fine.
Okay, cool. Another question we have is, do you support Scala JS? And how does DI work without Scala Reflect?
Yes, we support Scala JS, and DI works without Scala Reflect because we have zero runtime reflection whatsoever. All the constructors are generated at compile time with a macro, so you don't really need to have any kind of runtime reflection there. And we put a lot of effort into these macros so they're as fast as possible. There's just non-existent depth when it comes to compile times, because they're all black box. They start hard. There's no anonymous classes or anything generated. You can really pollute your class path if you have anonymous classes inside macros. And we created a replacement for Scala Reflect. We created Izumi Reflect, which is basically a replacement for Scala Reflect's type tag. It contains type information of a type and allows you to compare types, compare kinds of types, variances, etc. So it implements subtyping and quality checks, and that's all we need. That's all we need to compute wiring. We don't need to access some of the other information inside Scala Reflect, which is like methods, signatures, etc. So there's a lot of information there. There's just types and their representations. And the same library, Izumi Reflect, is used in Zio for similar purpose. It's used in Z layer to store to back the Zio environment. So when you get a component from the Zio environment, the Izumi Reflect tag is created and it's used as a key inside the map. So we had this made for this stage, and then ZLayer came out, and they had a very, very suboptimal way of they used class tags, and that meant you couldn't have type parameters in the source because class tag can't support that. You don't have generic type information. Reflect does, so we looked at that restriction, we helped them out. Yeah. So this library used to parse for that.
Okay. Another question we've got a bit more for the future is, are there any plans to extend the integration kind of past microservice type projects and to more data orientated projects?
Possibly, but I mean, you can use dstage itself as wiring. You can use it anywhere. You don't have to even declare any roles or anything like that, or take over your main method. You can just use the injector and create everything you want to know, everything you want to have. So in this particular case, yeah, you basically can just go and use it in Spark or whatever you want. It'll work. As for anything more specific, better probably open an issue and describe what is it, what exactly do you mean? Because then we can help, or you may be able to open for request. So this is a very broad question.
Okay, cool. Another question, maybe a little bit contentious. Do you feel Zio is a better interpreter than Cat's IO for productivity?
Yes, because of typed errors mostly. For our use case, the Zio environment type is somewhat useful for testing because you can omit the arguments and have them be inferred with the environment. But most of the benefit is from typed errors, is from using bifunctor tagless final, just having that after with 2 parameters and knowing where errors can happen, where they can't happen, where these are dominant errors or not, what error to return to the client in case of failure. And yeah, just having it sealed down and controlled. This is very, very productive. So different implementations are welcome, but for now, for us, it's basically Zio.
Okay. And on this theme, do you consider the current Zio dev release candidate version production ready?
Yes, it's production ready. Definitely production ready since it's been released. More production ready than version 17 because of some bugs fixed. Yes, I think it's faster and better than the previous release. It's actually great. If you're stuck in version 16 or 17 or anything, please update. There's no reason.
Okay, cool. I'm just looking around to see if we've got any more questions anywhere. I think you've answered everything that I can see. So thank you again. Like, great presentation. I'm sure everyone has been very impressed with it. I will post a link now in the chat to the breakout room. So if people do have more questions for you, you can go ahead there and answer them in that room. And yeah, thanks again. And yeah, just a reminder again that the breakout room is posted in the Zoom chat.
Okay, thanks, yeah.
Cool. Thank you. Hi, Petra.
Hello. Can you hear me?
Yeah, I can hear you, so
Cool.
it's a good start.
Great. So first thing that's working. You should now be able to see my slides.
Yep, I can do. Very clear.
Oh, great. I guess the two most important things are working.
Yeah. The voice and the slides. Okay, I'll probably introduce you about a minute before, so we've got about 7 or 8 minutes beforehand. So.
Can you see my mouse pointer too, by the way?
Yeah, I can.
Cool.
Moving around.
Hello, how is it going?
Hello. Yeah, good so far. Thanks.
All right. Good luck. Break a leg.
Thanks.
Yeah, okay, bye.
Bye-bye.
Were you intending to share your webcam? It's not showing right now, but I don't know if that's intentional.
Oh, sorry, I was muted.
Oh, right. I didn't know if you were just.
Yeah, it's a little bit hard because every time I go to the top of my screen, there is another thing that comes down, and it's hard to to actually get the mute button.
Okay.
Yeah, I was thinking about it, but I don't think I need the webcam, and it's sometimes slowing down my Zoom meeting. So I guess.
Yeah. I don't think it's necessary. It's just that you asked about it, so I didn't know if you were intending
yeah.
to do it and just hadn't enabled it. But yeah, it's I don't think it's.
Since it's just a small image on the side anyway.
Yeah.
It's okay.
Okay, welcome everybody again to the Joy Track, and fresh welcome for those just joining us. If you're joining us on Zoom, please feel free to post any questions using the Q&A option as part of your client, and I'll be asking those to Petra at the end of her talk. If you're on Twitch, I am trying to monitor the stream chat there as well, so please feel free to post questions there. At the end of the talk, there will be a link posted in the chat on Zoom to the breakout room where Petra should be joining afterwards for you to have a bit of a more interactive Q&A session. And now it's my pleasure to introduce Petra to you. She's the last of our talks for the morning track, and Petra first heard about Scala more than 10 years ago, and after that, it soon became her #1 favorite language. She's very interested in DevOps tooling and improving developer productivity. For the last 3 years, she's worked in distributed teams and strongly believes in remote working. And today, Petra's going to talk us through MUnit, the new testing framework on the block. So over to you, Petra.
Okay, thanks a lot, Chris. I'm super excited to be speaking at Scala Love conference. And this is my first time giving a fully remote presentation, which is, yeah, a bit different to not being able to see you guys, but I hope it will be everything work just fine. So I'm happy to introduce you to a new testing framework that's called MUnit. And you might be thinking, great, a new testing framework, but there is already a couple of testing frameworks out there. So do we really need another testing framework? If we look at Scala over the last 10 years, so there was this, in the very beginning, there were no Scala specific test frameworks, but then quickly there came Scala Test and Specs 2. So those two have been around for most of the time. They are both quite, yeah, proved to be working well and have a lot of features. And a little bit later, there came two other frameworks, Minitest and Microtest, that were like more opinionated, didn't offer like trying to squeeze in all kinds of features, but had a very specific philosophy and tried to be more minimal. And lately there has also been Scala Verify, that's another minimalistic framework that's actually based on Minitest. And its goal is to have like a common minimal testing library that can be used to test on Scala itself. And in the beginning of this year, a new testing framework has been released. It's called MUnit. And some quick facts about it. MUnit has been created by Olafur. It was released in the beginning of this year. You might also know Olafur from several other Scala Meta projects. And MUnit is also used in some of those projects already. So it's used in real world projects. And its name comes from the fact that it's a member of the Scala Meta family. And most projects of this family start with the letter M. Let's get a quick overview of its goals and features. We will dive into more details later. The first and most important feature, in my opinion, is that it treats tests as pure values, and it has a minimal and developer-friendly API. It really encourages you to customize it and make it your own. It has extensive support for filtering, both statically or on dynamic conditions. And there's quite a lot of interesting things that you can do it. And one of them is transforming your test cases or values before they actually run. And it gives you actionable errors, which is like a nice test output that should make it easy to spot a lot of errors right in the command line without having to navigate into your code. And I'm sorry, my neighbors are working. I hope it's not too loud. So another set of important goals is to support the whole Scala ecosystem, like Scala.js and also Scala native. And it's already available for .t. It's implemented as a JUnit runner, and so for this reason it has good IDE support. And yeah, one of its goals is to leverage existing tooling that's available for JUnit. And it also provides reporting based or a reporting that's based on a SPT plugin, and lately also support for Scala check has been added. So let's get a quick look at how writing tests in MUnit looks like. So that's the correct slide. If you have used other test frameworks, so the setup for MUnit is pretty similar. You basically just have to add a dependency and declare it as a new test framework in your build SPT. And writing a simple test, the most straightforward way to start is by extending MUnit fun suite. It's also possible to go for a more minimalistic approach, but I guess for convenience and getting started, this is like the best way to go. FunSuite gives you a clean and quite minimal testing framework that can be used without learning too much about the underlying implementation in the beginning. It comes with a lot of features included, and it should cover most of your testing needs. So most of the things that you will see in this example with some things that you probably know from other testing frameworks. So MUnit comes with a very simple API to let you declare test cases. And out of the box, it already supports synchronous and async values. Other things that it lets at you with traits is assertions and fixtures, and transformations for suites and tests and values, as we will see later. So like I already mentioned, the most important feature, in my opinion, is that it treats tests as pure values. So what I mean by this is that if you look at the definition of the base suite, basically it consists of a type that will be the test value produced by the body of your tests. And tests in MUnit are simply a sequence of those generic tests. Knowing about this underlying fact is quite helpful if you want to tweak or customize your tests. But like I said it before, it's not strictly required. And using FunSuite will take care of most of the things for you. So let's look at what FunSuite adds basically to the core suite. FunSuite defines the value produced by our tests as a future of any. It will also work for non-future values. And it defines a test method that offers a nice syntax to define tests. And what this test method does is it will basically simply create a new test and add it to this mutable list buffer that in the end will be used to define the sequence of tests that our suite needs to provide. A test itself in MUnit is a a class that consists of a name and a body that can have a custom result type. And there's also the possibility to add a set of text to it, which can be useful for filtering or applying transformations. And there is a location that will be passed around implicitly most of the time. And it's used to enable the jump to test and error in your test outputs. So let's look at some of the developer-friendly APIs that MUnit offers. So by treating tests as values, it gives the developer a lot of freedom to customize how you want to write your tests. And many customizations can also be achieved by using text filters and transformations. So the most minimal thing that you can use is extending MUnit suite directly and overriding the test value and the MUnit test method. And this way you have complete freedom by restricting the type of your tests even further. Maybe you say you don't want to allow any in your tests. You know your tests will always have a result of future string. So you can override the test value and also simply define your tests as a list of test classes without using any kind of mutable buffer or side effect. And if you do it this way, you can define your tests as a simple data structure. And if you're trying to execute any logic in your body that does not have the expected test type or will not produce the expected value, it won't even compile. And so it allows you to catch errors even earlier. This API is probably a little bit too minimalistic for end users, but it can be quite useful if you want to define your own type of suits that can then be used by your team or by other people. Another interesting thing that's not quite as minimalistic, but still very useful is filtering and transformations, which can be used in combination with tags. So you can, in MUnit, you can define as many tags as you like and give them custom names, and you can add the tags to your test cases. This is quite useful for example, for filtering when you have a test that's very slow and that you don't want to run every time you execute your tests, or it needs some kind of external service that's not available in your local test environment. You can also decide to ignore a complete suit based on either a static value or also on dynamic conditions. In the second case, you can override this method and use whatever logic you want to decide if you want to run the suit or not. To filter individual test cases, you can either provide the lists that you want to exclude or include via the SPT shell, or if you want to do it more dynamically, you're free to do it in your code. You can override the MUnit tests method that will eventually return the sequence of your tests. And since the sequence of tests is just a normal data structure, you're free to filter it or modify it in any way you like. So in this example, we're using the list of tests that we get from the base implementation and simply apply a filter based on the tags. And also, we can choose to just apply those filters for certain conditions. So this gives you a lot of freedom to decide when you want to run specific tests and when not. Another useful thing that is not so well known probably from other test frameworks is the way to apply transformations to your test. So there are 3 different types of transformations. You can decide to transform your whole test suite, which is mostly used for ignoring it. For example, you can have transformations for your individual test cases. So you could, like, for example, implement custom retry strategies or run a test multiple times. And you can also apply a transformation to the value produced by the test body itself. And for the example of this talk, I picked the last type of transformation, which is the value transformation. And in this example, we are going to add support for Monix task in addition to the future. And if we look at this example, there is one small problem. So on line 13, we define a test that does not return a future as a test value, but it will return a Monix task. And if you have used Monix before, or also if you haven't, it's not important, but the important thing is that Monix task is lazy. And this means if you don't do anything else and leave the code as it is here, nothing will be actually run. And so the exception that is thrown when we try to get a value from the database will never happen. And the dangerous thing is that you might miss it when you run the test, because the test will not complain, it will just succeed, since it doesn't throw any exception. And one way to fix this, of course, would be to manually run the task every time we create a test. So you could add this run to future call for all your test cases. And while this might work, it's not very nice, because we have to repeat this line in every single test case. And like I mentioned before, if we forget to add it, the test will not fail. It will simply still pass. And so it's quite easy to miss this. And a better solution would be to automatically transform our test value to a future that MUnit is able to understand. And we can do this by using a value transformation. So in order to transform a task automatically, we can override this method, which is called MUnit value transformation, or value transform. And there we simply add a new value transform to the list of MUnit's value transforms. And the value transform that we add, we give it a name, which is task, but could be really anything. And then inside we have to add a partial function that will basically match when to apply a transformation. And in this case, we just want to apply it when our test returns a task. And so if our test returns a task, we simply turn it into a future by adding this run to future call automatically. And once we define this value transformation, we can remove this line that we added to our test cases, and the transformation will be applied automatically by MUnit. So another feature that MUnit offers is to show you actionable test results and helpful diffs right on your command line. So its goal is to provide you with useful information that can be used to debug test failures without having to navigate into your code. So in order to help you debug your test cases, it will offer you an option to jump to the location automatically in your source code in case you need to, more sophisticated debugging that the test result does not provide. It offers you some clues about the error that you can also define manually when you write your tests. It will highlight the most important stack trace lines, which are usually exceptions thrown in your application and not like the lines of the test framework itself. And if you're comparing case classes with assert equals, it will show you a nice and colorful diff. And let's look how this does look like for a simple example. Imagine we have this test case here where we have a case class which is a cat, and when we compare two instances of this case class that have one value in common and one value is different, the test will fail, and it will show you the output in this screenshot. So as you can see here where the mouse pointer is, you will get a link to the location in test, so you can simply click on it and it takes you there. It will also show you like those 3 lines that are the definition of your test and highlight the line where the error happens. It will show you which value it actually obtained. And most useful probably in this case, it will also show you a diff that highlights differences between the 2 case classes. So there is even more to MUnit that has not made it into this presentation. MUnit also offers quite a lot of different ways to write fixtures for your tests. So you can set up resources like databases or opening a file that can be both isolated and for each test case or reused between test cases. Another cool thing is that it allows you to basically tag tests that you know to be flaky. So this means that sometimes they will fail and other times they will succeed for no apparent reason at all. And so it's quite useful to being able to tag those tests and then decide that maybe you're already aware that those tests are flaky and you still want your suite or test run to succeed, even if those are failing. It offers a plugin that can be used to upload the reports produced by the test to Google Cloud Storage, so that the historical data can be used to generate reports that give you an overview of how your test cases have performed over time. And those reports can also be used to generate HTML report with MDoc. And also there is like a lot of more examples that, interesting things that you can do with MUnit, and I really invite you to take a look at the website and the blog posts, because there, you can find a lot of examples. And this takes me to some credits. for this talk and also where to get more information if you're interested. So first of all, MUnit is like a new or nice combination of great ideas that other frameworks had before. So the reason why it's still a new framework is that, especially if you have like try to build a minimal framework, it's by definition quite opinionated, and so its uniqueness lies in offering a combination of features that you might know in somewhere or another from other frameworks, but not like in this combination. And like I said, there is already a really nice website and a blog post, a couple of blog posts actually. And yeah, if you're interested, go there and have a look. That's it for my talk today. I was actually a little bit faster than I expected. I hope you enjoyed it. And if we have any questions, I think there are still a couple of minutes left now, or we can catch up in the QA room. Thanks.
Okay, thanks very much, Petra. It was a great overview of MUnit. There are a few questions, so as you said, we've got time. I'll put those to you now. So the first one is, does MUnit allow you to be able to consolidate reports from multiple users in its reporting?
Sorry, could you repeat it again?
So does MUnit allow you to consolidate multiple reports from multiple users in its final reporting?
By users, you mean, could the person clarify this a little bit, or is it not?
I'd like them to, yeah, but they haven't done so far. Let's put that on pause for a second, then we can.
I think you can define when you set up the plugin a certain key for your reports, and it will accumulate all data for this key in the specified cloud storage. So as long as multiple users are using the same key, it should be accumulated.
Okay, cool. Another a bit clearer question. How would you convince someone to migrate from, say, Scala test to MUnit, and how much is the migration taken into account, the migration cost?
I think a big role in this question plays, or an important question is which kind of tests your team currently uses. So if, like you might know, a Scala test offers quite a couple of different test styles. And I think MUnit is closest to the I think it's also called fun suite in Scala test. So if you use that suite, it should feel pretty familiar. Also, an important point is if you make heavy usage of the DSL that Scala test is using, and if you actually like this DSL, then maybe Scala test is a better choice for your team, because MUnit does not try to provide a DSL that covers every possible use case. It has a very small set of assertions. I guess it's like 5 or 6 of them. So it's very easy to know the whole API by heart, while Scala test is offering like a lot more features. But for some people, some people prefer a more minimal approach. So.
Okay, cool. I can't see any other questions right now, so I'll publish the link to the breakout room in the chat. If you could follow that, and then people should be able to go and join you there and have a bit of a more interactive QA. And yeah, thanks very much again, and thank you to your neighbors for helping with their part.
Yeah, I'm sorry about that. It just started.
No worries.
When I gave the talk. Okay, yeah.
All right, thanks very much.
Thanks, bye-bye.
Hello.
Hello. How are you? I cannot hear you.
I was muted.
Okay,
I'm fine.
now I can hear you. You're fine?
You see my slides?
Yes, I can see your slides.
Okay.
We're
good.
waiting for your track owner,
Okay.
right? What time is it? It's still 10 minutes before the talk, right?
Yes.
Okay, she'll be there. Zainab is your track owner, if I remember correctly.
Yes.
Did you have lunch already?
Not yet. I've had very early this morning, so I'll eat later. I will eat later.
I'm sorry, I'm going to eat in front of all these people because I'm hungry. It's almost 4 a.m. my time, and I'm up since yesterday.
Okay, go ahead.
But meanwhile, tell me why you chose this topic.
I chose this topic because I've always seen many forms of polymorphism, and I wanted to know what all these forms have in common. And I was also interested about the genesis of polymorphism. So I started to read some papers, and it was very, 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 very interesting. And there are many features in many languages like Scala, which are not very, which are not very well known. So I just think I could maybe make a talk about it, and this is my second talk on this subject. So.
Okay. Yes, you
interesting.
said that the first part was at Scala UA. What did you cover there?
Okay, at Scala UA, I covered the talk was about polymorphism, and it was it was more beginner than this one, and I covered all the simple various forms of polymorphism. So parametric polymorphism, type inclusion polymorphism, subtyping, ad hoc polymorphism with type classes and all this stuff. And I'll talk a bit about existential type. And in this talk, I will be talking about I will talk about parametric polymorphism, inclusion polymorphism, existential types, and I will see how we could mix subtyping with quantification.
Very excited about your talk. So I'll be
thank you.
I'll be joining your talk from Twitch because I need to run around the different joy rooms. So good luck, break a leg, and
Thank you.
oh, here's Zainab. Hello, Zainab.
Hello.
Hi, Stefan.
Hi.
Okay, so I need to run. Bye bye.
Bye.
Oh, okay. Bye, Ollie.
Bye.
Okay, it's great to see you. I'm really looking forward to your presentation.
Thank you. I'm Erzi, and are we starting yet?
We have around 5 more minutes, but that's definitely enough time to prepare. We can see you, we can hear you as well. Can you flick through a few of your slides just so that we can make sure we can do a flick through?
This is
yes.
do you see?
Yes, I do see. Oh, this is going to be fun.
Thank you.
How have you been finding the conference so far?
What, could you repeat, please? I didn't understand.
How have you been finding the conference so far?
It's very interesting. I saw 2 talks this morning, but I wasn't very focused because I was thinking about my talk. So maybe after this talk, I will be able to enjoy the rest of the conference.
Yeah, that's definitely true for me too. I've got mine now over and done with, and can enjoy the rest of the conference.
Oh yes. By the way, I saw your talk. It was very interesting, but I wasn't, like I said, I wasn't very focused. I think I will see the replay.
Well, the good thing about me hosting you is that I get the pleasure of seeing your talk and sitting back and relaxing in the background.
Thank you.
I'm sure it'll be very interesting.
I hope so.
Just a message to the participants before we get started. If you have any questions, please ask them on the Q&A chat, and I will forward those questions on to Stefan. Okay, Stefan, when you're ready, I think, oh wait, we've got a few participants joining. Let's give it a couple minutes more. Okay, Stefan, when you're ready, please feel free to start.
Okay. So I will go.
But I should probably introduce you first, right? For all the attendees. So thank you everybody for coming in and watching Stefan talk. So Stefan is a functional Scala developer. He's been writing code for Scala code for about 5 years, and he co-organizes the Paris Scala users group. He's very interested in lambda calculus and type theory, and so I think of him as my Prosian alter ego. So today he's going to give us a tour of the many forms of polymorphism. Please welcome Stefan. I know that unfortunately you don't have your audio on, so you can't clap, but I'll clap for Stefan.
Thank you very much. So welcome everyone. The title of the talk is Polymorphism, Wait Until You See My True Power. So I'm Stéphane Tanquois. This is the link to my GitHub, my Twitter, and there's also my blog. Now we publish the slides of this talk of the talk I've already presented before on my blog. So the title of the talk is inspired by a sentence of this character, which is Frieza, and just as polymorphism, Frieza has many forms. So as we evolve in the talk, I will present more advanced form of polymorphism, and you will see more advanced form of Frieza. So before starting, I want to give the syntax of the language I will use for my examples. So the first language I will use, because I love that language, is Scala, right? So this is the syntax of Scala. Right there, I'm defining a value, named value. The val keyword is to say that my value is immutable, and this is the type of my value. Then I define a tuple of integer and string. Right there, I'm defining a function, named function, with the def keyword, right? And that function takes an input parameter named input of type integer and return a string. Then I define the function as a value, right, with the val keyword, and that function is will be a lambda function. On the last 3 lines, I define an alternative. An alternative is a variant type is an alternative between two records. The first record is record 1 with 2 fields, label 1 of type boolean and label 2 of type char. And this is the second record, right? The second language I will use for my example is Haskell, and like Haskellers like to say, we should all learn Haskell for Greek good. So that's what we will see today. So we'll see some Haskell today. So in Haskell, remember that on the first line we give the signature of a value or of a function, then we give an implementation. So right there I'm defining a value of type string, and this is the signature of my value, and then I give the implementation. Right there I'm defining a tuple of integer and string. I'm defining the function from integer to string, and this is the implementation. And this is the same, but my function here is a lambda function. And right there, this is a variant type, so it's an alternative between the record 1 boolean char and the record 2 string int. And look here, so we'll see also the syntax of TypeScript, right? So this is how to define a value in TypeScript, and the const keyword is to say that my value is immutable. This is how to define a function with the function keyword, and that function takes a number named input and returns a string. This is also a function as a value. And you just note that in the type of the function, I put the name of the parameter. And this is how to define a record with 2 fields, label 1 of type boolean and label 2 of type char. This is how to define another record. This is the variant type is an alternative between two records. There's a little difference, but it's not doesn't matter for this talk. So now I just want to give a quick recap about polymorphism. So in 1985, Cardin and Wegner give a classification of the various forms of polymorphism at this time, and they come up with this classification, where we have parametric polymorphism, inclusion polymorphism, which is in a group named universal. And this talk will focus on those two forms of polymorphism. So we won't talk about other forms of polymorphism like ad hoc polymorphism. There's another talk in the conference which talk about type classes. So feel free to see it. Now I want to give an example of what parametric polymorphism is. And in Scala, to achieve parametric polymorphism, in my example, I will define a length function, which that function takes a list and will compute the size of that list. So this is how to define my function length. That function takes a type parameter, and my function will take an input parameter list, which is a list of A, my type parameter, and returns an integer, which is the size of the list. And when I will call that function, I will have to specify the type of the list. So right there, I'm specifying the type A to int. So the compiler will infer that the input parameter is of type list of A, right? And note that when I will implement my function, the implementation of my function doesn't know the type A, so it's agnostic to A. It should work for any A, right? In Haskell, this is how to define the length function. So that function will go from a list of A to an integer. And note that in Haskell, every character which is unknown to the compiler will be considered as a type parameter. So as A is unknown to the compiler, it's considered as a type parameter. And this is how to implement the length function in TypeScript, right? And the only difference with Scala is to use instead of the brackets, we use the dot signs, right? So now we talk about inclusion. So before, I want to give first a definition of inclusion. So type A is included in or is a subtype of another type B when all values of type A are also values of type B. Especially exactly when A considered as a set of value is a subset of B. So with an example in Scala in TypeScript, because Haskell doesn't support subtyping. In Scala, we achieve inclusion with subtyping and inheritance. So if I have a class person with two fields, name, string, and age int, I have a class employee, which extends from person, right? With an extra field, is manager of type Boolean. If I have an employee, in that value, that employee could be assigned to a variable expecting a person, right? So that is inclusion. An employee is also a person. And in TypeScript, if I have that record person with two fields, name, string, and age number, I have that record employee with an extra parameter, an extra field, excuse me, is manager Boolean. If I have a value of type employee, I can assign that value of type employee to a variable expecting a person. Why? Because what's the difference between the two? In TypeScript, I don't have to explicitly write that my employee is a subtype of person, because the subtyping relationship will be inferred based on the structure of the two records. Whereas in Scala, I have to explicitly specify that employee is a subtype, is a subclass of person with the extend keyword. So this is structural subtyping, and this is nominal subtyping. Now I want to talk quickly about existential types. So when there's a similar, parametric types are very similar to the universal quantification that we use with that keyword in mathematics, especially in logic. And if I write something like this in my type system, this means for all type A, expression P has type T of A, right? So when I will create a value or implement a function of that type, the type A will be unknown in the implementation, so the implementation is agnostic to that type A. Whereas when I will call a value, or use a value or call or use a function of that type, I have to set the type A. So the type A is only known at the call site. Then if I instead of writing this, I'm writing this by using this sign of mathematics. In our type system, this means for some type A, expression P as type T of A. And what's the implication of that? So that type A will be known when I will implement or create a value of that type. So that type A will be known, and the implementation will depend on that type A, right? But at the call site, when I will use a value or use a function of that type, I won't be able to know the type A, right? So that's the difference between the two. And with existential quantification, the purpose of existential quantification is to hide the type inside the type, right? You will see that with an example. If I define this type, T, like this, for some A, I have this record value, I have this record with a field which is value of type A and a function from A to int, right? If I declare a value of type T, I will set a type to A, which is int, in my example, for the value X, and then I will give the value for X. And if I have that, if after the implementation, after the definition of X, if I have the value X, I won't be able to do anything on it except taking that value and pass it to the function. So this is an abstract interface. This is a module interface, right? So how to have existential types in Scala? There is an easy way to have an existential type. For example, if I have a list of integer and I assign that list of integer to a list of underscore with that sign, right there, I will hide the type integer. So I won't be able to know after my definition to know the type of an element inside my list. So if I try to call head for example, I will get an any. And by the way, this is very interesting. I will come to that later. So there is another way to have existential type in Scala. One of the other way is to define a try like this with an abstract type A. And when I will define the value x1 of when I will define the value of x1, I won't be able to know. I will lose the type of that value. I will set a value right there, but afterwards, I'm not able to know what's the type of A. It's hidden to me because it's just known when I will implement that value. And there's another way to have an existential type in Scala. If I have a tray like this, I have an implementation of that tray with a type parameter. If I have a value of x2, I know that value is an instance of that class, the implementation class, but I won't be able to know the type of the A inside my value because that type will be hidden to me. The type A is existential. Excuse me. So now this was just an amuse-bouche, like we say in French. So I hope you're ready for the big stuff. And in this section, we'll see what we could mix quantification and subtyping to write more powerful and expressive programs. So we'll first start by seeing what we get when we mix parametric polymorphism with subtyping, right? So I will start with an example. In that example, I define a function f, which takes records like this, one of type number, and returns the value of 1. If I call it with an instance of that record right there, or with a subtype of it, I will get the value of the first one, which is A, for my 2 examples. Then if I call it with one true, I will get a compiler error because true is not doesn't belongs to the type number. True belongs to the type boolean, and my function expects the value of 1 to be a number, right? So this is logic. Then if I have another function like this, but instead of relying on subtyping, I take a type parameter A, and I specify that that type parameter is a subtype of my record 1 and number, right? And the implementation still the same. And I just use the type parameter for the type of my input parameter. If I call it with an instance of that record or with a subtype of it, it'll be the same, and I will also get the compiler error. But what's the difference between the two? You just see that right there. If subtyping, the inclusion relationship in my input parameter is implicit. I just expect my input to be of that type, and if you give me a subtype of it, it will work. It works. But with that version, my subtyping relationship is explicit, right? And this is easier to. This is more convenient. This is this version is more complicated, but it's more powerful, and we'll see that in a moment. And this is what I just said. And what I want you to remember is that if you have this kind of type, for all A, have a type T, this is actually equivalent to for all A, which is a subtype of any of the type T. And this explains why we get the type any when we call head on a list of underscore, right? Because this looks like for all some A, which is a subtype of any of the type A. And so we'll get just the upper bound. So with an example, we'll see how powerful what power we get by mixing subtyping and parametric polymorphism. In that example, I define a type point, which is a record with two fields, X number and Y number. I define a type tile, which is a subtype of record with two more fields. And if I define that function, move x0, which takes a point and a dx of type number, and that function will just add that dx to the x coordinate of my point, right? And just return that point. If I call it with an instance of point and 1, and I call x on it, I will get a result. If I call it with an instance of a tile, right, and 1, and I call or on it, I want to get that field of my tile, I will get a compiler error. Why? Because this is actually simple, because right there, as my function expects a point, if I pass a tile, that tile will be upcast to a point, right? But I will lose the type information or that I have on tile. So I will lose that the type information about those two fields, right? So this is I will just see that I have a point, but the value of that point as actually as an actual type, which is a tile. So this tile type will be existential afterwards. And if I define that moveX function like this, with type parameter which extends from point, and if I take a point, an input of P, of type P, a number and a dx of type number with the same implementation, if I call it with an instance of point, I will get the same result. But if I call it an instance of tile and I try to call R on it, this will actually compile, because I won't lose any type information, right, with this version. So with bounded quantification, this is more interesting and more powerful, as I just said before. And that explicit subtyping constraint helps me not lose type information. And by the way, you just see that with OOP is closely related to existential quantification, in the sense that if I have a super type like this is quite similar to saying that for some type A, which is a subtype of point, I have the type A, right? All I will know is that my type A is a subtype of point, and I don't know the actual type of my value. And by the way, by mixing subtyping with quantification, we call it point polymorphism. Right. Now we'll see what we get when we try to mix existential quantifications, so existential types, with subtyping, right? And by doing this, what we really want to write is something like this for some A, which is a subtype of T1 of my expression as type T2 of A, right? So with that existential quantification bound by upper type, what I express a type which is unknown to me, which is hidden, right? That type A. But I give a little bit more information about A, and the information I give is that type is a subtype of T1. So that type A is not more abstract than T1, right? So with this kind of quantification, with a bound right there, I'm expressing subtyping relationships between two types, but I don't know how the relationship holds. It is because the type is hidden to me. I don't know the implementation. I don't know the details, but I just know that there is a type which is hidden to me. That type has a subtyping relationship with another type. That's it. And by the way, if I have this kind of type for some A T of A, this is similar to for some A which is a subtype of any T of A. Right, and I will show an example of mixing subtyping with existential quantification. So in my example, I want to define this kind of module, a tile module, right? The tile module will have a type P, which is an abstract type. We'll have a type T, which is an abstract type, but T is a subtype of P, right? And I have 4 methods. One to build a value of type T, one to get a value of type P from a T, excuse me, one to get that value from a T, and one to get that value from a T, right? And I know that I have two type, point and tile. Tile is a subtype of point, but I don't know anything about those two types. Then for the implementation, I will know the type, and as I know the type, I will give the implementation for my tile module. So for the implementation, I will set P to point, I will set T to tile, and I will implement the method, right? And you just note that we could just note that in my implementation, tile is not a direct subclass of point, because tile is a subclass of segment, which is a subclass of point, right? But right there, this is good with the constraints that T should be a subtype of point of P, right? So, and if I have a function like this, which takes tile module as an input parameter, that function will be able to build a tile, get R from a tile, get the R value from a tile, get the var value from a tile, sum them up, and without even knowing what's the type of T and what's the type of P, right? That type will be hidden, will be abstract, but my function will be able to create values of that type and manipulate them. So that's very interesting. And now we'll see more forms of polymorphism. This is the last part of the talk, right? So the first thing I want to show, the first one I want to show that in that section is row polymorphism. So row polymorphism was introduced by Mitchell 1 in that paper, and it was implemented in PerfScript. This is the first language I know which offer type row polymorphism. It's coming in Haskell, by the way. The idea of row polymorphism is to be polymorphic on the field of a record. And by the way, a field of a record is a row, so that's why we call it row polymorphism, right? So what it means to be polymorphic on the field of a record. So what I want to do is to be able to describe a record like this in such a way that record as a field A1 of type T1 up to the field AK of type TK, but that record doesn't have those fields, F1 up to FM, and I don't care about the rest, about the other fields, right? And so this symbol called row is just a variable, polymorphic variable, which contains the extra fields. So row polymorphism, the reason why PostScript and Haskell support row polymorphism is that they doesn't support subtyping, and with row polymorphism, you get some of the advantages of subtyping, right? You have some of the capabilities of subtyping. They are more of row polymorphism and they are more of subtyping, but they have a kind of overlapping between the two. So I will show very quickly row polymorphism on an example. What's an advantage of row polymorphism? If I have a function like this, f, which takes a parameter, which is a record, like with two fields, a number, b number, and that function will just sum the value of the two fields of my record. I could call that function if, by the way, this is TypeScript syntax, and I will just imagine that TypeScript supports row polymorphism for my example, but it's not true. So if I call it with an instance of my record or with a subtype of it, I will get the value, and the extra parameter of my subtype will be ignored. Now, if I define another version of that function with row polymorphism, for example, so I will take the two first input parameters, a number, b number, and I don't care about the rest. And with the same implementation, I will be able to call the g function with the same values and get the same result, right? Now, if I define that function h, which takes the same input parameter, but that function will return that input parameter, right? And will add a field to that input parameter with the with keyword, which by the way does not exist, it's just for example. But that function will add to the X record another field, the field sum, which is the sum of the two first field, right? So if I call it with an instance of that record, A1, B2, I will get the same record with an extra field, sum3. If I call it with an instance of a record of that type, with an extra parameter C100, 100, I will get the same record with sum and 3. Whereas with regular inclusion constraints, that C field should be ignored and should not appear in the output result, right? So this is an advantage of row polymorphism. The last kind of polymorphism I want to talk about, I will be very quick because I think I'm out of time. It's kind polymorphism. But so before talking about kinds, and I just want to talk about types. So what is a type? A type could be seen as a way to classify values, right? So a type could be seen as a set of values. And if I have the value true and false, they belongs to the type Boolean, for example. And the type int, for example, it could be seen as a set of values as the set of 0, 1, 2, up to infinity, for example. So a kind is similar to a type in the way that kinds could be seen as a set of types. And I just want to show an example of type and kind in Haskell. So by the way, in that example, I will use two commands. The "t" command, which takes a value and gives the type of that value. And I have the command, the "k" command, which takes a type and gives the kind of that type. Right, so if I ask for the type of true, the value true, I will get bool because it's a Boolean, right? If I ask for the type of hello, I will get array of chara. If I ask for the type of array of true, I will get array of Boolean logic. If I ask for the type of the empty array, I will get array of a being a type parameter, right? So if I now ask for the type, or for the kind of bool, excuse me, I will get star, okay? If I ask for the kind of string, I will also get star. If I ask for the kind of array of bool, I will also get star. Just have to remember that the kind star is the type of all monomorphic types, right? Not only, but all monomorphic types belong to the kind star. And then if I ask for the kind of the array without the type parameter, right? I will get the kind star to star. And why star to star? This could be seen as a function type, right? And this means if you give me a type of kind star, like string or bool, like this example, I will get you a type of kind star. So if you give me bool, I will give you an array of bool which has kind star. So that's the idea behind kind polymorphism. And for the last example, not the last, but almost the last, I want to show if I define a value like this id, right there, id is a function from a to a. So a is the type parameter. And when defining that value, I'm quantifying over a type to define my value, right? Now, I want to define a type, and that type, I will have a parameter. And my type will have only one constructor. So by the way, that proxy type is just a way to tag a value with a type, right? And which is the interesting thing is that example is that that t parameter is actually a kind. It's a kind parameter. And if I create one value, like proxy one, with proxy value, and I set the type, I set proxy value to the type proxy int, right? T will have kind star, right? And if I create this value, proxy2, and I set proxy value to the type proxy of array, that proxy to that the t kind will be star to star. And if I ask now for the type of proxy1, I will get proxy of int object. This is that type. If I now ask for the kind of proxy of int, I will get star object. If I ask for the type of proxy2, I will get proxy of array. Okay. If I ask now, if now I ask for the type, for the kind of proxy of array, I will get star. Okay. Little word, but okay. If I ask now for the kind of proxy, just proxy, I will get k to star. So you see right there that I'm not going from star to star, I'm going from k to star, k being a type, k being a parameter, kind parameter, right? So that type will work with any kind. And the great news about kind polymorphism is that kind polymorphism is coming in Scala 3. So stay tuned. For that example of kind polymorphism in Scala 3, so that example is taken from the Dot documentation. So, and this is how to define the kind polymorphic function in Scala 3. So for that function, I take a type parameter. That type parameter should be a subtype of any kind. And if you call that function f with an integer of kind star, it works. If you call it with a list of kind star to star, this should work. If you call it with a map from kind star to star to star, this also works, right? So that's, and by the way, you just see that this look like bounded quantification that you just see before, you have just seen before on the type level. So this is all for me. This is some links if you're interested that I use for my talk. So thank you very much.
Thank you very much, Stefan. So I'm going to give you a little clap. I'm sure the audience would love to clap too.
Thank you.
Oh, okay. So I have so many questions, but unfortunately we're out of time. So I think I can only pick one of the many that I want to ask you. So you've explored a variety of different type systems here, the ones in Haskell, Scala, and also TypeScript.
Yes.
And there are different things that you can do in each of them. Which type system do you prefer?
The type system I prefer is actually Scala. For it, well, it's very simple because Scala Haskell doesn't support subtyping, and for some there are some cases where I really need subtyping. For example, when I want to express in my programs a hierarchy of error, for example, in Scala, we could use the exception, which is the on hierarchy given by the type hierarchy given by the prelude like which is into the language, and this is quite useful. And in Haskell, for example, if I wanted to do something like that, I will have to trick with existential types and so. And TypeScript also is a very interesting language. And but the problem with TypeScript is that there are a lot of shit in the type system, like falsy values, which I don't like. And by the way, don't get me wrong, Haskell is very interesting. Is a very interesting language, and I think everyone should learn a little bit of Haskell, because for certain concepts, it was easier to grasp them in Haskell because it's much more simpler. So, but my preference will go to Scala.
Yeah, and I'd second that as well. In that there are some times as well where in the Haskell type system there are things I want to do. The different language extensions in Haskell can make the type system quite interesting, of course.
Yes. Yes.
Okay, so now I'm going to direct all the participants and you as well, Stefan, to the Q&A room where you can all ask more questions. I will paste it in the chat. If you go to the Q&A room, feel free to share your audio and video and ask questions. There'll be questions in an unrecorded room, so you can be a lot more casual.
Okay, I want to say a little thing, because something just asked if this presentation will be available somewhere. I gave the link to my blog, and that presentation is actually uploaded to my blog. So if you're interested to look at it later.
Yes, and what we can do at Scala Love is that we can share the presentation on our Twitter feed. So if you follow us on Twitter, we will share the presentation and you can have a link to it. We are also recording it, so you can view a recording afterwards, put it up on YouTube. Okay, well, thank you very much, Stefan.
Thank you.
Please head over to the Q&A room.
Okay.
Thank you.
See you later.
That was the link that I just posted.
Okay, I'm going to that.
Okay, now we have a few minutes before our next presentation, which should be by Adam.
Hello, I'm here. Just in case.
Hello.
We still have 10 minutes, right?
Yes, we do. So you can take plenty of time to go and do all the preparation that you need.
Okay, cool, thanks. Maybe I will start sharing my screen just to verify it works fine.
Yes, I can see your screen. It looks fine.
Okay, let's check presentation mode. Does it still work?
Yes, it does.
Okay, awesome, awesome.
That's great. You might want to just enter a bit more text just so that I can see how long the line is.
Sure. Let's see where the demo, for example. I guess, you know, you see the same thing that I do, right? It probably ends somewhere like that's a long line, somewhere over here, right?
Yes, it does. Good.
Right.
Cool. And I can see your cursor very clearly as well. That's great.
Okay. So let's go back to the first slide and wait for a bit.
Okay. Cool, and I can see your video as well. That's great.
Yeah, I just wanted, just for the beginning, so that people can see that I'm real and so on.
Yep. Gosh, it's interesting doing virtual conferences, isn't it?
Sorry, again?
It's interesting to have a virtual conference.
Yeah. I think I did a couple of talks, but that's only my second one, which is online. But I guess we'll be getting more experience in that now.
Yeah, definitely. It is quite nice being able to present and also host from your own home, I have to say.
Yeah, and so far it works well. I hope I won't be an exception. We'll see.
I'm sure you'll be absolutely fine. Although you are the first person live coding.
Okay. Well, but there's always the external forces that you can't control, like a power outage, internet outage, and other things, which are independent, really. So you never know.
I'm sure we'll be fine.
It's a distributed system, so even if one node fails, meaning me, other nodes will be able to take over, right?
Yep, I'll whip out IntelliJ and try and write something on HTTP endpoints, get started using Tableau.
Why not? It's quite simple.
It is, actually. It is. I was looking at it the other day. I needed to use something for some kind of Swagger generation, stumbled across it.
Right, that's the goal. That's the goal.
Yep. Let's wait around 5 more minutes for a few people to trickle in, and then we can get started. Have you done this live coding demonstration before?
I did a live coding of Tapir, not this particular one, but similar ones, I guess. It's not such a big library that you can do that many variants. So yeah, I did a similar one, but not that particular one.
Okay.
There's always some new angle that I try to explain some concepts to people. So
yeah, I always find whenever I give a presentation that I learned so much in giving it that the next time I give it, it's never quite the same.
Oh yeah, sure. It's continuous improvement in presentation giving. Hopefully improvement, at least. I don't know. That's from my point of view, at least.
Yes. You've been presenting actually quite a few things, haven't you, on HTTP and web services?
Yeah, well, I did HTTP back in the day. So yeah, I did a couple of those. It's a topic that is near to my heart, let's say.
Yes. And certainly it's very good. I have to say that all your blog posts and your presentations have been very helpful to me as well. Doing a lot of...
Thank you.
Yeah.
Always nice to hear that somebody finds it useful or bearable to read.
Oh, it's definitely very useful. It's always a challenge, isn't it, with those kinds of things, because you throw them out there and you're not really sure who is reading them or who is finding use out of them.
Yes,
the same
sure.
is true for conferences as well, right? But,
and you yourself, the stuff you're talking about pretty well, or at least you're supposed to know it pretty well. And the more you know it, sometimes the less you're able to explain things to people clearly, because you just assume too much. So you have to be cautious here. So yes.
Yes, definitely. I think that your posts are always very good in explaining things clearly and at the right level, which is something that I take inspiration from too.
Well, hopefully we'll keep it that way.
Let's just wait one more minute for people to trickle in. Just a note to all the participants that during the talk, if you have any questions, please ask them on the Q&A channel, which you can find at the bottom of your screen. And if it's a question which is relevant to the code at that point, then I'll ask it during the talk. And if not, I'll ask the questions at the end. So please post on the Q&A channel. Okay. And Adam, I think we're ready to get started. So I'd like to introduce you, if that's okay.
Sure.
So everybody, please welcome Adam. Adam is a pretty seasoned Scala developer. He's very well known for his helpful blog posts on functional Scala development, as well as presentations. He's an enthusiastic open source contributor, and he's involved in a lot of projects and web services, such as STTP and Tapper. And Adam is going to use these today, particularly Tapper, to show that our HTTP endpoints are data as well. Please welcome Adam.
Thank you very much. It was a great introduction. I might steal it actually, and use it maybe somewhere else. So yeah, thanks again, and thank you very much for coming. So this will be mainly live coding talk. We will do a short introduction, and then we will try to do some code. We'll see how it all works. So the topic that we will be dealing with today is HTTP endpoints. So you might think that it is such a common task. Why are we still dealing with that? Shouldn't it be a solved problem right now? So on one hand, yes, but on the other, we are doing more and more systems, and they expose more and more endpoints, more data. That it's also becoming a task that you have to do more often. And we are still, experimenting and trying to come up with ways which makes it easier and to expose API endpoints and to make it more type safe, to have more properties checked by the compiler so that we don't have to check every tiny detail. So it is still an evolving process, and we are still looking for the best approach. And I would like to offer one possible solution for the problem of describing how your API should look like, and separating some concerns which maybe weren't before separated. So before we dive into the code, I would like to do a very quick overview of the current situation. So how you might approach creating an HTTP endpoint right now, right? So if you are doing Java, you would probably end up doing annotations. And using annotations, either using Spring or JEE or some other framework. And this works in a number of cases, but still there are some shortcomings, right? So here we have an example endpoint, which is mapped to the get method, and it corresponds to the given path. And as a response, it produces some JSON, right? And so it looks fine. However, we can see that here we have some string references, right? So this isn't really checked by the compiler. Also, what isn't checked by the compiler is that the actual combination of these annotations makes any sense, right? So all of these are checked at runtime, right? These annotations might only be allowed to be combined in a specific order or something like that. They might even come from different packages which don't make sense. So all of these properties are only verified when the endpoint is actually being exposed when the application starts. In a similar way, what isn't checked by the compiler is that we can actually serialize the data type that we have here, which is a book to JSON, right? We again have a runtime reflection-based mechanism for serializing data. So the compiler isn't very helpful. Annotations are type safe, but in a very limited way. So annotations form like a mini language inside of Java, which has restricted syntax and which has different typing rules than normal Java. we don't have any abstraction capabilities. So unless the framework really gives us a way to combine a couple of annotations into one or to somehow abstract over them, you can't do it. You can't have like a parameterized annotations which produces another set of annotations. So the metadata layer, which describes how the endpoint should look like, it's very static, right? You have to spell it out exactly. You can't really manipulate anything in here. So, you know, annotations, they have definitely served their purpose very well in the Java ecosystem, but maybe it's also time to look for something better. And Scala has a couple of alternatives here and a couple of answers. One of them, which is probably quite well known, is Akka HTTP, right? So here we also have a description representation of an endpoint, which is also a get endpoint, as you can see. So in Akka HTTP, we describe the endpoints, we define the endpoints by combining a number of directives. Each directive is a function which takes in the request and either accepts the request. So when the request is accepted, the inner directive is executed, or rejects it, which means that the next route should be checked, right? So here we have like a filtering directive which only lets through get requests. Then we have a path directive, which also not only checks that the path matches, but also extracts the second segment. And the second segment, this will be a typed. This now is checked by the compiler that the function over here, this must be a function which takes a string and returns some further routes. So here we have more type safety. And we also, you know, at compile time, it's checked that we can actually serialize the book to some format. Here, this will be a JSON format. So this again might seem like a very nice solution, and indeed, it's very useful. It's a very nice if it's very flexible and it's very powerful. However, one thing that is missing, which is often a problem, is that you would like to somehow easily document your endpoints. To generate, for example, OpenAPI or Swagger documentation. And this isn't really possible with an approach like this. Why? Well, the route, if we look at the implementation of the type, well, it's an ordinary Scala function which takes a request context and returns some result in the future, right? And it can be any Scala function. So it's a very opaque definition. We cannot look inside. We cannot inspect it. So we cannot take a route and see, well, is it a route that actually only allows GET requests or not? Well, that's not possible, right? We actually have to provide a real request to see if it will be accepted or not, right? And we can't really even then tell what kind of properties of a request have been checked that allowed it through or not. So, so this kind of defining endpoints, again, very flexible, very useful quite often, but also opaque, and it's not possible to inspect what's inside. In a similar way, but with a different APIs, we have HTTP4S, which also defines a function. The syntax is quite different, and in many ways, HTTP4S takes a different approach, but the general idea is the same. We define HTTP routes, which on a high level are a function which take a request context and either let it through and provide a response or reject it. And again, the syntax to define the matching is different, but the problem is the same. It's a very opaque definition, so we cannot look inside and we cannot see what kind of properties this endpoint matches or not. So it's not possible to say anything about the endpoint just by having an instance of an HTTP route. And this is needed if you want to generate documentation or things like that. So there is a project in HTTP4S, it's called HTTP4S Row, which actually creates a reified description of the endpoints, which is somewhat similar to Tapir, what Tapir does, as we will see soon. However, the API is radically different. And one of the goals of Tapir is not only to provide a way to describe endpoints so that they can be interpreted and so that they can be converted to documentation, but also to provide a very programmer-friendly API. So that's one of the main goals of the APIs, of the Tapir API, is that the way you describe the endpoints is readable, even for somebody maybe who doesn't know the library that well, and that there are no surprises, that you can actually guess what the methods do, and so on. So if this goal is achieved, you will be able to tell quite soon, hopefully. So now going into some more details about Tapir. What is the general idea of Tapir, right? So the general idea is that we want to describe our endpoint using a data structure. So instead of creating a function which is opaque and which cannot be introspected, we will define a data structure which describes what kind of properties, what kind of inputs and outputs does the endpoint have. And in this description, all of the requirements, whether we are reading a query parameter, a path parameter, a method, what kind of body we produce, this will be all represented as values, as data. And this works quite well because our programming languages, and Scala in particular, are really good at manipulating data. So just as we manipulate normal, let's say, business data, we can use the same language to manipulate data that is then used to expose HTTP endpoints. So this description is completely separate from any server, client, or documentation implementation. It doesn't depend on any effect library. So it's just a normal data structure. And then, having this data structure, we can take it and convert it to a server, or we can convert it to documentation or to a client. So we will see how it works in practice. And just before we start coding, a short introduction on what kind of experience do I actually have. So some credentials as of HTTP APIs. So I've been doing this for quite a long time, I think 14 years, starting with J2EE. So I know how not to do it. And JBoss Theme, Spring, and so on. Then I moved into Scala. So I did Lift, Spray, Akka HTTP, HTTP4S, and then I started doing Tapir. I'm still using Akka HTTP and HTTP4S, by the way, if the task requires it. I guess I had quite a wide view of how you could actually implement HTTP endpoints. Now, as to what I'm doing daily, I'm the co-founder and the software engineer at SoftwareMill, which, as a company, our aim is to scale businesses through software, help businesses scale their how they work through software. And in practice, this means writing distributed systems, big data systems, ML, and so on. So mainly on the backend, we use a lot of Scala, also Java, Kafka, Cassandra, and so on. And I'm also doing a couple of open source projects. One of them is Tapir. Okay, so let's go to the live coding part, and that's where things will start breaking. So as we probably all are well aware, we are supposed to sit at home, so we do. And I heard some people have a lot of free time because of that. And I suppose if you have a lot of free time, one of the things that you do is reading books. So we are going to write a very small application which will store the books that I've read. So here we have a representation of the business entity that we'll be dealing with, which is a book. We will be storing only the title and the year that the book was published. Here is our database. So the database, as you might have noticed, is stored in a var. So you should never do it, right? So that's only during demos, only for demos. Demos, how do you write that? Maybe like that. Okay. So it's thread unsafe. There will be race conditions if you try to access it concurrently and so on. But it will work hopefully for that purpose. So what we will try to do is we will try to describe two endpoints. So the first endpoint will be an endpoint to get a list of books, and it will take two query parameters. The first will be an optional year parameter, which will filter the books by the publishing year, and the second will be a limit parameter so that we can limit the amount of results that we get. So let's try to describe these endpoints. So I will first use the Tapir API to describe the endpoints, and then I'll try to explain how this all works and why this all works the way it does. So we will create a value that will represent our endpoint. This will be the books listing endpoint, let's say. And what we start with is we start with an empty endpoint which doesn't have any requirements on the request or on the response. So an endpoint which doesn't do anything, and that's called endpoint. But before we use it, we actually have to import it from the http.tapir package. So we import everything from that package because there's a couple of methods and values which will be useful. And that's like this import provides the main API for actually describing endpoints. So here we have that empty endpoint value, and now we can customize it. So we can customize it by saying that we require that on the input we have the books path, and we require on the input a query parameter which will be an optional int, and the query parameter will be called year, and another one will be called limit, right? So once we have that, we can say that on the output, what we want is we want a JSON body, which will be a list of books, sorry. And here we have another unknown symbol. So we actually have to specify how we would like to represent our data as JSON, right? So we need some way of serializing JSON and deserializing JSON. So we can use any existing Scala or Java library for that, but it needs to be integrated with Tapir. It's quite easy. There's a couple of integrations available. So here we will be using Cersei. So we will import the Cersei integration, json.cersei, and we will import Cersei's. We will import automatic Cersei derivation of codecs so that we don't have to do it by hand. So this import over here, what it does is it brings into scope the JSON body method. The JSON body method returns a value, which is a description of an endpoint output, so of a component of what an endpoint might require, which corresponds to a body that is serialized as JSON. So we will come back to that later as well. One more thing that we might want to specify in our endpoint is what should happen if there is an error, right? Maybe the limit is negative, or maybe the year is to find the future, well, whatever error there might be. So in case of an error, we will return a string body. So returning errors or normal outputs is such a common use case. So almost in every case, you have a different kind of response in case of an error and a different kind of response in case of success, that these two are separate. Okay, so we have described our endpoint. In a similar way, we can describe an endpoint. So now we will describe an endpoint that will actually add a new book. So what we will do here is we will define an end book endpoint, and it's again an empty end. We take the empty endpoint. It needs to correspond to the books path, and it needs to take the JSON body of a single book this time as an input body, right? So here we have used the JSON body description, and we have specified that it's an output of the endpoint, right? Because that's what the response will contain. Here, the request has to contain the JSON body, right? So this value is usable both as an input and as an output. In case of an error, we are not very inventive. We will just return a string. And additionally, we require, because that's a potentially sensitive operation, we will require a header, which will be a string. And this will be our secret authentication token. And we are using a custom header because we are doing security by obscurity. Why not? Okay, so we have now described our second endpoint. What are these values that we have defined here? So what we might do is we might ask IntelliJ to infer the type for us and see what's sitting here. So maybe let's break the line over here. Format the code. Okay, code formatting brought it back. Okay, Okay, actually, that's enough information. So what we see here is that the value, the books listing value that we have defined, this is a value of type endpoint. We can go to the definition of type endpoint, and you can see that it's a case class, right? So it's as we have, as was our goal, this is a data structure. This data structure contains a couple of fields. So it contains, the first field is an endpoint input, which describes the inputs of the endpoint, right? So what kind of data, what do we extract or what do we map to from the request? And then there's the error output, which corresponds to the response in the error case, and the normal output, which corresponds to the success case, right? If we now go further in, and if we navigate to endpoint input, we can see again, it's a data structure, a sealed trait. A data structure like any other in Scala, there's nothing special about it. It has a couple of implementations. So things you can expect: a body, a cookie, a header, a query parameter, again, and so on. We can, for example, go to the query. Again, the query is a case class, so a normal data structure. What the query contains, apart from a couple of other things, is the name of the parameter, right? So all of these requirements are reified as data, and thanks to that, we will be later able to introspect things and see how the endpoint is constructed. So going back to our main example, here we have created this data structure. And what are these type parameters over here? Well, the type parameters correspond to the data that we extract from the input and that we write to the output. So the first type parameter corresponds to the input that we to the data that we read from the request. So here we read two optional ints. The first optional int corresponds to the year parameter. The second optional int corresponds to the limit parameter, right? There's no other information that we read from the input. There's also the requirement on the books, on the path, but it doesn't extract any data from the request, right? It's just a filter that the path must match. So it's not represented in the type over here. The second type parameter corresponds to the output in the error case. So here we have a string and here we have a string. And the third type parameter corresponds to the success case. So here we have a list of books and here we have a list of books as well. There's also the fourth type parameter, which is concerned with the streaming requirements. So if we used some streaming, that would be specified, but here we are not. Is there a question or something like that?
Yes, there is a question.
Yeah.
Hi, Adam. There's a question on HTTP status codes. Do you specify the HTTP status code anywhere when you're listing the endpoint?
Yes, that's a very good question. So by default, if the endpoint completes successful, the status code will be 200. So if this output will be used, if there's an error, the response code will be 400. But you can customize it. So there's a couple of ways to do it. So there are dedicated outputs which are called status code, and there's a couple of them. So you can say that this endpoint always results in a given status code, or that the status code will be provided by the logic of the server, or that the status code actually depends on the implementation. So maybe you have like a sealed family of case classes, and for each implementation you want to have and depending which implementation is returned by the server logic, you want to have a different status code. So then you can use an output which is called one-off, and here you enumerate the cases. So that's how it looks like, and it's all in the documentation if you would like to explore further. Okay, so carrying on, in a similar way, we can add the type annotation to this endpoint, and you can see that here we have similar things. So on the input, right, we read the book, which is the book to add, and we also read in the authentication token. So the inputs are a bit different, but the idea is the same. One difference is that we don't really return anything in case of success, right? If things succeeded, we just return a unit, meaning just return 200 OK, and that's it. Okay, so these methods, these .in methods and .out methods and .error out methods, what they do is they extend the list of inputs and outputs in a given case class, right? So here we have an empty endpoint description, meaning that there's no inputs, no outputs, right? And each time we invoke in, what is modified is actually this value over here, right? A new input is appended to the list of inputs, and each time we invoke .in and .out, we get a new immutable description of our endpoint, which we can reuse. Yeah, and another question.
Yes, we do. So it's a question on API and Swagger generation. And then we'll have another question as well. Is there support for OpenAPI to generate Swagger or YAML files for the
Yes, of course,
groups?
of course. Yeah, we will get to that quite shortly. Yeah.
Yes. Good. And another question on specifically on this logic is by endpoint type, we can't tell what is the which its input type is query path or body. Yes, no, this information is in a way lost. Yes, you cannot from the type you cannot say that. But it's also, I usually don't find it that useful. If you do need to know if it's coming from the query and so on, and you can map it, right? So you can map it over here to some like query holder and something like that, right? And then you know that it's from a query if you actually need to know it, but you usually don't. Okay, so yes, carrying on to the interpreter part. Now we have the descriptions of our endpoints. So let's interpret them as a server so that we can actually see something in action. So what we do is we will interpret our servers into HTTP routes. We could also interpret them into HTTPS routes or play or Finatra, doesn't matter, looks exactly the same. So in order to interpret these endpoints, what we need to do is we need to take our, for example, our add book endpoint, and we need to import the interpreter. So the interpreter will be import HTTP tapir server HTTP. So this brings into scope an extension method, which will allow us to convert the description of our endpoint into an akka route. So in order to do that, we actually need to provide the missing part, which is the business logic, right? We have the structure that we had the description of the structure which describes the endpoint, but we don't know what should actually happen. So this import over here, what it does, it brings in an extension method called toRoute. And here we have to provide the business logic. You can see that it's typed according to the type of the endpoint. So the business logic as the input takes a tuple which corresponds to whatever is read from the request. And on the output, we have to return either an error, which is represented as the left part of the string, or success, which is represented as the left part of the either, sorry, or success, which is represented as the right part of the either, here a unit, right? So these three types, the book string tuple, the string, and the unit, these correspond to the three type parameters in the endpoint description. And because we are in akka land, everything is wrapped into a future. In a future, if we were interpreting into HTTP4S, everything would be wrapped into the IO monad of your choice. Okay, so let's say we want to add a new book, and here we have our authentication token. So the logic will be quite simple. So if the token is different from secret, it's very simple security, not very secure, but still, then we return a left, which is unauthorized access. And otherwise, we modify our in-memory database. So books equals book concatenated with books, and we return a write of a unit. And everything needs to be taken into a future block because we might potentially call a database, and this will be the add book route.
In a similar way, we can interpret our book listing into a route. Book listing route is book listing dot to not book listing, books listing, almost. Books listing dot to route, and here as an input we had the year filter and the limit filter and the limit filter. Right, so what we do is we have filtered books is year match. So if the year is defined, then what we do is we take the books and we filter them so that the year matches. If the filter is not defined, then we just return the books and we apply the second filter, limited books, limit match. And if there is a limit, we take the filtered books and we take the limit number. Otherwise, we return the filtered books, right? So we apply both filters to our in-memory database, and we always return success. So we always return right of limited books. And again, we need to wrap this into a future, maybe like this. Doesn't matter really. You could also use future.successful. Okay. So what we have done now is we have coupled each description of endpoint with the server logic. Once we couple the description with the server logic, we can actually convert it to an akka route, so a function which will be understandable by akka. So the concatenated route that we want to return here is add book route concatenated with books listing route, and I'm missing an import so that I can use the tilde there. Akka HTTP Scala DSL server directives. Okay. Yes. Okay, so this was needed so that I can concatenate. So now we are in akka land, right? We have interpreted, we went from the Tapir land, which was descriptions. We added the server logic, and now we are in akka land, meaning that we have a route which we can expose to the outside world. Okay, so this concatenated route will be stored over here in our books routes value. So what we can do now is we can actually start the server. So to start the server, what we have to do is we call await.result, NAGLU HTTP, bind and handle, and routes localhost 8080. And we will wait up to 1 minute. And our routes will be how did it was called, books routes, right? Okay. So what is missing here? Probably some kind of implicit. It should be all http.bind and handle routes. Yeah. I don't have the import Scala concurrent the execution context, right? Is that what I'm missing? Scala concurrent implicit global. Ah, no, I'm missing the I know I'm missing the actor system, of course, because we are in akka. Yes, implicit. I have it in my notes. Implicit val actor system. Actor system. Really don't need that. Yes. Okay. Now it will compile. So before actually running that, let's do another interpretation of our routes. So because as somebody asked, we will now interpret our routes, the same descriptions into OpenAPI YAML documentation. So that's a different interpreter that we have to import. So what we need to do is we need to import http tapir docs OpenAPI. So that's a different interpreter which also takes the same data structure but returns something different. So having that in scope, we can take a list of our endpoints books routes, and we can call the two open API method books I've read. And of course, it's red because why not? Books routes, yeah, not routes, but books listing. Yeah, books I've read and the version number 10. And this will give us an open API object that we still have to serialize into YAML. So we will import the serializer as well. HTTP or tapir open API serc YAML. And now we can, so this will return a data structure which corresponds to the open API description. And now we can call to YAML. And this will be a string. So now we have interpreted the same data structures as documentation. So now we have a string with the YAML. We still have to expose it, right, using the Swagger editor. So we will expose it over here in our server. So the way we do it is we take the built-in Swagger akka of the YAML that we have open API YAML over here. And we take the rows. Okay, there's a question.
There are quite a few questions, just to make sure that people are on the same page. So could you show again how you specify get and particularly post?
Ah, yes, that's a very good question. Let's go back to our descriptions. I didn't specify it. So I didn't include in the specification, in the description of our endpoints, I didn't include information that this should be get or post. So actually both get and post would work in this case. So get and post are additional inputs and they are added by the .get and the .post methods, like over here. So what this does is this adds a new input, which doesn't extract any information from the request. It just specifies that this endpoint must be a get endpoint. So yes, that's a very good observation that I forgot to do it. And now things will work. So maybe before we jump into the next question, let me just run the code and we will see if it actually works. Because we have now interpreted our endpoints both as logic, both as a server, and we added documentation. So by opening the Swagger API, we should see our books. So we can try out the books, and if yes, here are the books, right? And we can say that we only want 3 books. So we have 3 books. So yeah, things work nicely. Yeah. So now we can. Another question.
Yep, a couple more. So the next question I think relevant to these particular endpoints is, let's say that you wanted to use a custom type for any of the query parameters or even header values. Could you have a custom decoder?
Yes, of course. Let's go back to the box listing. So these options, they are probably quite surprising. Like if you look at the description, if you look at the type here, you don't really know what these options are, right? But we can have like a case class limit of an int, right? Something like that. Let's just make it top level. And you can have, let's say we will extract the limit. So we can now create a limit, limit parameter, right? So we have extracted, because all of these methods, what they do is they return values. These are immutable values, which you can use multiple times. So we can create on the side, like a description of a limit parameter that we can reuse multiple times. And let's say we now want to map it to a case class. So we can use the map to helper method, which maps things to a case class. What's wrong over here? Maybe because it's not type, maybe because it's not top level. Of course, something broke, but don't worry. Because there's, I know, because there's an option, of course, an option of it. That's what was wrong. Or maybe not. Anyway, that's how you would do it, and what you would get from it. Now it worked. Endpoint input of limit, right? So now that we use the limit parameter over here, we need to change the type over here as well. And probably in a couple of more places when we actually try to compile things. Yes, so here limit dot L, because now we are dealing with an instance of the limit class, right? So we have to unpack the real limit. And yeah. Okay, so things compiled. What we can also do is we can combine multiple parameters. So we can have case classes which have a couple of fields. We can take a couple of parameters and combine them into a tuple and then map it to a case class. So basically using the map methods, there's a couple of them. Some of them allow reporting errors during encoding and decoding, some of them not. So there's quite a lot of flexibility in how you want to represent your data. The important thing is that all the time you're dealing with immutable case classes and you can extract common things. Another thing that you might want to do also is you might see that actually these two endpoints, the books listing endpoint and the edbook endpoint, they share quite a lot of common things, right? So they correspond to the same path and they report errors in the same way. So what you might want to do is you might want to extract a common part of that, create an abstraction, which actually expresses these common things that you might be using in multiple endpoints in your system. So you might have a base endpoint, which is an endpoint which corresponds to the book's path, and in case of an error, it returns a string, right? So that's what is repeated in both of our endpoints. So we might create such a description, which can then be further refined, and we can use it instead of the previous one, right? So over here, right? So we can take our base endpoint and remove the parts that are repeated, and hopefully the code will still compile. Yes, there's some warning, but let's not worry about that for now. Yeah, okay. Hopefully this answers the question more or less.
Yeah, I think that was pretty comprehensive. Thank you very much. So a couple more questions just before we move on. Does this also support GraphQL as opposed to just REST?
Not yet. I know there's I forgot the name, sorry. But there's a person behind Caliban. So he attempted to do some integration. I'm not sure at what stage it is in. I don't think it should be a problem. Even if not directly, like Tapir coexists quite well with other solutions, right? Because at the end, you just create an Akka route, an HTTP route, anything like that. And you can have part of your system being specified with Tapir and maybe some specialized endpoints you might want to still implement using pure Akka HTTP and so on, right? So over here, you get an Akka route or an HTTP route, right? Or whatever. It's a route like any other. You can nest it in directives, you can combine it with other routes and so on. So even if there's something that Tapir doesn't yet support, you can still use the full power of Akka HTTP or whatever server framework you're using. So this might also apply to Caliban currently. So yeah, that's the answer I guess is to look into Caliban and how does it work.
Thank you. I think that's a pretty cool design ideology, actually, making sure that you can still compose it with existing HTTP routes and other systems.
Yeah, I guess the whole philosophy of Tapir is to be quite to be quite independent from specific frameworks and to not to be bound to any to properly separate concerns. I think the concern of describing endpoints is totally separate from other concerns, such as what kind of effects library do you use, right? So as long as we are describing things over here, the server logic might use futures, it might use Zio, it might use Monix or whatever else, right? It's totally irrelevant to the description of the endpoint. And I think it's I view it in terms of a feature, right? So in that way, I wouldn't necessarily see a need for like Monix HTTP or Zio HTTP and so on, because you can describe the endpoints using just case classes. Like the core library doesn't have any dependencies at all, except Magnolia, I think, to generate schemas. and then you can use any kind of effects library to implement the server logic as you wish. Yeah, I guess we are getting to time limit, right? So we didn't, we just scratched the surface as to what Tapir can actually do. There's also the possibility of generating clients so that you can convert the endpoint into a function, and the function, when it's called with the proper input parameters, will actually perform the HTTP call. There's also testing support, so you can create a stub endpoint basing on a description, so which you can use with HTTP client, for example. So there's a couple of other interpreters that might be interesting. I had some clothing things, if you'll allow me, maybe. I think one important thing is noticing where is FP in all of that, right? Because we didn't really see a lot of monads, anything like that. And I think it's good because I think FP isn't about functors, monads, anything like that. Also, Lee Hayoi had a very good introduction to what actually FP is in the morning. And he had a very nice analogy with tiramisu, which I don't have. I have a more technical one. So maybe you could refer to his as well. However, the FP here is that we have immutable data structures, which are endpoint descriptions. And then we have a number of functions which operate on these data structures, right? So we have the Tapir API, which itself manipulates these descriptions and creates more complex descriptions from simpler ones. And we have the interpreters, which convert these descriptions into other things like documentation servers and so on, right? So that's where the function programming is, right? We have the functions which manipulate immutable data structures, and that's all what FP is really about. Just to summarize, 1 minute overtime. Can I be 2 minutes overtime? Just to summarize it, so that you know what are the gains and losses, right, from using Tapir. So I guess as I said, I guess I'm mostly outlined it before answering the question. So I guess the separation of concerns is one gain, the flexibility that you have, the abstraction possibilities, but also you know that the code reads nicely. It's, if you look at an endpoint description and you read it out, you probably have, if you don't know Tapir, you probably more or less suspect what it might be doing. And some of the losses, of course, right? The Tapir API isn't yet complete. It's a library which doesn't have a 1.0 release yet, although we are using it in production in a couple of projects, and other brave people are using it as well. However, yeah, there's still some work to be done. As I said, Tapir coexists peacefully with other libraries. So if you, for example, if you need to use WebSockets, you would need to use HTTP or HTTPS directly for that. If you want to filter requests like in an aspect-oriented way, let's say, you would need to use a directive or a middleware as well. That's probably coming to the API, but it's not like the main goal. So you know you probably will still need to work with those other abstractions. And to end, yeah, to end the presentation, the whole code is available on GitHub. So if you'd like to go and play around, that's where it lives. You can import it into IntelliJ or Metals or whatever and try to break things. I invite you to our GitHub channel or to create issues on in the project if something isn't clear. And yeah, if you want to stay up to date on Scala news, subscribe to our Scala Times newsletter. And I guess, yeah, that's everything I had. Thank you very much.
Thank you very much, Adam. That was, well, that was pretty awesome. So there are a ton of other questions, but unfortunately we don't quite have time. So if you do have other questions, please go to the QA room, which I will post. There is one very important question which I wanted to ask, which actually is on this screen at the moment, which is please share the link to the sample project. Do you mind just putting that in the chat as well?
Sure. Should that go into talks room or?
There's a Zoom webinar chat just below.
Zoom webinar, more chat.
Okay, just for everybody who's attending right here, and I can see that you have. All right, and I'm going to just post the link to the Q&A room. Um, hold on. There we go. So that's the link to the Q&A room.
Okay,
Um,
so I hope to see you there soon.
Okay, unfortunately I can't come and join you, but all the other
Okay,
participants
right,
can.
right. You have the next talk, right? Okay, so yeah, to the other participants, I hope to see you there soon. Okay, so talk to you later, and thanks a lot.
Thank you very much.
Hello.
Hello, Ollie.
Hello, how are you doing?
I think we're doing pretty well. Had
That's
some lovely talks so far.
That's great. Victor, hello. He's not here. He's here.
He is here, but he is muted, probably getting set up.
Okay. Let's wait for him. Sweet Read by Ollie, yes. Someone raise their hand.
Is it Sandeep who's still running the Q&A session for the Joy Room?
Come again?
Whoabouts is running the Q&A session for the Joy Room?
Who's running? Oh, Victor is here. Hello.
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 This is
Good morning,
nice.
good evening, good afternoon. I don't know where everyone are, but it really doesn't matter.
This is nice setup.
Oh, thank you. Just a few more seconds to polish some slides, as always.
Last minute. Real pro. That's how podcasting happens. Someone said in the chat.
Yeah, it definitely is. I really like your setup, by the way.
Thank you.
Yeah, and thank you for saving us. Last minute, huh?
Like a boss.
Yeah.
Victor, you have a question on the chat already asking how big your monitor is. It does look pretty huge.
Which one? I have a 3.
We can only see the corner of one.
Yeah, that's intentional. It's kind of like makes people engaged. You know, they'll try to say, okay, what is going on that screen? You know, there's some bunch of code. What is happening over there? So that's why. Okay, so in this case, for some reasons, I probably need to still hide this because I might have some speaker notes there. So in this case, they don't want some of the link to live stream.
Don't worry, we can't see anything now.
Nice. Yeah, this is the purpose. Because I don't share yet. All right. I think we're good. All right. So I will move all videos over here. And I will do share screen. So where I should look for the questions, or you will call out those?
Yes, I will call them out. So it's entirely up to you how we want this to happen. I can ask you questions during the session if you like. I'll turn my video on and wave around a bit, and that's how you'll know that there's a question.
All right, so let me rearrange this. Do you see my screen by the chance?
Yes, I do. It looks perfect.
To this one, not to this one.
Just so you know, the right side of the screen is going to be obscured slightly because of the gallery view of you speaking as well.
Right side?
Yes, the right side will be just maybe the right inch of it.
So tell me which part is obscured right now.
Let's see. We can actually see all the text right now, which is great. You have maybe a little bit of space next to how things work, and then we can't see the rest of the right of the screen, but that's absolutely fine. It's nothing to do with your setup whatsoever. It's just because.
So the right side, you know, I always confuse which is right, which is left.
Oh yeah, me too.
Okay, doing full screen. Let's test some slides if we can see slides in the right place. Not this one. Yep. So we're seeing good slides.
Yes, we can. So at the moment we can see whose tweet, and just to the left of, to the right of that, we can't see the text, but that's absolutely fine. I think you probably won't have much content on that side of the stream.
Let me just move it a little bit. So in this case, I would be.
I wonder if instead of maximizing it, perhaps if you moved the window a little bit, so if you shrunk the window on the light side.
Yeah, in this case, like if I will do windowing, some of the animations will not be executed in and some of the like animations and transitions, they will not be. Well, we'll see how it goes. Like,
yeah, I think we should be all right.
If it's gonna be a huge problem, we can always like re-record this when we will publish. That's it.
Okay.
So.
Oh, we have some comments from people saying that they can see the whole width okay, and even see the minimap. So actually, that's probably absolutely fine. It might just be just my setup. I think that's true. I think you can configure
that's cool.
this.
We're okay.
Yes. Yes,
okay.
That is absolutely fine. And I can see that we can configure this on Zoom as well. So that's absolutely fine. Great.
All right. I think I don't know how I can. No, I will see. My Zoom chat is overflowing, so I will be able to see Zoom chat on another screen.
Yes, we will. That's fine. Okay, I think given the time, I'd like to introduce you to our attendees. So this is Victor Gamov for you who are joining. He's a developer advocate at Confluent, and he can help you with all your Kafka and stream processing questions and needs. He stepped in for us as a last-minute speaker at Scala Love. Thank you so much, Victor.
Not last minute replacement, but hopefully it would be valuable addition to this awesome conference.
You're definitely a valuable addition.
All right, thank you so much. So good morning, good afternoon, good day for everyone. For me, it's morning. For some of our attendees, maybe it's some different time of the day, but this is still doesn't matter because it's an awesome conference and we're online and it's all about things. My name is Victor Gamov. As it was already mentioned, I work as a developer advocate at Confluent. And the Confluent is one of the companies who contribute heavily to Apache Kafka project. And we build our own packaging of Apache Kafka called Confluent Platform. Another important thing, if you want to know about me, I build highly scalable and highly available Hello World applications. So essentially it. Now, today I'm going to be talking about a very cool project. It's not new, but not many people may be aware, and maybe it's not 100% translated to your existing knowledge with Scala. It's actually this project was built with a different type of audience in mind, like not the audience who know how to code, but rather audience who want to solve some of the problem, specifically stream processing problem. So let's dive into these different bits of this stream processing problem and why we need to have a thing called KSQL DB. So Apache Kafka is open source and event streaming platform, distributed system that allows you to do multiple things. Many people start Kafka as a kind of like just one of the better version of messaging, but this is kind of some of the more like overlook for the people. Once the people start looking deeper, Kafka can actually offer much more features. Essentially, there's three major components that Kafka is built on. Obviously, it's a client library that allows you to interact with Kafka. So essentially, there is the broker itself, and there's a client library that allows you to interact with. Based on these client libraries, the Apache Kafka community builds a couple interesting things. It's connectors that allows you to connect external system to Apache Kafka without writing code. And the stream processing capabilities, which is part of Apache Kafka as well. So like what is the stream processing? Let's talk about this. So like imagine we have some enterprise and you need to perform. Historically, Kafka was a place like would behave as a kind of like a dump pipe, like people just getting some of the readings from some systems. They put them in Kafka because Kafka able to provide this kind of a very large distributed buffer in order not to overwhelm receiver system where say we have some enterprise where we're collecting some information from like the telemetry from some sensors from some machines, and this is like example of one of the message. How does the message look like? There's like production line. There's something that this production line is producing, some of the widgets or some of the things, and we can calculate some interesting like we potentially might get some of the interesting insights from this data, like especially when there's a large enterprise and large of amounts of messages are full flying around. So it's not only that we need to like push it somewhere. Historically, Kafka was created as a pipe, like for fast ingestion for Hadoop. But like, can we do better here? So I'll give you example, like very short example that explains a essence of stream processing. So like remember this message. this particular like event that happens here. So say we have a stream of events. What is a stream of events? A stream of events is a sequence ordered immutable events, things that happen over time. So immutable means that like once things have happened, we cannot change anything with it. So only thing that we can do is to send another event that helps us to like amend, and it would be up to the system that will be, you know, responsible for consume this message. So think about this. You have a conversation with your significant other and you said something that you're not supposed to say, and you cannot change things, right? So you already did this. The only thing that you can do is just like try to you know, make it up. So you try to come up with another message, and it would be up to receiver system to, you know, receive your apology or not. So this is how the streaming system is actually model real life very naturally. So things that happens in the real life, we don't have a time machines right now, unfortunately. Hopefully we'll have in future, but for now we don't have it. So we will model our system with this like immutability in mind. Now, so imagine we want to do some filtering of these events that happened. Like we have a the red widget and yellow widget. So in the original stream, we have all sorts of combinations. Some of the events happen on this production line. Now, and we want to produce another stream. We're not modifying existing stream. It's always creating something new, which is like very functional approach to things, right? So we not mutate things in place. We're just like creating something out of it. So we derive from the initial stream of widgets, we create the stream of red widgets. So traditionally, how we can do this, we use Kafka Streams framework. Kafka Streams framework, it's a part of Apache Kafka, and starting from like last year, now there's official Scala API that allows you to write your Kafka Streams applications with Scala. But can we do better? Like it still requires the code. It still requires solve the problem about distribution code, deployment of code, supporting the execution. So you need to figure out where you're going to be running. You're going to be running this on a bare metal. You're running this in cloud somewhere. You're running on Kubernetes. You're going to run this on Docker or Mesosphere or whatever. How about this? So this is actually your stream processing application that does exactly as the previous line of code does. But in this case, it allows you to focus on something familiar. Many of us know what the SQL is, and many of us it's more domain specific than like a general purpose programming language that allows you to perform this kind of stuff. So let's get back to the initial example of this production line, and let's see what kind of stream processing application we can come up with, just giving this like a data model in mind, using this the purposely built language that is very much SQL-like. So there's two types of stream processing capabilities. One is the stateless stream processing, another one is stateful. So stateless stream processing is something where you don't need to know, or you don't need to remember a previous step. Any type of transformation, any type of filtering operation, it is a stateless stream processing. So here's an example how we can use this select statement where you can do just simple filtering. Say you want to just get another stream of widgets where is weight of particular widget is more than a certain number. So we can filter this and produce another stream, and based on that we can generate another application that would be either alerted or something. So the result is going to be, in this particular case, we just will print out this on the console. We don't do we're not creating new stream. So the second thing is that we have a stateful stream processing. Anytime you need to do like accounting, summing, you need to perform any type of aggregation. So in this particular case, we need to remember previous state. Historically, how we can do this, we can perform this computation, and after that we save our state somewhere in, say, distributed database or whatnot, where we can access to this one. In this particular case, KSQL DB already have state storage, so you don't need to worry about this. You just need to perform this count, and the KSQLDB will take care of it. So we can also perform more complex aggregation. Like this particular case, we can calculate average temperature in Celsius, where the sensor, the information that reported for a particular sensor in terms of temperature would be more than like 20 degrees and stuff like that. So in this particular case, we need to have a storage for aggregating things, and after that we need to have ability to extract that kind of thing. And most important, not the most important, but one of the important things is just like how we can integrate with other systems. So KSQLDB able to not only do this computational bits, but also communicate with external system and offload this result. So you can read the data from somewhere. Say we have a Kafka producer that writes data into Kafka. You do performing this calculation. After that, you dumping this result as in the form of report that like front end will be able to pick up. So this is a architecture of KSQLDB, which is again event streaming database. It's open source. It's available at ksqldb.io. Works with any modern Apache Kafka installation. So it allows to integrate different storages, different applications, perform some of the, in my opinion, very complex things with very low kind of like effort in terms of writing code and things like that. And it also supports two types of queries. You can get the push queries that will be kind of have an updated result, but also you can have a pull query like a traditional database when you can just request something and you get like materialized view on particular data set. So we have an input source, everything or streams leads to Kafka. We start things with Kafka. We have some like a client application, or there's some connector that pushes data into Kafka. Once it's in Kafka, KSQLDB can read this. Also, KSQLDB internally use Kafka for some of the some of the storage information, some of the information about even like a processing. Even KSQLDB stores this like execution log inside Kafka. It enables like multiple different use cases you can perform, not only like the calculation of incoming stream, but it also allows you to perform so-called like a joined or like enrichment type of application. So you with one KSQL query, you can access to multiple stream at a time, and you can perform very complex things. Now, analytics is one of the use cases that this enables. Microservice communication. This is something that you can easily implement with KSQLDB using this kind of like a pull query type of functionality of application. Let's quickly take a look on a demo and what we're trying to do here. Actually, you can participate in this demo. I will have this running. So essentially, let me talk this one a little quick. I will execute this for now, and I will explain what we're gonna see right now. Now, so I do have a connector to Twitter. I think it's a pretty important data source that I can read the data from. So I'm reading data from Twitter and putting this in this Twitter topic, and after that I'm massaging this data a little bit. So in this particular case, like let's replace it with Scala Love. So if you will be tweeting something with Scala Love, and within this say 1 hour window, my application should count. If you tweet more than 4 tweets within 1 hour, you should be able to see your application, your result. So in order to see me this, let me reset this offset a little quick and see if we have any results. If some people were tweeting about this conference. So if people not tweeting, having this Russian heritage, and I can create bunch of fake of Twitter accounts that will be tweeting about this. So let me see if I will be able to tweet something. This is my, let me see here. Out my small Twitter, what's up, Scala? Hello. Scala Love. And let's have it here. I will tweet it here. Obviously, result will not be here because those previous tweets came from the different times. But if I will do part 2, and I'll do say part 3, and I suppose should see the stream here in a few more seconds. Let me do one more. Okay, part 4. Should see this streaming result in a moment. But let me quickly show you what we're trying to do here. So first thing that I'm trying to do is once I get this information from the Twitter, it comes in a JSON format. Now I need to transform it into something that will have a good format. In this particular case, it will more tabular thing. So KSQL DB supports some of the functions. In this particular case, this function can understand JSON path and extract certain things from the JSON. And the JSON is a native data structure here in KSQL DB. Also, Avro and Protobuf, those data structures are also native. So next thing is that if I want to calculate some I will execute this continuous query that will constantly be writing data into console. Now I'll talk about tables and streams in a few more seconds, but in this particular case, this is where I'm creating this aggregated store where my results, like a user count, will go into this particular table. And here I also created another table from my previous result that I will be just limiting by number of accounts. Let me see if my tweet bot is still tweeting. Maybe I already my API exceeded the search queries that I have. Let me see if I do have anything here. Select if actually data coming into the system. Where is it? My let's create. Nope. Okay, let me see. Up. Fat fingers. Okay. Am I have a full screen? Let me see. Yeah, my window here. So let's see if we will be able to. No, not this one. I have a different query. H4. Come on. Okay, let's see. From Twitter, where text is Scala Love. And let's see if we have anything here from initial tweet, or if I don't have any data, meaning that Twitter already banned me. No, something is going on. Someone is tweeting, so looks like the thing is actually working. Let me quickly re-enter, because if I changing this window size, the console applications, they don't behave very well. Okay, let's try this once again. So when I add this image changes at the end, so it will create continuous query that will constantly pushing these results. In this particular case, nothing. If there is no new data, there's nothing's gonna have here. If I will say, okay, live from Scala Love, I should be able to see this tweet over here, I think, hopefully. Yeah. So essentially how it works, the Twitter, I tweet in Twitter, Twitter provides this Firehose API. my KeySQL DB connector listens to data from this tweeter, gets this data into Kafka topic, and after that, I can perform all sorts of operations on this data. So you can try this yourself. This demo will be available. I will show you after. Now, quickly. So as you saw previously, I use the console to interact with KeySQL DB as the like CLI, the same way as like SQL Plus or something like that, or like a PG client that you use for interacting with any databases. You can do this in console. We do have a like UI that allows you to interact with this in kind of like a graphical graphical form. Let me show you real quick. So if I do things like KSQL, this is my KSQL server. I can see how many streams I'm running here. This is our Twitter stream with some data. I do have some tables that will preserve some of my aggregated queries. So I can go ahead here and just do something like query stream. So maybe my connection is down. Yeah, so I'm running this in the cloud. Maybe my local proxy just fall down. So this is why I prefer console. Console works all of the times, like the UI. So next thing, for the real programmers who wants to interact this in a programmatic fashion, you can have a REST interface where you can just like submit query and get the results like almost instantaneously. And this right now, the team is working on providing like a KeySQL DB client, like a native client with like all cool features in terms of like reactivity and other stuff. I'm using maybe HTTP 2.0 as a protocol. So we have this enhancement or improvement proposals process, and one of this is kind of like community process where the people can discuss and influence some of the developments of the things. Okay, let's see what else we can do with KeySQL DB. So let's figure out. Let's pretend we have some of the data that represent some of the orders information, so we can perform some of the transformation. And say we want to filtering, so transform this timestamp into something and throw some of the address data. So we're creating new stream from existing string, but just eliminating the fields that we don't need and keeping the fields that we do need. So in this particular case, you see we're querying the original stream and extracting this data that we only need. So in this case, new stream will not have this like information about the orders. We're creating the new stream where we have only things, but also you can see here there's a function that we can execute on particular fields. In this particular case, we extracting the timestamp on the previous stream and creating this raw time, which is like service column that would be part of new stream that will be used as a kind of like a time for new stream. And we're applying function the timestamp to string, so we can define a format how I want this look like. So in this case, in the result, it looks like this. So it's pretty powerful. In this case, you don't need to write a code to do like simple things like this. So let's talk a little bit about joins. Like usually when we're talking about some of the stream things, the first thing people are asked, like, can we join? So imagine we have some information about orders, and we do have some of the lookup table that allows us to get extended information about certain items. So in this particular case, we do have the item in our lookup table, and here we do have some of the additional information about so this is order information. Now we want to have an enriched stream where we can combine information about item, not only putting this item ID here, but also we can not item ID here, but also like include this information about make and model. So with KSQL DB is actually fairly easy. Joins is like a natural part of it, and your previous knowledge of database joins are not disappear, so you can still use the same similar constructs over here. And we will have an enriched result here in this part. Oh, sorry, there's a pointer. Yeah, so we'll have a kind of like a joined flat structure of the KSQL DB. Interesting thing here is that KSQL DB able to integrate virtually from any source and sync system in the world, thanks to a very rich Kafka Connect in infrastructure, or like Kafka Connect ecosystem, where we can use this source connector that will read data from, say, in this particular case, from MySQL. Just in this SQL query, we're just defining this create source connector. We specify the class connector that needs to be in the class path of KSQL DB, but next stuff like KSQL will start pumping data out of MySQL. Once you're done, you do some performing some queries and things like that, and after that you sync this out to another system, into Elastic or whatnot. Let me briefly talk about the streams versus tables and how they would be relate to one another. So we have a Kafka topic with certain events. So in Kafka topic, all events are immutable, and putting them. So we are creating these abstractions that called KSQL DB stream that will have information about topic, plus it will partially create a schema for this, because S in KSQL DB stands for structure. So we need to have this kind of a structure. A table in KSQL DB will be able to, with the table, we are creating a current state for particular topic, for a particular topic or for a particular key. So in this case, if we go in, like receiving new messages into Kafka topic, this is how the stream and table would look like. So in this particular case, we're creating a stream with only one entry. So in this case, we will use the event timestamp as our time, and our table will have a key and value. Next thing, we're putting another message into Kafka topic that will append to KSQL DB stream, and also it will change the state. So think about this when you're performing this type of operation. It's like you are playing in chess, and you either see this board represents you a state of the world. The board is itself, it's your table, and if you're recording all these moves that you're playing around, this is your stream. So table represents a current state, stream represents how the things are changing over the time. So in this particular case, in Kafka topic, we have four events. If we create a table, that will have aggregate, and it will contain latest and greatest value for particular key. So under the covers, everything builds on top of Kafka producer and consumer. It's like foundational API that like we use everywhere. But with addition, oh, that's not good. So KSQL DB builds with Kafka Streams as a framework to implement certain internal things. It uses RocksDB as a storage for the data. That's it. So it's another application. It doesn't run inside the Kafka. You can run this anywhere. You can run this next to your Kafka cluster. You can run this in cloud. We have this managed Confluent Cloud thing that allows you to run like a serverless stream processing application, and you can run the KSQL DB there. You can run this any type of, like virtually any type of hardware where you can run Linux and Java potentially. There's different packages, Docker, Kubernetes, whatever. So how you can scale this? You can scale how you can scale Kafka consumers, because it follows a same paradigm that Kafka consumers and consumers provides. You can run purposely cluster per your particular application, so you can have some sophisticated jobs that require you some big aggregations. You can run this in larger KSQL DB cluster. If you have some other things like bigger or smaller, you can run this in a different size of cluster. Now, so the web UI allows you to quickly, map up your query, but like you can submit your queries and submit those in the same way as you can submitting to application server. You want to learn more, obviously. There's only one place that you need to go. It's developer.confluent.io. Like all your needs in terms of learning how to do stuff with stream processing, with Kafka Streams, KSQL DB. There's Kafka tutorials, fantastic place. So you can take the use case, and after that you see how this use case implemented in the different stacks. If you have any questions about stream processing, join our Slack, which is cnfl.io/Slack. And as kind of special for today's show, we also giving away the stream processing books, Kafka Definitive Guide, Making Sense of Stream Processing, the fantastic books that like I'm like returning over and over. So those are great. Don't hesitate to praise me on Twitter and follow me on Twitter and ask particular questions. Thank you so much for being with me this time. And I think this is all the time that I have today. And I think we do have some time for some questions, do we?
I think that we'll have time for questions in the Q&A room,
Okay.
but unfortunately not here. But thank you so much for your talk, Victor. That was very
absolutely.
insightful.
So you need to tell me like how I can get to this Q&A room.
Yes, I'm just about to post a link in the chat for the Q&A room.
All right. Thank you so much.
So thank you very much. So can all the attendees, if you want to ask questions, please head to the Q&A room. It's a lot more casual, and so you can have a nice casual discussion about KSQL.
Fantastic. All right. Thank you so much.
Thank you very much. It was great to have you. Thanks. Okay, and to everybody else, well, actually, to everybody, we are going to have the keynote, I believe, in the Joy Room in around 15 minutes.
Yes, that's correct.
It's very exciting.
Yes. Okay, I need to set up something special for the keynote. Ashton, do you hear me?
Yes, I do.
Okay, let's try your setup.
Okay, I'm just getting it prepared here. 1 second. If you send me an invite to the Slack channel, I can just go ahead and post the visual when it's done. If
Okay.
it works for you.
Yes, it works. You can also send me email. I still cannot see you.
Yeah, just 1 second here. All good?
Let me see. Yes. Okay, dear attendees, we're going to have drawing the sketches based on the talk. So if you want to see that during Martin's talk, you can choose to do gallery view so that you would see both Martin speaking and Ashton drawing. And thank you, Ashton, for joining us.
Yeah, thank you.
Yeah. Okay, so can you mute yourself? Okay, you're muted. Okay, thank you. Now we're waiting for Martin to come. All right, let me check the Twitch streaming. It looks fine. Okay. Hello, Martin. You're muted. You are
Yeah.
muted.
Hello. How are you?
Good, good. Getting excited.
Are you? Did you sleep at all, or did you stay all
No, I cannot sleep.
stayed awake all night?
Yes, all the
Oh,
night, and
what-
it's half of the conference.
yeah. What time is it now? 6 o'clock in the morning.
6:30. Yeah,
6:30. Yeah, yeah, yeah.
yeah.
Ollie never sleeps. Yeah.
Yeah, that's command from Only Never Sleep. That's true. I don't. Someone even saw that I have a twin or something, and
Okay.
there are two of us.
Right.
But who knows? Maybe it's true. Let's check your slides.
Sure. Let me just do this screen share. Just have to go, oops, to the start. Presentation mode. Okay. How's that looking?
Good.
Good.
It's
Okay.
looking
Cool.
good.
Cool.
All right. We have a lot of people here. Attendees. So we also have a Twitch channel.
Right.
Yes, with 369 people on Twitch channel.
Okay.
Whoa. Yes. Okay. 374. Someone
Okay.
said.
Yeah.
Quite a lot of people.
Mm-hmm.
Also, we decided to complement your talk with drawing, visualizing your talk. If you click on the gallery view, you can see this is the where your talk will be drawn. Ashton kindly joined us to do so. Then
Okay.
we will post the result.
Okay. Mm-hmm.
Yeah. Unfortunately, I think attendees on Twitch won't be able to see that, but they will be able to see the result later.
Okay, cool. Very good. I just look at my screen share. So now you should see the PowerPoint, right?
Yes.
And I just want to exercise how to flip quickly from one to the other. No, yep. Okay. Yep, that looks all good. Okay. Good. So all set, I guess.
Okay. Let's wait one more minute.
Yeah, sure. So I couldn't see, I saw some of how he's talk in the morning, but then I had to do my slides, so I couldn't see any others.
We're recording them, so you'll be able to watch them later.
Yeah, looking forward to that. There were lots of good talks. Yeah.
Yes,
And
I'm very excited, very thankful for all speakers and attendees for letting me create this event.
Yeah. Yeah. Yeah, I hope I can catch some of them after my talk. So we will have a break immediately after?
Yes, we will have a Q&A room where everyone can ask spoken questions. So I will post the link and you will be able to talk to people directly in that Q&A room.
That's a breakout room?
Yes.
Yeah, I've been there in the morning. I have had a quick look at what it's like.
Yeah.
Okay.
Yeah. All right. I am honored to introduce our next speaker, who doesn't need to be introduced, but still. Martin is the inventor of the Scala language and a professor at EPFL in Lausanne, Switzerland, and the founder of Lightband. His work concentrates on the fusion of functional and object-oriented programming. He believes that two paradigms are two sides of the same coin to be unified as much as possible. To prove this, He has worked on a number of language designs, from pizza to JG to functional nets. He has also influenced the development of Java as the co-designer of Java generics and as the original author of the current Java reference compiler. Thank you very much for joining us today.
Thank you, Ollie. That's some ancient history that you have brought up here. I mean, the Java compiler, my God, that was a long, long time ago. That's true. So the future, of course, is Scala 3. That's what I have been working on over the last more than 6 years now, and it's finally coming out. So I'm very happy to essentially give you an update of where we are with Scala 3. So let me just go into the slides. Okay, so a Scala 3 update. Just see. No, what is it? Okay. I had a problem with scrolling, but that should be fine now. So first, why do that? Why Scala 3? And the reason to do Scala 3 really has to do a lot, I think, with the reason why exists Scala. What's the raison d'etre for Scala? Why do we have that? And I dug out really an ancient historical slide that was part of all my early Scala talks in the from 2006 maybe to 2010 or something like that. So it always said Scala is a unifier. So on the one hand, it is great for small scripts. So you can write, you have a repo, you can write really small stuff, and it grows to large systems. And the way that's done is essentially by a fusion of object-oriented and functional programming. So that was essentially the history at the time. And by now, I believe it has lots of languages that followed in Scala's tracks. So if you look at languages like F star or C star, F sharp or C sharp, I mean, C sharp predates Scala, but the functional features in C sharp came after Scala's. Or later languages like Swift or Kotlin, they have all adopted quite a lot of essentially the approach of Scala to essentially combine object-oriented and functional, and in parts also quite a lot of the concepts and syntax of Scala. And also Java, the big tanker, is moving along, and with every release acquiring more and more of the functional features, quite close to the way Scala did them. So the last one that we will expect in the next version is data classes and pattern matching, which finally came, which is essentially a funny story, because when I did pizza, since Ollie mentioned it, that was in 1996, we presented that to some of the people at Sun, and they said, well, we don't need closures, which was one of the additions, because we have inner classes and they're good enough. And we definitely don't want pattern matching because that's not object-oriented and not extensible. But the generic types, that looks interesting. So that was the start of the GJ project, which then became the Scala C compiler. So by now, finally, 20 years later, Java has moved around and actually will have pattern matching and some form of ADTs in the language. So it took them a long time, but they are definitely moving in the right direction here. Okay, so that was the outline. That was what Scala is. And furthermore, I think another important thing of what Scala is that it concentrates on flexible abstractions. Oops, oh, sorry. It concentrates on flexible abstractions instead of individual features. So that means we have a rather modest language size. If you compare let's say the language grammars, then Scala is actually a lot smaller than it seems to most people, despite, of course, a large breadth of applications. And that essentially concentration on abstractions also allows us to construct very advanced libraries. We have a very rich ecosystem of high quality and highly advanced libraries. And it's also good for domain-specific languages, which was a application area that was very important in the beginning of Scala, less important now. And finally, I should say that this library-centric design is also very good for language interoperability because it lets us essentially model the host language features as essentially library features in Scala. So all this is good, but it also has some downsides. So the main downside, so first downside is that this flexibility that Scala affords leads in practice to styles that are quite heterogeneous. So people apply it, essentially apply different recipes of the features to achieve different things. And that, of course, is also partly due to the fact that Scala is so versatile that you can do pure functional programming in it, and people do, and you can do actor-like reactive programming in it, and people do, and you can do data science, and that's what another set of people do, and so on. So essentially, there are lots of different application areas. So that leads to some difference in styles, and I should also say that there are some features in Scala that lead to essentially incidental differences in styles. For instance, some people like to write all methods with a dot. I guess the majority likes to write all methods with a dot, but some people want to write methods infix, or at least some of them. And it differs between different people and different teams. So that means that looking at a Scala program, even the optics sometimes look quite different. And that's a thing that I believe was maybe interesting at the beginning, where we said it should be great for DSLs and we want to experiment with different styles. But I think by now Scala has grown up, we've grown up, and we should be able to settle on a single style and stick to it. So I think by now it's more important now to actually achieve some uniformity in the way people approach Scala. And that's one of the goals that we have for Scala 3. The other downside was that sometimes these abstractions led to essentially a whole systems view that was too low level. They expressed mechanism instead of intent. So what we will do in Scala 3, what the goal of Scala 3 is really is to work out the essence of what Scala is. This combination of functional and object-oriented, that's of course a large mantle. How can we sharpen what that is really? I think the first thing that is important here is that we have to put it on solid foundations. We have to connect it with the foundations. And unlike when Scala started, we now do have foundations that are essentially the right substrate on which to put Scala. That's first the dot calculus, the calculus of dependent object types. Then there's the SI calculus for implicits. And then there is something called lambda circle, which actually existed when Scala got started, but we didn't know about it, which is a very nice foundations of the new metaprogramming capabilities in Scala. The second thing that we want to do is to improve the developer experience by improving tooling and binary compatibility. I'm well aware that the lack of binary compatibility between major versions is one of the sort of most annoying things that happened in the Scala ecosystem, and I think we finally have the tools to overcome that. The third point is drop baggage. So over the years, like I guess any programming language, Scala has acquired some things that were cool at the time. And in retrospect, you say, well, maybe not so. For instance, XML at the time was really something that was extremely, at the time, people thought forward-looking. Sort of the same thing like what microservices were 2 years ago. Absolutely the thing, the fashion of the day. And so Scala got them. Actually, I added them to Scala because of the insistence of Phil Wadler. I guess most of you have heard the name, who was at the time very active in a lot of XML committees. And he said, the XML is the future and you absolutely need to be able to paste web pages in your programs as constants. And that's why you need to support XML. So that was the reason at the time. And at the time, lots of people found it cool. Now, I guess a lot of people will say, well, why XML and not JSON? So probably a programming language shouldn't do either, should have neither XML nor JSON nor other essentially specialized literals. The other thing that we will drop is symbol literals. That was also a fairly marginal use case where we said, well, why need that? So generally, the whole thing, the whole language will become more opinionated. We want to essentially show better, essentially a best way to do things, and not essentially stay on the sidelines and say we give you a number of different building blocks and you can do it any way you like. That's essentially a tendency. Of course, Scala will never be Go or another super opinionated language where there's basically only one way to do things. So we don't want to get there. We can't get there reasonably. But essentially, where there is a unnecessary choice, we will try to essentially make the choice for you and have that essentially sanctioned in the language. And sometimes that is by a restriction, and sometimes that is just by essentially proposing something that is hopefully so appealing that everybody will use that. We'll see some examples later on. Okay, the other thing that is very important for me, I think, is to make it even more appealing and easy to use for beginners. So I guess a lot of you laugh now and say, even more appealing, isn't Scala a super complicated language? No, actually it isn't. When in Scala's early days, there were kids 11 years old, like Shadei Ladad, who picked it up and found it extremely easy to use. And it is. So if you stick to the basics and you don't essentially buy into the more advanced libraries, which of course have their place, but not for beginners, then Scala can be a very, very simple language. It is essentially as simple as Python and a lot simpler than Java because it doesn't have all these boilerplates and it doesn't have a public static void main and all these incantations that make no sense and that people have to learn before they can write the simplest program. The simplest Scala program is a lot simpler than the simplest Java programs, let's say, or the simplest program in a lot of other languages. And that is also backed up by the fact that Scala is actually a very successful first teaching language in a number of universities. I also saw direct comparisons of Scala versus Haskell, for instance, at Leiden universities, that proved that Scala is actually far simpler to teach than Haskell to the average undergrad. Okay, the other important thing, I believe, is to eliminate pitfalls. Because of the way it was put together, by and large, things work well, but there were sort of corner cases that led to surprises. And I guess that's also inevitable in every language. So over time, one should be able to identify these surprises and, if given the chance, eliminate them. So generally, we want to improve the productivity, and the predictability for what we do. So make programmers more productive, have more fun writing code, and also be safer, give more predictability what the code will actually do. Finally, we want to make the language feel natural and beautiful to use. I think aesthetics are a big part of programming. We sit in front of our screens all the time, and we might as well do it in a way that is beautiful and aesthetic, and not in a way that essentially is an eyesore. So in that sense, the Scala Love logo, to say we want to do something that we all love and we want to have essentially improve the thing that we love, is a big driver of what Scala 3 is about. So what's new in Scala 3? I gave already a lot of talks about it, so I'll give a quick rundown. It will not be the main topic of this talk, but I just want to look at the main topics that the language is about. So the first topic that I said, we want to connect better with the foundations. So language features that fall into that, in order to do that, are in particular intersection and union types. So intersection types are directly supported in dot, unlike the compound types using with, which are not. And union types are essentially the logical dual of intersection types. So these are sort of things that come out of the type structure. Also, if a language supports subtyping, like Scala does, then intersection and union types are needed to make the subtype relationship into a lattice. And being a lattice has a lot of algebraic advantages, and which translate directly into advantages of type inference. For instance, with union types, we can do a much better job at inferring types that essentially won't blow up like we currently have sometimes when we compute the least upper bound, we get a huge type. So a union type prevents that. The other important thing for foundations is essentially that we want to push more capabilities, or ideally all the capabilities of a method into a function type. So methods in Scala, methods and functions are not the same thing, because essentially functions are values, they're objects, and methods are things inside objects. So they have to be different, and they're connected by eta expansion. But the fact that they're different shouldn't prevent us from having the capabilities that we associate with methods also on function types. So for instance, a method can be polymorphic. A function type could not so be polymorphic so far. So in Scala 3, functions can be polymorphic. A method could be dependent. So the result of the method could depend on the parameter value. That will be also possible now for functions. So we will have dependent functions, or dependent product, as it's called in the dependent type research. So that addition alone will push Scala about halfway towards dependently typed languages like Idris, or theorem provers like Coq or Agda. And finally, methods can be implicit. So they can have implicit arguments. So in Scala 3, function types can also be implicit, and that gives you a lot of additional modeling power for abstracting over contexts. The next feature for the foundations is type lambdas, where with higher kind of types, we lacked so far a way to express them directly, and people developed very clever workarounds using structural types and type projection and things like that. So in Scala 3, those workarounds are no longer necessary because we have native type lambdas. And finally, the meta-programming that I already mentioned will be based on quotes and splices and inline, which essentially gives them a very close connection to this lambda circle calculus. So the next big topic of Scala 3 is to simplify life as a programmer. The essentially day-to-day things that are make life easier. The first thing, for instance, is you don't need to put things always in an object or class anymore. You can write definitions at the top level, like you would do in a script. The second thing is you don't need to compose your ADTs using case classes and sealed traits. Enums do it for you. So enums range from simple Java like enumerations to GADTs. You can express everything with that simple construct. Classes can have parameters. In Scala 3, traits can have parameters as well, and that avoids workarounds like early definitions or things like that. Exports are a useful feature to use aggregation. So typical criticism, which I subscribe to, of object-oriented programming is that inheritance is overused. Inheritance is a very powerful feature. But the advice is you should use this essentially only where necessary, and you should use aggregation or composition instead. But the fact is that today's languages do a very poor job at supporting aggregation or composition, and exports fix that. So exports are a simple way to add forwarders to your classes so that you can have nested components and then a facade that just exports the capabilities of these components. And the final one, which is really quite trivial, but quite pervasive in practice, is that new will become optional. So you don't need to write new in front of a class anymore. You can just write the class name and the arguments. The motivation here is to say new is basically, it's an implementation detail. A user of a class shouldn't worry about whether that C thing here is a class or an apply method of the companion object, for instance, generated by a case class. I've seen that so far, some people write case class instead of class just to get these constructors. So that's no longer necessary. You can do that for all classes now. The new will become optional for everything. Okay, so the next chapter of what Scala 3 does is it restricts features that are either unnecessary choice or that are unsafe. So for instance, method calls now will always be with a dot, with its traditional method call syntax with a dot, unless the method is declared infix. So that means the library designer will pick a style for all its users, and you will no longer essentially give the choice to for different styles. There are also some things that were unsound in Scala 2 because we lacked the foundations to figure out that they were unsound. Now we have a much better ground, and those will go away. So one thing that was unsound was type projection without restrictions. So type projections will be restricted to the sound subset now. Another thing was not unsound, but unsafe. And those were essentially pattern definitions and for generators. So in the first case here, you see we have a list, ys, and we want to decompose it into a head x and a tail xs. That might fail because the list ys might be empty. And previously that was allowed. And it could, that means that you could have a val def, a pattern definition that could fail with a cast error or a match error at runtime. Now that's no longer allowed, at least not in under strict mode in future Scala. So you have to add an unchecked to it to essentially tell the compiler and the reader that this pattern match might fail, and you might therefore get a runtime error. The other case like that was for expressions, where you could have, let's say, a generator that says 4x colon apple taken from fruits, where fruits is essentially a list of apples or oranges or bananas, or all kinds of fruits. And that would filter the apples out of the fruits, which is occasionally very useful. I use it actually quite a lot, that feature. But on the other hand, sometimes you want to say, no, that's not what I want. I do not want essentially silent filtering. I want it to fail at compile time, because essentially I want to assert that the for expression will process all the things on the right-hand side of the generator. So now if you just write 4x colon apple taken from fruits, that's the behavior. You would get a type error because it would say on the right-hand side, we have a list of fruits, and you on the left-hand side, you have an apple, and that's not compatible. But you can write a case in front, and that case acts like a filter. It would say, okay, in that case, we essentially only take the cases of fruits that are apples and process them. So that's the old behavior that you have here. Another restriction that is actually very important, probably the most important of all for them, for me, is multiversal equality. Multiversal equality rules out nonsensical comparisons. And to do that, to show you that, I thought I'd show you just multiversal equality in action in the Scala compiler. So let me just switch to that. Okay, so what we have here is we have the Scala compiler has a class name that you see here. And names are essentially, they wrap strings, they're strings with some semantics. So as a first approximation, there are two kinds of names for types and names for terms. So a name is not a string, a name is strings plus additional info. So one thing that you can do is you can take a string and you can essentially map it to a name. You have to say whether it should be a term name or a type name. So ABC2 term name would create the term name X. So one insecurity is if you would then want to compare a name with a string. That's something that essentially is quite common because names are so close to strings. Then if you're not careful, in Scala 2, you would get, that would probably pass, but you would always get false at runtime, precisely because names are not strings. So the equals test would fail. which is a bad situation because it means that you cannot refactor with confidence. You might actually change your types, and then suddenly some of your equalities or disequalities might essentially become nonsensical if you haven't caught it. Instead, what you want is that they're caught as compile time errors. So what you get here instead is, you see here, you get an error which says values of type term name and string cannot be compared with equals or not equals. So that's precisely what you want. Okay, so then one question is, well, can we scale that up? So for instance, can I do the same thing for asking whether a list contains a name? So there again, I want to say a list of names can never contain a string because names and strings are different. And here, unfortunately, I don't get the error. I don't get the error because essentially the list contains doesn't have the right signature. But let me fix that and define an extension method that now replaces contains. It's called has. So you see, has essentially takes a list and an element, and then it has a using equal tu. So that is essentially a constraint. It requires a type class that t and u are comparable with equality. So it's a 2-parameter type class, and it just is the same as contains. So has and contains is the same thing. It just has this additional type class that requires that they are equal. And what we get is now essentially the same thing as before. That we get the term names and strings cannot be compared with equals or not equals. So the whole thing can scale up to also library design things. So how does that work? The type class here gave it away already. So what we have here with the name is we have an extends clause as before, and we also have a derives clause. So that's type class derivation. And what the class name derives is essentially an instance of equal. So if your class does that, or you can also write the instance explicitly if you want to, then multiversal equality will kick in and all nonsensical comparisons will flag as errors. And that was for us really important if you have a large code base, because only that's sort of the one missing bit that you need to ensure if you want to do large-scale refactorings and just have the assurance that essentially everything, all your errors will become type errors. For equals and not equals, they will typically, before multiversal equalities, they were typically runtime errors and not type errors. So that's a big change. At the same time, multiversal equality, you see, it's still equals equals, so it's not a separate type class, it's not a separate comparison, it's completely compatible with the way we write equals everywhere. It's essentially just a separate opt-in feature. Okay, so that was one little excursion here. So let me just go back to the slides. So the other thing that Scala 3 does is replace over time a lot of old concepts that essentially have been superseded. So one such concept that will be phased out is package objects. They are replaced by top-level definitions. If you have top-level definitions, you don't need a package object anymore. And package object inheritance is replaced by exports, because the only reason a package object inherited from a class was essentially composition and aggregation. It wanted to export the things defined by that class. So export is a more direct way to achieve that. The whole implicit set will be replaced by a new abstraction for context called givens. I'll get to that. Implicit classes are replaced by specialized syntax for extension methods, and the current macro system is replaced by the new metaprogramming system based on inline staging and match types. Okay, so the three most important additions, you saw that there's already a lot in Scala 3 that changes and is added or is dropped, but the three most important ones I think are number 3, the new foundation for metaprogramming. So inline quotes and splices are a better way to express macros and at the same time also runtime staging. there's a very nice way to give precise control of implicit searches from metaprogramming called summon from. And there's built-in type class derivation, what you have seen here with the derived thing. You can do that yourself. You can essentially write your own type class derivation schemes, and then the type class will have instances for all case classes, all enums, so basically all ADTs, all sum and product types. The second most important thing, I believe, is a new way to express term inference. So term inference means given a type T, generate a canonical value of that type. And that's essentially what we do with implicits all the time. But implicits have issues. So implicits have been replaced by givens. Implicits, I believe, are Scala's most distinguished features, but they're also the most controversial ones. So a lot of people say, well, I looked at Scala, I saw implicits, I ran away. And that's not a good situation, because I really believe implicits should be the reason you stay in Scala and you use Scala. They're so great. But we have to essentially make them more accessible, and we have to make them safer. So that's what givens are. So givens emphasize intent over mechanism. The old implicit system that essentially slapped implicit as a modifier on everything that felt very much like a mechanism. So you have all these objects and defs and classes, and by putting implicit on it, something else will happen, and then you can build your things. But it didn't really emphasize the intent. The intent is this one. Given a type T, what's the canonical value of that type? That's all you need to know. And also, givens should make the idea of term inference more accessible and easier to use, and at the same time discourage possible abuses. So here's an example of givens. We have this trait ordered. We have an extension method and compare to between two things that are ordered. And we have now an instance of the ordered class, which says, well, we know how to do an ordered of int. And in order to do an ordered of int, I have to define the compare to method, and here's what it is. And once I have done that, I can write a maximum method, which now would say, well, maximum is defined over a list of t, and it must use the fact, using that t has an ordering, so that there is an instance of order of t. And then it can essentially use that instance in its reduction method, in its XS reduce methods. So what you see here is that the implicits don't have names. You can give them names, it's possible, but you don't need to anymore. So the fact that you say, well, here's the canonical instance of ordered, you don't need to invent a name for that. At the same time, to say this must use the fact that T is ordered, again, you don't need to invent a name for what this thing should be. It means you can write things a lot shorter, and you don't need to waste your time with things that are not important, like often the names are not important. So what this gives you is really first-class type classes. It's a very nice way to express that. So here's another way to essentially the typical type class example: a semigroup with a combine method, a monoid which extends a semigroup, and then an instance of monoid which says, well, here's my combine method and here's my unit method. And then you call that, let's say, with a sum method, where you say sum is defined over all list of t's, where t is a monoid. And what you do is you do a fold left, then you summon the monoid of t. So summon is the new implicitly, and you call its unit, and then you reduce the whole thing with combine. So this is essentially this approach to, it's still the same approach as implicits before, what the Coq theorem prover, which does basically the same thing, called first-class type classes. The idea is that a type class is really a trait. Instance of a type class, which we call a given, will translate to a value of that trait, an instance of that trait. And a type class constraint is what we express with the using section is really a parameter. You pass essentially the dictionaries for the type class in here. So theorem provers have that, essentially exactly the same system as Scala has. And I believe with the givens, we work out essentially the essence of that much better. Also, what you should see here is that these things were previously really hard to do because of the infix methods that we have here. That required essentially very, very elaborate scaffoldings and imports. The simulacrum macro library did that, but even with simulacrum, you had to do a lot of things just right to get that. And now everything works out of the box because of the way essentially these type classes are integrated with extension methods. So one thing that also goes away is implicit conversions, which basically I believe have been overused by and large. Implicit conversions still exist, but now only as a special type class. So there's a class conversion, and you can have an instance of that using givens. So you can say given conversion string token, and then for the conversion, you have to define the apply method. So you can say that, well, the conversion class, which is essentially a subclass of function string to token, its apply method is the thing that converts a string to a keyword. Or you can also use an alias given, then it's just like this. It's given conversion from string to token equals keyword. That you can also write. And the most important feature, I believe, at least for me, is optional braces. The idea is that Scala 3 will make curly braces and parentheses optional in more places. And instead of braces, you can use indented blocks. That's by itself a fairly trivial and small feature. It's handled, of course, just in the front end, in the parser. And it's, if you look at it, not really terribly important because as a fact, there's a lot of code variation already today. So for instance, if you have an if then else here, then some people write braces around both of the parts from here to here. And the other braces go in the else. Some people object to the else after the closing brace, including myself lately. I find it very unappealing to have the else hiding behind the closing brace. So I tend to spend an extra line and put the else on a new line. So sometimes it's like that. And sometimes, of course, we leave out the braces if there's a single branch. So I guess a lot of us do that. But then we have to come back and add the braces back if we want to have more than one statement on one of these branches. And we don't even have agreement on how to lay out this. So for instance, if I look at how he uses libraries, he tends to write the if and then immediately the open parent. So there's a lot of code variations in all these things. And what the Scala 3 will offer is a little bit more variation. So we now also allow this. So no braces at all. You just have the two sides, or even better, you don't even need parents around the condition of the if anymore. So you just can just write it like that. If in the token equals left parents, then, and then the then part, and then the else part. So that's an additional way to do things. You might say, well, didn't you say you want to become more opinionated? Well, my prediction, which maybe is crazy, but I stand by it, is that in a short while, everybody will write this code and nobody will write the old code with parents and braces. So in that sense, it's actually something that will lead to more uniformity and not less. Other uses of the new syntax you see here. So for instance, for a for expression, you need neither parents nor braces anymore for the generators. You just write them after the for, and then you have a yield and then the expression as usual. For a while, you don't need parents, you write while do. For a for loop, you also would write for do, not for yield. And for a match, you don't need braces either. So you write, for instance, an option match, and then you just write the cases like this. Same thing for a try, you write try body, and then you could write a single case like this, catch case, exception handler. Or if you have more than one, then you can indent them after the catch, and if they line up, then that's fine. So optional braces, of course, is very controversial. So I never have seen so much discussion. So we were a bit scared, and we added it as an experimental feature last autumn. And I've now used it very heavily for more than half a year, where I used that syntax exclusively. And believe me, I worked quite a bit. I had a lot of commits to the Scala compiler over the last half year. And I must say that the experience has been positive beyond everything I could expect. It's far better than I dreamt of. I thought it would be good, but I didn't imagine it would be that good. I believe overall it's the single most important way how Scala 3 improved my productivity. Again, you will say that's crazy. I mean, we have all these heavyweight features, the exports and extension methods and multiversal equality and the givens and things like that. But no, I mean, because that's the one thing that you use every day, you use in every line you program. You use it and it makes your life easier in every line that you program. So why does it make your life easier? Well, there's one thing that is measurable, that programs become shorter. You get a more than 10% reduction in line count. That's basically all these closing braces that you have to add. That by itself, you might say 10% is not much, but it is essentially line count that's imposed on you. You don't have any control. There are 10 or 5 closing braces. You have to spend 5 lines to do it because that's your coding guideline. And that's when you give up essentially control over the layout of your program and also over the beauty of your program. You become essentially an automaton that where essentially you put this. You might as well write your programs in XML. And there are reasons we don't do that, because essentially that wouldn't be a legible or beautiful format. The same thing applies to braces, much less strong than XML, of course, but nevertheless. The other thing that I believe matters a lot for writing programs is that as a writer, you stay in the flow. So if you use braces, then essentially as soon as you change something, let's say an if then else condition branch becomes 2 statements instead of 1, let's say you add just a debug print into your program, which I have to do a lot. Then every time I do that, I have to essentially, after I added the debug print, I have to go up and add an opening brace, and I have to go down and add a closing brace, and then I'm back. By that time, I'm out of the flow. Whereas with indentation, I just add the print and where it belongs, and that's it. So this simple thing makes life incredibly simpler because it's essentially something that happens all the time. So a good analogy that I want to make here is that indentation is really like Lego bricks. You put your bricks, your statements where they belong at the right indentation, of course, and that's it. There's nothing more you need to do. You just put them where they belong. If you compare that with braces, then braces are like baling wires. So you have something and then you put another thing and they say, no, then it won't fit anymore. I have to wrap something around it to make it hold. And wrapping things around it, that's basically putting an opening brace and a closing brace. I mean, the braces even look like baling wires. So that's really the ergonomy, the workflow that you have here. So would you rather use Lego bricks or baling wires? That's the question. People were essentially predicting lots of downsides, that essentially would become super fragile, errors wouldn't be detected, refactorings would end in catastrophe and things like that. In my experience, there was not a single thing. Program changes were a lot more reliable with braces than with braces. With braces, often when I did something, a lot of changes, then suddenly I got 100 errors in the parser. And I had no idea. Well, I knew I missed the opening or closing brace somewhere, but where? I had no idea. Going through the programs, everything looked okay. So what I typically do then, I don't know about you, but that's my way to deal with it. I looked at the diff of the last revision and said, there's this brace. With indentation, you never have to do that. I promise you, you never have to do that. There's never a single issue with things. Of course, that's not a statement about all indentation syntax. I'm well aware that maybe in other languages it's different. I know, for instance, in YAML, which I also use, it's terrible. So the details matter. And we took a lot of time and several trials to get it right, but I think we got it right. So I'm really happy with the result in the end. So roadmap, where are we? We are in April. We had for a while all features fleshed out with implementations in .NET from .NET 0.21, I think. Now we're at .NET 0.24. We are currently in the period where we want to stabilize, want to finish the SIP process to essentially officialize the changes, want to write docs, spec and user-facing docs, migrate the open source ecosystems, flesh out the tests and community build, and invest in compatibility and migration tools. And hopefully that will lead in late 2020 to Scala 3.0 final. So that's when we still plan the release, COVID-19 or not. So for stabilization, we have essentially regular releases, timed releases every 6 weeks, new ones, and each new week release contains bug fixes and usability improvements. And I'm also very happy that .NET support now appears in the leading editors. So it was just merged in Metals. It's in a nightly, not yet in a release version, but it's in a snapshot version, and also IntelliJ. So both of them are starting to use Scala to support Scala 3. And of course, that's absolutely essential that we get there. The SIP process, so the SIP committee, the Scala Improvement Committee, is reviewing the complete language. We had the last meeting in March 11 to 13. That was basically just when the lockdown happened in Switzerland. So the first 2 days were in person. The last day was remote. It was a weird feeling, the first fully remote meeting, and from one day to the other. We managed to discuss most features at that meeting and also at the meetings before. Some features were changed or dropped as a result of the discussion. And we invite community feedback on the Scala Contributors Forum. So we have about 2/3 of the changes completed by now. I can just quickly show where that is. So, sorry. Oh, sorry, no, I have it. I should have. So here you see the Scala contributors, and there's a Scala 3 feature status overview where essentially you see the current situation. So you can show that. And we also have essentially for all the features that haven't been discussed yet, which you see, that's essentially those here. We will open contributor threads. So one which is one of the latest, which is very active, is about main methods. So it's one of the proposals here. So if you're interested in shaping the future of Scala 3 and essentially giving your opinion and your advice, then that's a good way to interact and to contribute. Okay, so going on, migrate the ecosystem. So I'm very happy that many libraries have started migrating. And what we try to do is essentially have a set of those libraries in the Scala 3 community build, which essentially will serve as a check that every new version of the compiler and the language can still build those libraries. And I'm quite happy to say that we have quite a lot of them in the community build. So from algebra to Zio, having heavyweights such as Scala test in between, we have quite a few of these libraries already in the community build, and more are coming. So keep it up. We were really happy to get more of these things into the community build, and that way develop a hopefully complete ecosystem of libraries by the time Scala 3 is actually released. We have also, Scala Center has also recently compiled a migration guide, and there should be hopefully more news and more progress on tools for migration in the future. So to conclude, you could say, well, there's an awful lot of changes. There's an awful lot of work to get to Scala 3. Is Scala 3 maybe a new language? Is it maybe just something, what relationship is there to Scala 2? And I would say, well, the answer is yes. We have lots of language changes. We remove some features, so it's not backwards compatible. The new constructs improve user experience and onboarding. I think for a new user, it will look somewhat different, hopefully better than Scala 2. And it also means that the books about Scala will have to be rewritten. The Scala 2 book by itself will essentially be outdated if you want to learn Scala 3 from it. On the other hand, you say, no, not really. It's still recognizably Scala. All the core constructs remain in place, and there's a very large and practical common subset between Scala 2 and Scala 3. Quite a few programs that can cross-build. So for instance, Scala Test, Zio, or earlier versions of the .NET compiler. By now, we essentially cut the cord to Scala 2 because we want to use our own dog food. We want to use the Scala 3 features in the .NET compiler. So by now, the latest version of the .NET compiler are not fully compatible with Scala 2 anymore, but large parts of it are still big because they haven't changed lately. So I think the answer is it depends, and it's a process. So Scala 3 keeps most constructs of Scala 2.13 alongside the new ones. That's why it's possible to define this to define this large and common subset. So some constructs will be deprecated and then phased out in future 3.x releases, starting with 3.1. So that means that for 3.0, we have some temporary duplication, but the end result should be a more compact and regular language. So I just want to do some quote of Josh Zurith, who has experimented with Scala 3 a little bit. He said some expletive that I highlighted. Scala 3 will be amazing. It's very much a new experience and very much still Scala. So I like that quote. So one thing that we were asked a lot is, why are there so many features at once? Couldn't you have faced these things in one by one feature after another? And I guess the answer is, well, the problem here is Scala 3 is by definition when the books will be rewritten. So we need to get something in now if it affects the foundations. If it simplifies life, especially for learners, because then it should be the book in the books, and if it replaces an existing feature, because then again, a book doesn't want to explain the existing feature that will go away in Scala 3.1 or 3.2. So that essentially forced our hand that we had to put a lot of things into 3.0, and that it's a huge upgrade from 2.3.13. But we were careful to really restrict it to the things that were absolutely necessary, which means we prioritize foundations, simplifications for developers, and restrictions. And the things that we leave for possibly later versions is added power and expressiveness for essentially more specialized expert users. So that's something that we said we have so much in 3.0. If it's something that primarily gives more power to essentially an expert user, it's still something that might be worth to have, but we can delay it. We don't need to have it in 3.0. So one question that was asked a lot when I talk about Scala 3 is, will this be a Python 2 versus 3 situation? And I believe no, and for 3 reasons. So the first reason is we don't need to migrate everything, since Scala 3 can use Scala 2 binaries. So it means the Scala 2 library, for instance, the standard library, and the 2.13 library is usable from Scala 3. In fact, there is no Scala 3.0 standard library. This standard library is shared between the two. And that means also for other things that essentially all Scala 2 libraries that are published in Scala 2.13 are usable from Scala 3 as they are. provided they don't use macros or they don't expose macros to APIs, because macros don't port that way. So macros are the big caveat. For macros, you have to put in extra work, and typically, essentially, source versions to have versions of macros that work for Scala 2 and a different set of macros that does the same thing for Scala 3. That's what we see right now is the main effort in porting is really macros. The second reason why I think things are much better than when Python went from 2 to 3 is that we have strong static typing. So we can actually migrate in confidence. Errors will typically be caught in the type system rather than at runtime where you're not sure whether you have all the tests or whether the error will show up in production. So that's a big advantage. And 3 is, I think there are actually lots of benefits from that you can obtain from migrating to Scala 3, unlike when Python 3 came out. When Python 3 came out, basically it was all pain and not a lot of gain that Python 3 had over the years. Python 3 got acquired a lot of more interesting features. So by now it's pretty clear that Python 3 is a vastly superior language to Python 2, but it took a while. Whereas Scala 3 will be a vastly superior language to Scala 2 from day one. So I think for these 3 reasons, I imagine that the migration to Scala 3 will be a lot smoother and also a lot faster than what happened in Python. So how to get there? Well, I said there's a large common subset with source compatibility. We have some rewrite tools, so far mostly implemented in the Dotty compiler itself. We should hopefully have more other tools when Scala 3 comes out, but so far they haven't materialized yet. I just want to talk quickly about binary compatibility. So today, Dotty can link with Scala 2.13 class files, I should say. So I can have a Dotty module that uses a Scala 2 library. We are very close to actually have the opposite as well. So the opposite would be that a Scala 2 module can depend on Dotty or Scala 3 module, again with the binary. And that will be achieved by making the Scala 2 compiler understand tasty. So the Scala Center is currently working on a reader in Scala 2 for tasty, where tasty is essentially our intermediate format, that contains a complete representation of Scala 3 programs. So it's Jamie Thompson who works on that, and he's quite far advanced. So hopefully you should see that soon. The other thing is binary compatibility. So once we have tasty, which essentially represents a complete Scala 3 program, we plan to make it compatible over the whole 3.x series. Probably not from 3.0. That's a bit too ambitious, I think. We want to settle it first, but maybe 3.1 or 3.2 after that will freeze the format. And that means that we can essentially use tooling that compiles from tasty, and that means that we won't have binary compatibility problems because old versions of programs can migrate by, since everything is in tasty, can be transparently recompiled for new versions of the compiler or for different platforms. So that's a big, hopefully, advantage that we will have in the future, and that should do away with the binary compatibility problems that plague the Scala ecosystem now. Thank you. So I'm already over time. Maybe we take quickly some questions. I'm happy, and otherwise I'll be in the breakout room for the pass.
Thank you, Martin, so much. That was an interesting tour in our future, and we really appreciate your time and presenting. So I guess we only take one question and then go to the breakout room because we're already over the time. So it seems to be like given and then are new reserved keywords for Scala 3. How they support backwards compatibility?
The givens you have to put in back quotes if you want to do that. So okay, so no, so for the given specifically, so we have a source version which is called Scala 3.0 migration, that you can run the Dotty compiler with that source version. And in that source version, the given and all the new hard Scala 3 keywords, a couple of others like that, are still treated as identifiers. So in that source version, you can run given in your original thing. And what it will do is it will say, well, attention, this keyword will no longer be supported in Scala 3, and it will offer a rewrite, an automatic rewrite that puts the keywords in backwards. So it's fully automatized, but you will end up, if you use a lot of givens in your program, with a less beautiful program because the givens will end up in backwards.
Right, I guess we can move now to the QA room, and I'm going to post the link in the chat. Once I can have it open, for some reason it doesn't show up. Yes, so here is the room. Please feel free to go there and have chat with Martin, and Martin, we invite you to continue.
Great, thank you.
Yeah, okay. Hi, James.
Hello.
Hello, how are you?
Great. How are you?
Good, good. I think that Grigori is your track owner, right?
Yes.
Yeah.
I'm here.
Okay, I'm gonna leave you guys. I'm gonna go to the Q&A room. Thank you.
Awesome. Thanks, Ellie.
Yeah, thank you.
Perfect. All right, James. I think we have a couple of minutes just to set you up and to wait until, well, technically it's a break. So
Great. Yeah. Just hanging out in the hallway during the break.
yep.
How's everything been going so far?
Pretty good. So you've seen probably an amazing keynote by Martin.
Yeah. Yeah, Scala 3 looks awesome. I played with it a little bit.
It looks like we have lots of Twitch viewers. Like not everyone can be in Zoom. So here in Zoom, we have only around 70 attendees now, but in Twitch channel, it's around 500.
Nice. That's awesome.
How's your morning? Isn't it too early for you?
Not too bad. 8:30 in the morning. So and then there's 2 other rooms right now, right?
Yep. So there is a happiness room. We're in a joy room. There's a happiness and another room by JetBrains. Harmony, right?
Yeah. Nice. Yeah, I'm bummed I'm up against Runar because I want to go to Runar's talk.
Wow, everything would be recorded.
Yeah,
so
that's
you
awesome.
can watch it.
Gregory, how do we do Q&A at the end?
So it is mostly up to you. I think that, well, there are two options basically. There's a small Q&A after your talk, and probably people will post some small questions during your talk. And I can try to interrupt you if you want, somewhere in the middle,
Yeah.
if there would be some minor questions. But
I think
after all, I will post a link and you will go into a separate Q&A room where you can ask all questions in details, and you have like indefinite amount of time. Well, indefinite means like 40 minutes.
Yeah, go. Great.
We have a couple of minutes, like 10 minutes.
Yeah, cool.
Let me see. Yeah, we have, 10:45 is your time. Perfect.
Looking good.
It's already a nice teaser.
I've been using Windows for my Zoom virtual conferences this week, and I got the Windows subshell for Linux all working on it, so it's not too bad. Real bash shell.
Wow, really? So do you finally use Windows for the development or only for presentations?
No, just for presentations. Because normally I'm on Linux, but Zoom on Linux presenting is a little iffy, and so I was like, well, I could just dual boot into Windows, and I think it'll be a little more reliable. So
yeah, to be fair, all these applications in Linux, they're unreliable, extremely unreliable. They all have different interfaces.
Yeah, yeah, exactly. So far it's been working great.
That's nice.
Yeah, it's nice to have like real Ubuntu.
Well, talking a little bit about teasing your presentation. So how's Docker? How do you work with Docker on Windows?
Well, because I'm using the Windows subshell for Linux, I'm actually just using Docker right inside of here. So
and it works?
Yeah, it just works. So it's actually great. Yeah, but if I had to do Docker on the Windows side of things, it would probably be challenging.
And I tried to do that, I think like a year, maybe 2 years ago, and I hadn't, well, I could make Ubuntu shell working, but I couldn't make Docker's work under the Ubuntu shell. Probably they released some they did some updates of the shell.
Yeah, and this is on the when I tried it for the first time, I just started with the Windows subshell version 2 or whatever, the newest one, which isn't 100% 1.0 yet, but I'm like, it's going to be 1.0, I heard soon, so I might as well just start with that. And so far, it's been good, and Docker's worked great. So
yeah, I remember times when I had to install a separate exe file to install some Docker for Windows and to use it from PowerShell.
Yeah,
that was horrible.
Yeah, horrible. Yeah, I did a presentation on Tuesday with Josh Surratt, and for part of it, we showed some Rust, and I was in IntelliJ, which runs on the Windows side of things, and I wanted to get the Rust stuff working in IntelliJ, and to get Rust working in Windows is, oh my God, you have to install a bunch of Visual Studio pieces, but it doesn't really tell you which pieces of Visual Studio it needs. And then we finally got them installed, but then so that it can support multiple versions of the .NET whatever SDK that Rust needs underneath the covers, it actually doesn't give you the right path in your normal shell that has the linker that's needed in your normal shell environment. And so we just gave up and we just ran the Rust stuff from inside the subshell for Linux, because with Linux it was like apt-get install cargo, done.
Oh man, this is horrible. Have you tried to use some machine learning stuff on Windows?
No.
I'm talking about CUDA. And it was surprisingly bad. It was too bad.
Yeah.
Why surprisingly is because, well, all gamers, they play games on Windows, and there is no good way to install CUDA drivers on Windows. Yeah, you're installing something, but it always has nothing in the class path, and you have to point it to something. Download some DLLs from somewhere.
Oh, geez.
It all sounds like
that's brutal.
Yeah, don't do that. So I think we can start, or at least I can start introducing you. So
Perfect.
Yeah, so ladies and gentlemen, welcome James Ward. So probably he does not need to be introduced like many of our presenters today, but he is a fan of functional programming, as he says. He works in one big company. Yeah, this is his Twitter. Just follow him Twitter, slap likes everywhere. And today we are probably going to talk about some Scala tooling and about how to package Scala. I remember some buzzwords like Kubernetes, like Docker. That's why I mentioned some teasering. But all right, James, please take your time.
Great, thanks, Gregory. Great, so I'm gonna get started and talk about containerizing Scala applications. So thanks for joining us today. I'm not going to do any slides today because I just wanted to walk through some stuff. We'll see a bunch of different ways to containerize Scala applications, and we don't need slides to do that. So so I'm going to be in IntelliJ and in the shell and stuff. So so we need an application to containerize, and so I'm going to start with just basic. This is the application we're going to use for all of these examples, and this is using Oozie HTTP, which is a very, very pre-alpha Zio-based HTTP server that the author says not to use. And so, hey, let's use it anyways. And so this is going to be our application that we're going to use. So, so in our application, I've got like 16 lines of code just to parse the port environment variable, because later on we'll use the port environment variable for a different environment that will tell us what port to listen on. And I took James Roper's idea of turning a port into a char, because the char is the closest way you can represent a legal port value, and I thought that was cool. So let's actually parse out our port into a char. Okay, but then the rest of this is all just start up the server and respond with hello world. So pretty basic server here, and then of course our main loop here where we then can fold with exit code. Okay, so that's our application that we're going to be working with, and we are going to start by just running this application. So let me go over and let's just say SBT run. Okay, so that will use SBT build and then run this web server, and we'll make sure that it all works. And there we go, running web app, listening on 8080. So let's go make sure that that's up and running, make a request, we get hello world. Great. Okay, so we've got our application and we know it works, at least when we run it from SBT. But let's start with taking our application and starting to package it up. So to do that, I'm using the SBT native packager, SBT plugin, and this is really a great plugin that has a lot of different ways that you can package applications, and we're going to walk through some of those. So one of the ways that we can package our application is using the launcher jar plugin. The launcher jar plugin, what it's going to do is just assemble a directory structure that has the jar files and then some start scripts for us. So let's actually go run that one. So instead of running SBT run, let's run SBT stage. And when we run SBT stage, it's going to use that SBT native packager plugin, and then going to assemble our directory structure with everything that our application needs on top of the JVM to be able to run this application. We'll take a look. Okay, so if we look in our target and then universal stage directory, you'll see that we have two subdirectories, bin and a lib. If we look in lib, these are all the jar files that are going to go on the class path. And one of these jar files is my actual application. That's the default hello Uzi HTTP. There's a launcher jar because I told it to use the launcher jar plugin for SBT native packager, and then the jar file that has my actual class file in it, just that web app class file, and then the let's see, 7 dependency jar files there. So we can go use the generated bin scripts. So in bin, you'll see that there's this hello Uzi HTTP. There's also a batch file there. If we were running inside of Windows, I'm running the Linux subshell in Windows, so I actually use just the bash script there. So now that has just basically run java -jar with those jar files, and if we go reload our browser, we should see, great, it still works. Okay, so now we've got all of the things that to run this application on top of an operating system and a JVM. So if you have an operating system and a JVM on a system, you could take all these files and run the application. And that definitely works for a lot of environments. But for running inside of Kubernetes, for running inside of other Docker-based things, we need to go to another packaging format, which is a Docker container image, or an OCI image is the standardization of the Docker container image format. So this allows us to package everything that our application needs to run, all the way from the operating system, the JVM, and then our application. So all those different pieces. So let's turn this particular project now into a Docker container. And the first method that I'm going to use to show you how to do this is using something called build packs. To use build packs, there's a command line tool called pack. And what I'm going to say is let's build a container image, and then I'm going to tell it the name of the container image. So let's call it hello Uzi HTTP. Okay, so now this is going to use build packs, and it's going to take a minute to run through and create our container image. I am using underneath the covers, there was an option that I specified earlier to use the Heroku build packs. There's a number of different build packs that you can use. You can use the Heroku build packs, you can use the Pivotal, Cloud Foundry build packs, those are really the two main options today that I'm aware of, but others are starting to be built as well. Build packs are a incubating or experimental CNCF project, and so this is a good standard way to be able to take source code and turn it into a container image. The nice thing about build packs is that build packs usually have inside of them a bunch of different support for different languages. So I could run that same pack build command on a Node project, I could run it on a Python project, I could run it on all sorts of different types of projects, and the build packs know how to detect what type of project it is, and then know how to for that project type, build it into the actual runnable thing. So we've just built our container image, and now we can run that container image with Docker run. So I'm going to tell it to do basically an interactive session, and then I'm going to port map port 8080 to that. Actually, let me show you that we're using the environment variable port as well, or we can use the environment variable port, and then we'll map port 9000 to 9000, and then I'm going to tell it to run the hello Uzi HTTP container image. Okay, so now Docker is going to start up, and you'll see that my server is started up on port 9000. So now if I go to localhost 9000, then you'll see, great, it still works. Awesome. Okay, so we've got our Docker container. It is assembled and able to start that server. It has everything in it that's needed to run this application. So let's actually use a tool called Dive. I like the name of it because we're going to dive into this container image and actually look and see what's actually inside of this container image. A container image is kind of like a bunch of zip files that have some metadata, and that metadata allows them to be stacked together into a bunch of layers. So let's go tell it that we're going to look up that Uzi HTTP. Docker containers have this concept of like tags on an image. So I'm going to tell it, make sure we get the latest one of those. So let's dive into that container image. It's going to fetch the images, and then we can look and see what's actually inside of all these things. Okay, so the whole container, all of the layers, all the different containers that were assembled together, the total size for this container image is 663 megabytes. So pretty large, and we'll walk through why that is. So if we can actually walk through the different layers and see what was contributed by each layer. And each layer comes from another Docker image, essentially, or can come from another Docker image. And so we can take like the Ubuntu Docker image and start with that, and then add some things to it or remove things from it, whatever we want to do. And each time we make a modification, we're adding a new layer. The whole reason for layers is that then we can do more efficient caching. So when our runtime, whether it's Kubernetes or something else, needs to go fetch the container images, if it already has the particular digest for the Ubuntu image layer in its local cache, then it's not going to have to go out to Docker Hub or to some other location and fetch that layer across the network. It can just pull it from its cache efficiently. So it's a nice thing about having the layers is that then you can invalidate the higher layers and then you don't have to repay those network costs every time you download the lower layers. Okay, so we're starting at the base layer here, and the base layer was 63 megabytes, and we can go look and see what's in here. This looks like just an operating system image. If we collapse this down, this list down, the tree down, then we can see all the different files that are in that layer. And now we can start to walk up the layers, and let me actually turn off, we're not going to view the unmodified files at each layer. So now we can actually see what gets contributed in each layer. So in the next layer, there is something in var, then some other stuff, not too much going on in these lower layers. But then we get this really big layer, 429 megabytes. And what this one is this is what's called the Heroku run image. So in build packs, when we assembled our Docker container for our application, the build pack said, here is your base image that you're going to use. And Heroku has a base image that knows how to run a bunch of different types of applications and has a bunch of native libraries in it. It's got things like image magic because somebody on Heroku needs image magic and so on and so forth. So it's kind of this, for Heroku, the kind of standard runtime for anything running on Heroku. And that's important for Heroku. But in our cases, we really, we don't need a lot of this stuff. And so a lot of this stuff is unnecessary for our uses. But there it is, the 429 meg layer for the Heroku base image. Okay, now if we keep walking through the layers, we're gonna get to, now we're into a launcher that is going to know how to launch our application. And then we get some information on JVM stuff. And then we get to 161 megabyte layer. And now this is the layer that has contributed everything for our application. So there's some, and we'll get to the JDK is in this layer. And then we keep walking, there's SBT, there's our actual project. So in the world of build packs, they generally just keep everything that was in the source tree and then the compiled output of the tree. And so that was in our project directory, target directory. So now that's really everything that our application contributed. And as well, if we looked into the target directory, we could go find that target universal stage directory and that sort of thing. Okay, so where the launcher jar plugin added all that stuff. Okay, so that's nice that we're able to so easily create a Docker container for this particular project. But let me show you how we could now deploy this particular Docker container. So I'm gonna go back to that pack build. And what I can say is, let's do a pack build, but this time let's publish it. Because when we did it before, it just put it into our local Docker daemon, so it didn't send it anywhere. But I want to send it up to Google Cloud, and so you could also send it to Docker Hub, and so I'm going to give it the coordinates for where to put it on Google Cloud, and I'm going to say -- publish. So now it's going to rebuild this container image, and it's going to take that container image and upload it up to Google Cloud, and then we'll be able to deploy this thing from there. So it's going to walk through. Build packs actually do have some great caching abilities. So I think that it's going to be able to restore some of these layers as it builds from cache. And so this is going to run the successive times that we run it, it should run nice and fast. So so you'll see it installing JDK, running SBT compile stage, and taking the output of all that stuff and then assembling it into our container image, and then it will upload that container image up to Google Cloud. So this will just take a few more seconds and then we'll be able to go see it up on Google Cloud. Okay, assembling. Exporting, which is now copying the layers. So Google Cloud already has some of those base layers or knows about those base layers in this. So it's not going to have to upload everything. It should just have to upload a small layer that was changed since the last time I did one of these uploads. And then it will assemble the caches for build packs. Okay, so that'll finish up in a second. While that's finishing up, let's go over to Google Cloud. There's something called the Google Container Registry. And so if we go look in the container registry is where we see all of my containers that I've uploaded. There's a bunch of them. And let's go show some more. And there we see the Hello Uzi HTTP one. And you'll see that I uploaded this one 18 hours. So as soon as my shell command finishes, once it finishes uploading, then we should see a new one there. There we go. Just now, we have a new container image that was just uploaded just now. Okay, so now that we have our container image up on Google Cloud, now we can take this container image and deploy it. We could deploy it on a raw compute instance using GCE. We could deploy it on Kubernetes. If you've got your own Kubernetes, it's just a container image. This is now a portable thing that we could deploy anywhere. I'm going to deploy it on something called Cloud Run, which is a managed service that can run these containers. So I'm going to say, yep, deploy it in that region, give it a service name, allow unauthenticated access, and then I could set some parameters, but there is the container image coordinates that it's going to deploy. Now let's create this service from that container image. So now Cloud Run is going to take that container image and going to set up a service. This is serverless, so I only get billed with this when I'm actually using it, but it will give me an HTTP endpoint. I could give it my own domain, all that kind of stuff. And it's going to take a minute to get it running because it has to pull down that 665 megs the first time. But now we can go access that HTTP endpoint that it set up, and there we see our Uzi HTTP running in the cloud saying hello world. Okay, so, and of course, same sort of experience if you're going to deploy on Kubernetes or whatever. Okay, so that is the basics, but we want to optimize our layers a bit better. The build packs, they're nice and easy, but they don't give the most optimized output. So let's take a look at how we could build this container a little bit differently than before. And let's get this out of the way. I'm going to switch over to a different branch. Let's see. Let's go to the launcher jar branch and check that one out. And now for this one, what I'm doing is instead of doing build packs, I'm still going to use the launcher jar plugin, but then I'm also going to use the Docker plugin that's coming from SBT Native Packager. And I set some Docker parameters. I'm telling it which base image to use. So I'm going to use this gistroless Java 11 base image, which is a nice small base image for Java. And then give it some other Docker parameters, and then tell it to do Java -jar to run my artifact that was built from the launcher jar. Okay, so let's go actually run this one. And so to do that, let's do SBT, and then I'm going to say Docker, and then I'm going to say publish local. So now this will build my Docker container from within SBT and publish it to my local Docker daemon. And so it's really nice that SBT Native Packager has this built-in support for building Docker containers. And this will give us, we'll see in a minute, a much more concise, layered approach to our Docker containers. So it'll be a lot better. Okay, so it's going to go through. It's now pulling my distroless Java base image, and you'll see it's pulling down those layers to my local Docker daemon, and now it assembled my Docker container. And so let's go actually just go look into with Dive. Let's go look into what was created for that Docker container. So my my total size for this one is 208 megs. So that's definitely a lot better than the previous one. And if we look through the layers, the first 4 layers are just from that distroless Java. And so we can go, let's go over to over here and take off unmodified, and now back to our layers, and we can see what's being contributed. So we've got some base Linux operating system stuff, some more Linux operating system stuff, and then we've got this layer that brings in I think mostly the JVM and things that the JVM needs on that particular layer. That's 177 megabytes. Okay, so that's nice. We've got a nice layered approach for our JVM, but then we see that there's this 12 meg layer, and this 12 meg layer, what it brought in was the dependencies for my project. So the Docker plugin for SBT Native Packager knew the difference between my dependencies and my actual application. And this is nice because if the only thing that's changing on a given release of my container is the dependency, or is my application, not the dependencies, then it's not going to invalidate this layer. And so this layer will stay the same until I actually change my dependencies. And then if all that I change is my dependencies and not the JVM base image, then obviously that JVM base image layer is not going to get invalidated either. Okay, and then the next, the top layer is my 2 jar files, the launcher jar, and then the jar file containing my web application class file. So that one's only 15K. So, so obviously a super trivial example, but you see now how this has done a much better job at layering my Docker container to be much more efficient with caching, that sort of thing. Okay, and then of course we can run that particular Docker image just like we've run the other ones. It should work just fine, listening on port 9000, so we're good. Okay, and I'm not going to go through and deploy that one because it would be just the same thing that you saw before. Okay, so that was the launcher jar with the Docker plugin. So let me show you that again real quick. Really, the only thing that we did was we added the Docker plugin, which comes from the SBT native packager, and then configured some parameters for that Docker plugin. Okay, so now let's continue on to the next example here, which is going to be, let's use a Docker file. So I'm going to check out this Docker file example. So Docker files are the traditional way to create Docker images. And I just wanted to show you this one because we're going to build on this for the last example. So in this one, what I'm doing is I have a Docker file that's starting with a OpenJDK, and you'll see that I've said as builder. And so this is now not going to go, this particular Docker image is not going to go into my layers. It just is a temporary one that gets used to do my build. Okay, let's look at our build.sbt. You'll see that it's like the first one where all I'm doing is using the launcher jar plugin, nothing else in my build.sbt. So then I can run sbt stage, and then I can assemble. I could actually manually assemble my layers with the Docker file. Is you can assemble the layers. I could do 2 copies, and that would then do the layering with the dependencies, and then the my part of the application. But you'll see I give it my run image, that'll be my base image, and then I copy in the target universal stage stuff, the bin and the libs, and then I tell it how to start the application. So if we want to use the Docker file to build our application, what we can say is Docker build -t is the tag. So let's tag it with Uzi HTTP, the same thing that we've used in the past. And then we're going to say build dot. Okay, so now Docker build is going to go, and inside of Docker, it's going to run the build for this project. So one of the downsides of this approach is that it's not going to reuse my local Maven cache because we're now running this inside of a Docker container. So I don't have my external, .m2 directory, my .iv directory, all the my system caches don't get used in this case because it is running this inside of a Docker container that doesn't have those things in it. We could mount those directories into the Docker container, but this actually causes a whole heap of issues because when Docker runs as root, for the Docker daemon runs as root, and I think there's ways to not do that, but when it is running as root, then when Docker writes files into that global mounted cache into like your .m2 directory, then those files are written as root, so that then if you need to, for some reason, overwrite those files not inside of Docker, then you run into permissions issues, and it just becomes a huge pain. So downside to this approach in this case is that it's not reusing those cached system cached pieces that we took advantage of when I ran from SBT. So you'll see now it has to download SBT, and then it's going to have to do everything from scratch, download all my jar dependencies and all that kind of stuff. And obviously we could set up caching and mount those cache directories into this to make it perform better. But so this is going to take a few minutes to run because it has to download a bunch of stuff, and I'm just going to cancel that because we're going to move on to the next piece, which builds on top of this to do something a little more exciting. Okay, so let's go back to IntelliJ. If we were going to use dive and look into this container image, we would see the base gistroless, and then we would see a layer for the things that I copied in that were produced from the SBT native packager launcher jar plugin. Okay, so now let's do the last example where we're going to do GraalVM. And GraalVM is a way to do ahead of time compilation on a JVM-based project. And I'm going to walk through, actually, I'm going to get it going and then we'll walk through because it's going to take a few minutes as you saw. Let's run Docker build again. Let me make sure that's that I think that's what I'm doing. Yep, Docker build. Okay, so let's get that Docker build running, because that's going to have to download everything from scratch, and then it's going to run Graal, which is going to take a little while, and hopefully this will finish in 4 minutes. We'll see. Okay, but let's walk through the settings and see what's going on. So I'm using the SPT native packager plugin like before. We can see that in our project plugins SPT, same SPT native packager. And then I'm using this Graal VM native image plugin. So it's great that the SPT native packager has support for Graal. And so now we can configure Graal to tell it how to do the compilation of my JVM project into a native executable. So if we look down here, here's where we start to configure Graal. So there's two ways to run Graal. I can run Graal inside of a Docker container, and this is usually a good approach for running Graal inside of a Docker container, because then it will go get the Docker container that's needed for Graal. Graal has a Docker container, and then we'll run the whole build and process of creating the native executable from within that Docker container. I created a Docker file, and I'll show you why in a second instead. Then I need to specify some Graal options. There's a couple important ones here that I want to point out. I specified no fallback because the default mode with Graal is that if it can't figure out how to turn this thing into a native image, then it will fall back to basically just running in a JVM. And so then it's not actually taking advantage of the ahead of time compilation. -- static actually will take the linked thing, so the glibc, the things that the JVM needs from the operating system, and actually puts them into the final native executable, which is really cool. That we can just have a native executable, and that's all we actually need in our container, because it has everything that's needed there. Okay, and then we've got a few other options. The majorly important one is down here at the bottom, and this is one where for Scala applications, you need to tell it to initialize the Scala runtime statistics $VM at build time. And if you don't do that, then you get weird errors and all sorts of things. If you're using Graal on something that uses reflection, I'm sorry, because that's unfortunate, but there is a way to get that working with Graal. You need to have a file, a JSON file that describes all the reflection points in the application. And I've done this on a Spring typical Java application, and it is not very fun at all to figure out all the reflection points. But luckily for my application today, I'm not using reflection anywhere. And so I didn't have to specify reflection configuration. Okay, so now my Docker file, what I'm doing is I'm saying get the Graal VM container, get it as the builder. I need to install a tool called native image, and then I'm going to call SPT Graal native image, package the binary. And then here's the reason why I did this from a Docker file, is that because I'm packaging this application as a static with the glibc and other system dependencies in it, I can say from scratch, which is nothing, start from nothing, and then I copy in the file that was created from this Graal, from that package bin. I copy only that one file into my container, and then I tell it to run it. Okay, so let's check back in and see how our process is going. So it looks like we have downloaded all of the dependencies for this project, and we have run the Scala compile, and then it's going to run Graal and take our jar files and our application, and it's going to ahead of time compile all of those into that native application. So I think it's working on that right now, and hopefully, oh, looks like it's just about done. So we 107 seconds. So there we go. We got our container. Let's dive into it real quick, just so that you can see. Here is our container from Graal. It is 15 megabytes and just has that one layer with that one file in it. So super concise. And of course, we should be able to run this thing. And there we go. It is running inside of a container. So thank you, Graal. You've just made things super concise and awesome. Okay. And just in the nick of time, that is all of the containerizing Scala application options that I wanted to walk you through today, but I'll be in the chat channel. Gregory, I think we're out of time in here, but I think we're gonna move over to the chat channel if you have any questions that I can answer.
Yep, that was really amazing, James. And to be fair, maybe like a day ago, my colleague asked me about this dive tool. So even like these small tools that not everybody knows about. So that was pretty awesome. And the next awesome thing was that you launched everything under Windows, and it's amazing, at least for me. I don't know how about others. So we have 2 questions, I think. So really quick ones. The first one is from someone who didn't ask it in our QA specific channel, but he asked, is getting fat jars bad using assembly plugin?
Oh, fat jars. I don't personally like fat jars. One is that they don't lead to good Docker layering because it's putting everything in. And then I think that just generally class path issues become a lot more challenging with fat jars. And so I'm not a big fan of fat jars. I think, you know, with shaded dependencies, there is a place for them. But when I'm building an application, I really try to avoid fat jars if possible.
Right. And the next question is, could you share the sample project with us on GitHub?
Yes, absolutely. It is on my GitHub. And so that's github.com, James Ward. And then it is called Hello Uzi HTTP. And then as you saw in the presentation, there are branches for the different options there. I started with build packs, then went to launcher jar, and then I went to Dockerfile, and then to GraalVM. So yep, it's all on GitHub.
Thanks. I guess that is all. We're out of time, so please go into this Q&A room. I posted it in Zoom. So that was amazing. And let's give James Ward a round of applause.
Great. Thanks, Gregory. And thank you everyone for attending. Hope that was useful.
It was amazing. Thank you.
Thanks.
So let's interrupt for a couple of minutes. And after that, we'll see our next presenter. Hey, who's that? Luca, welcome.
Hello.
How are you doing today?
Not bad, not bad. It's quite cold and rainy here in New York, but could be worse.
Yeah, I see how it's cold and rainy. You have a nice, on background picture.
Oh yeah. I mean, I could show you my room, but it's very boring, so I'm not going to.
Right. So we all have these background pictures. Everyone who has boring rooms, it's like a secret. If you have a boring room, you have something behind you, some fake image.
Some kind of fake. All right, I guess I have 10 minutes.
Yep. So yeah, do whatever you want.
Yeah, I'm drinking tea. Oh, you can't see it. There it is.
Drinking some water as well.
That's good.
How are things going in New York?
I think pretty badly, honestly. But I'm inside most of the time, so I don't really. The only
see
time
always
I think about
here.
it is on the news. Yeah, I mean, there's people walking around outside with masks on, but yeah, I mean, they apparently built like a mass grave or something in Central Park, which is pretty dark. But
yeah, I live nearby New York.
Things are gonna get better.
Uh-huh.
New York is just a very dense city, and that's bad for contagious viruses. Or it's good for contagious viruses, but it's bad for us.
This is a sad smile, sad laugh.
Yeah. Yeah, I mean, it's the only thing you can do is laugh.
All right, let's return a little bit to some good topics, to good vibes.
Yeah.
Someone in the Twitch channel asks you that Ringo called and he wants his shirt back. I don't know what it means. I don't know.
Oh, Ringo Starr.
Ringo.
Is that the thing? Did I
Probably.
steal a shirt?
I don't know.
I don't know what
haven't
his
seen
fashion choices are. I very much respect him as a drummer, but I'm not sure what his fashion choices are.
Me too. I mean,
but I love this shirt. This is my favorite shirt. This is like, it's all the nice little flowers. It's very cute. I love it.
Yeah, this is nice t-shirt.
But my hair is out of control.
Oh, someone says that maybe you're Ringo Starr.
Oh, I see.
Lots of compliment about your style. So,
where are you seeing this?
Oh, it's on Twitch. We have around 300
Oh yeah, I don't have
viewers.
both of them open.
Oh, so I will deliver these messages to you.
Okay, but only the nice ones.
Only the nice ones. Sure, this would be like a filter. Just be sure there would be no damn and bad comments. Stay safe.
Yeah. It's my second online conferences in 2 months. It's very exciting.
I've never participated in online conferences before.
Well, me neither, before this whole virus thing started.
Oh, someone says that you need a Twitch channel with weekly streaming.
You know, I've been like doing some, I do a lot of open source, and I've been basically hopping on Zoom channels in my at my company for if anyone just like wants to see how this process works. And I thought I could do the same thing on Twitch, or I don't know, something like that. That would probably be fun. I might do it. Whoever asked, good idea. It's probably not that hard to set up, so I might just do it at some point. Who knows?
Yeah, I heard lots of feedback that Zoom is not like a really convenient tool, but Twitch works great for people.
Okay.
You just connect into it and it just works. You don't have to install Zoom. And well, you know, to be fair, Zoom has a little bit weird interface. It's not the best user experience I had.
Right. I mean, I get it's a very different purpose though, right? Like Zoom is more for video chat, whereas Twitch is more for streaming. But yeah.
For gaming.
For gaming, streaming. I don't know. You can stream anything on it, right? I don't know if, yeah.
Yeah, I think maybe like 5 or 10 years ago, you could not stream something different from games. So they had some like really stricted policy about what kind of streaming can be.
Interesting. I didn't know about that. Yeah. Some last minute preparation. I've given this talk before, so it should be fine.
Oh, it should be about something on the letter M.
Yeah, yeah. Definitely. They will make a small part of this presentation. It's very small.
Nah.
You're very quiet. Does it mean that there's only bad comments flowing in? Because they're filtering all the good ones.
So what do we have here? Yeah, so I respect both the t-shirt and the done-up top button. I think it's a compliment.
Yeah, I think so too. This shirt doesn't look that great if you don't have the collar all the way down.
Really?
Yeah.
Huh.
I usually don't wear my shirts like this, but this is an exception.
Yeah, for this huge event.
Oh yeah.
I mean, it looks like it's one of the largest Scala conferences.
I guess, right? How many people are watching on Twitch?
So our track is like around 300 people.
300? Oh,
323.
Ooh.
Yeah, let's see, what do we have in another tracks? There's another track with Noel Walsh, and they have around 175 people.
Wow.
We also have friends from JetBrains. I don't know, what do they have? I lost the link. Oh, I have it. So they have around 100 people. So it's like pretty large.
Yeah.
We also have around 70 people in Zoom that are attendees that are not.
Oh yeah. Yeah. Wow. It's a lot of people.
Yeah, it's like crowding.
I don't think I've ever given a talk to so many people, to be honest. I wonder what my biggest audience was, but I think it was probably like less than 300. I don't know.
I don't know. Usually, you know, it's these are just rough numbers, like plain numbers. But usually when you are in a conference room, you just see the crowd and you don't really know how many people there.
Yeah, that definitely makes me more nervous though. Like seeing all these people and going up on stage, like, oof. I've done it a lot, but I still get nervous every single time. At least we don't have to stand in the doorways because it's too crowded. Yeah, that's good.
That's true.
I think that's happened to me before as well.
Actually, this is like a positive part of this streaming process.
Yeah,
everyone
you can like
sit at home, relax.
Exactly. Yeah, that's pretty nice. All right, I'm gonna start sharing my screen just to get it all set up.
Yeah, you have a couple of more minutes.
Yeah, I'm playing it safe. I'm playing it safe. All right.
Oh, some teasering. Oh, that is what on the letter M. They thought that maybe it's monad, but it's monoid.
No. Monads are boring, basically.
Yeah, what's the difference between monoid and monad? This is a dumb question.
You will find out.
Wow, this is awesome. Fun ride through abstract algebra.
The teaser is that they're kind of the same thing. They're just a different flavor of the same thing.
Oh yeah, because everyone knows this famous monad definition.
Oh yeah, a monad is a monad in the category of endofunctors.
Right.
Yeah. I never tried to learn it by heart, but at some point I could just say it and I was like, damn, I've become one of them.
Yeah, so people in Twitch are excited to see you talk.
Okay. Yeah. It's gonna be fun.
Yeah, new experiences are always fun. So
yeah. Just a cough, not corona.
Just a cough. These are good, pandemic jokes. Oh, these pandemic jokes.
Yeah.
Just like this nervous laugh, nervous cough.
Don't panic, Luca, more than 200 people. Well, thank you, Mark. All right, is it 11:30?
I think so. So I think we can start. So I'm very happy to present Luca Jakubowicz. I hope I pronounce it correct.
Yeah, more or less.
Yeah, you probably all know Luca. He's a great contributor into lots of cats-related open source project. He's also maintainer of this Outwatch project. What was the name? Yes, I think it's Outwatch. Like a reactive UI application.
I haven't touched that in a long time, but yeah.
So, and probably he will tell us something about monoids today, I guess. So it is not a teaser anymore. He spoiled the entire topic. So please, Luca, you're welcome. Let's give a round of applause to Luca. Virtual applause, sure.
Virtual applause. Hey, thank you so much. Yeah, my name is Luca. This talk is titled Monoids, and it is surprisingly about monoids and a fun ride through abstract algebra and type theory. So little bit about me. I work at Comstack, which is a smaller startup here in New York City, doing real estate, building a real estate platform, commercial real estate platform using pure functional Scala, and I really, really enjoy it. The other part is that I maintain a lot of various type level libraries, mostly CATs and their partner projects like CATS Effect, CATS Collections, CATS Tagless. And I'm really, really enthusiastic about functional programming and the more theoretical side of Scala. And yeah, so without further ado, let's get started. I am going to talk today about monoids, obviously. And then after that, we will be talking about monoids, some more monoids, and lastly, but not leastly, monoids. No, okay. I did this joke before, and usually when you can hear the audience laugh, you know that it kind of landed, but now it's like, I don't know. But yeah, for real though, I'm going to talk about monoids, but I'm also going to talk about like abstract algebra and how monoids and abstract algebra relate, and also type theory and how that plays into the past 2 points. All right, so a quick introduction about monoids for those that don't know about monoids. In CATS, we have this type class called monoid, and it's basically defined by these 2 functions, empty and combine. And empty basically just tells you, hey, for subtype A, I can give you this sort of empty value of A. And combine just basically takes 2 of these A's and combines them into 1. So the very simple example for this is integer addition. And so we can create this monoid for integer, and this is actually a definition from the CATS library, where empty is 0 and combine is just adding the 2 numbers, the 2 integers together. And you can see how that kind of makes sense. So going further than this, why is this useful? We can use this for a lot of different things. So for example, if we have a list of integers, we can combine all of them by using fold left, using 0 as a seed, and then using addition for combining all the integers inside. But you can do the same thing with strings, with the empty string as a seed and string concatenation. But we could also do something like combining all the sets by forming the union of all of those sets by using the empty set as the seed. And we could also do this for pretty much anything that defines a monoid. And this is really where the power and the usefulness of monoid comes into play, because all of these 3 functions here can be generalized to this combine all function that is a part of CATS. And basically it says here T colon monoid, which basically says that T has to have a monoid instance in scope. And then we can go from a list of T to a single T simply by combining all of them using the empty method of that monoid as the seed. So that's pretty neat. So moving along, we can find monoids pretty much everywhere. Like I think there's probably upwards of 50 monoid definitions in CATS. Don't quote me on that though, I'm not sure. That's just an estimate. And this is also why the talk's titled monoids, 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 because they are everywhere. So for example, in CATS, we have this definition where if we have a function from A to B and that B has a monoid instance, then the function from A to B also becomes a monoid, and we can also combine these functions now. Same goes for an option of A, where A has a monoid instance. So then that option of A becomes a monoid. The same goes for tuple. If we have a monoid on both sides, now we have a monoid for that tuple. We can do the same thing for the map monoid, for Scala's map, where if the values, the B type here, the value type of the map has a monoid, then we can start combining maps using that monoid. Same goes for something like IO. If we want to combine two IOs, we can do that if that A inside of that IO has a monoid. So these are just a select few examples, but there is tons and tons more. And the real useful part comes in their composability. So for example, we have this neat little example that I like to use where basically we have this this function right here where basically we have this data variable right here. Can you see my mouse? Probably. This data variable is just some form of text, and we use fold map, which is basically like combine all combined with map. So we basically take, so this is a list of strings, some kind of text, and we run this step function on each of those strings. And since it's a text, these are going to be words. And what we do is return a tuple of 1, the length of the word, and a map from word to 1. And because of the monoid instances in this case, this gives us the number of words in this text, the number of characters in this text, and the occurrences of each word in this text. So this here is a map from string to int, right? And so this will also be a map of string to int, where the string is the word and the int is the number of times that word appeared in this text. So this is neat, but we can reuse the same function for something like a stream, where we could use something like scan map to give us like an intermediary view of some kind of stream using these same metrics. And this is all supported outside of the box using FS2 or Monix. And of course, if you just use cats, you can use this on any kind of collection like list or vector or sets or anything like that. So this is really cool, and it makes it like a real general thing you could use a lot. And certainly I use it all the time in production code. So one thing about monoids that is very important and makes this whole thing kind of work are monoid laws. And the first law is the law of associativity. And this is like pretty much the most important law. And it basically says that we can move these parentheses around without changing the result, right? So if you do first x plus y, or I'm just going to pronounce this plus, even though it's like x combined with y, but that's too long. X plus y plus z or z has to be the same as x plus y plus z. And this may seem obvious, or like this may seem like something every monoid should do, like it's just like some intuitive thing because like most numbers work that way. And yeah, but it's really important, and we will see in a minute why. And then we also have this law called right identity, where if we combine something with empty, it has to stay the same. So basically it doesn't modify it at all. And the same goes if you put it on the left. So empty plus x is also x. And that's basically the definition of a monoid. So you have these two functions, or these two operations, and these three laws, and that's pretty much it. So why would you need this? Basically, if you think about a number of elements in some sort of list, some sort of stream, anything, right? I call it here A, B, C, D, E, F, G, and you want to like capture them all together, like combine them all together. You could do that simply by saying, hey, I just want to have this as a list and then call combine all, or maybe it's a stream, maybe it doesn't fit in memory, right? Because it's too large. And but still, you would just simply go through it sequentially, start from A and go to G. But with associativity, what this gives us is these kinds of transformations, right? So these two definitions right here are identical simply because of associativity, right? Associativity means we can move around these parentheses. So now these things are exactly equivalent, as long as the monad in question holds the monad laws, abides by the monad laws. And that means essentially we can parallelize any associative operation. So instead of taking, like, let's say 1,000,000 elements, or let's say 1 billion elements, and doing it all sequentially, we can take chunks out of them and then basically combine all those chunks in parallel, and at the end combine all of their results. And because of the monad law, because of associativity, these have to be the same thing definitionally. Right. And so if you have a stream of some A which has a monoid, and you want to do this in parallel, you define this max parallel thing. Basically, this is the whole code you need to get this done. So you basically chunk them in some kind of way, which gives you these smaller chunks. And then you use this map async function. And basically, right here, this is a chunk. So you use combine all on the chunk, return that in IO. And then this basically gives you a stream of A again. And then you compile and use this fold monoid, which basically takes a stream of A and returns an IO of A, where all of the A's were combined using the monoid of A. So yeah, this just works, and it's really nice. So monoid is a type of algebraic structure, and these monad laws are algebraic laws. That's just how mathematicians call them. Don't ask me, I'm not one of them. But so yeah, there's many laws, not just associativity and identity, which is the ones we looked at, but there's also something like invertibility, commutativity, which probably most of you have heard of. I learned it at school, like 6th grade or something called idempotency or idempotency, or I don't even know how to pronounce this thing, but it is what it is. And we also have absorption and distributivity. So these are a bunch of different laws, and pretty much all of them are present to some degree in cats. And we'll kind of have a look at what this is. And this is part of this is basically what abstract algebra is all about, defining these algebraic structures in order using these kinds of laws. So if we look at Cat's kernel, this is one of Rob Norris's type class diagram. This is where monoid and semigroup come from, and it looks like some kind of thing. And I remember first looking at this and being like, "Ooh, okay, where do I even start?" At least like monoid and semigroup, because they're more important, they're like highlighted, which is good. But what the hell is a band or a bounded semilattice, and what are all these arrows? It looks a bit confusing, but I hope after this talk it will make sense. And so basically, all of these structures are just like monoids, but they have different laws. That's basically the only difference. So we have this diagram right here, and basically, if you want to know what a structure is, you can basically just look, oh, okay, a commutative monoid right here is just a monoid that has to be commutative, and that's probably fairly obvious from the name. But something like a semigroup is just a monoid without the identity. So semigroup is just like monoid, but it doesn't have this empty function, which means it doesn't have an identity. And yeah, so what we're going to do is we're going to look at some of these structures to kind of see what they are and how these laws look and what kind of instances we could find in Scala or in programming in general. So first thing is this thing called groups, and groups in Scala terms extend monoids. So every group is also a monoid. And the basic thing is that in addition to all of the monad laws and the monad operations, we have this inverse function, which takes into A and basically inverts it and returns another A. So the one law that is defined extra here is the inverse law or invertibility law, where if you combine something with its inverse, that now becomes the identity or empty. And of course, this goes both ways. It doesn't matter if it's on the left or the right hand side. And so there's something obviously where with addition and where the inverse is just basically multiplying by -1. So 5 plus -5, right? So -5 is the inverse of 5. When you combine those by addition, you get 0, which is the identity. So integer addition forms a group. And so does integer multiplication, or I guess not integer multiplication, because you can't have, but some kind of number that supports whatever these things are called in English, Brüche in German. My mind is blanking, I'm sorry. But yeah, so if you multiply 4 by its inverse, by its multiplicative inverse, which is 1/4, you get 1, which is the multiplicative identity, right? So if you multiply something by 1, you always get back that same number. So those are 2 groups defined on numbers, but we can also define it for something like a set, where the symmetric difference of a set is a group, right? And the interesting thing is that this is a special kind of group where the inverse is actually itself, right? So the inverse of set 1, 2, 3 is also set 1, 2, 3. But if you then use the symmetric difference on the 2, you still get the set. And it's still a very valid group, even though the definition is kind of weird, right? So you wouldn't expect the inverse of something to be the same thing. But this is something you can you kind of come along with, like an abstract algebra. This is so abstract that sometimes the intuition of something like inverse is a bit misleading. Same with like something like combine. Sometimes combining doesn't actually mean combining. It means it's just the abstract notion of combining or inversing. And the only thing that is needed for this kind of, for something to be a group or to be a monoid is that it abides by these laws. And when it does, it does. And when it does, it is. All right. So those are groups. What else can we do with groups? So one really interesting thing is that Rubik's cubes all actually rely a lot, or like solving Rubik's cubes relies on a lot of like group theory, and it's really interesting. And my friend Stuart Stewart actually gave a really nice talk on Rubik's cubes and how you can do stuff with them in Scala using groups. And I really recommend checking it out if you're interested in that kind of stuff. I'm not great at solving Rubik's cubes, but I've solved a 5x5 like 20 times, and then I got bored of it, but it's cool. All right. Another really cool thing we can do with groups is have these kinds of negative lists, where basically instead of having just elements, you could also have like negative elements. And so basically that gives you a way to say, oh, okay, it gives you some kind of like historization to a degree, but you can also say, okay, I don't want this to appear in my list, so I'm just going to concatenate a remove node with this. And I wish I had more time to talk about this experiment that I did, but I'm kind of short on time, so I'm just gonna keep going. Next are semilattices, which is another really interesting algebraic structure. And semilattices are basically semigroups, so they don't have an identity, but they are commutative and they're also idempotent. And commutativity basically says that if you combine A with B, that has to be the same as B with B combined with A. And idempotency says that if you combine anything with itself, it remains the same. And so this kind of limits a lot of things. But other than that, it's basically exactly like a semigroup. So it has to be associative, has to be commutative, and idempotent. And we have a lot of different things we can look at here. So for example, my first example here is if you use Boolean algebra and you say true and false, that is the same as false and true. So and, Boolean and is commutative, and it's also idempotent, right? True and true is still true. False and false is still false. And the same goes for Boolean or, right? True or true is still true. And false or false would also be still false. And the other thing is, of course, set operations, right? So if you have a set of 1, 2, 3 and you union that with itself, that's still going to remain the same. Same for the intersection. And another thing is taking the max of any kind of ordered element. So for example, the max of 7 and 7 is still 7. Same with the minimum of 7 and 7. It would also be still 7. And so max and min are so-called semilattices. And this is kind of what I mean by it's kind of like counterintuitive. Like if you take the max of two things, you don't really usually see it as combining them in a way. But as I said before, the only thing that matters is the laws in this mathematical sense. So they are still semilattices and by extension semigroups. Okay, what can we do with semilattices? What else is there? So idempotency is a really important thing if you look at like distributed systems or something like Amazon SQS. When you have like some kind of at least once delivery, because you can't guarantee that a message will be delivered exactly once. And this is where idempotency really comes in handy, because if you want to send something, you have to make sure that if it comes twice, that doesn't like completely throw you off guard. And if you prove that your algebra that you use for this kind of thing is idempotent, that means you're basically safe on that regard. Another thing is like, I've talked about set intersections and set unions, but the same goes for like geometry operations, where if you take like a polygon and another polygon and you form their intersection, that is also, of course, idempotent and commutative, or the union of that. And that's something I've come across in my job recently. Or something like, as I said before, using updating state in a distributed system where you don't have this kind of guarantee that everything will always be delivered to all these different nodes. So something like CRDTs can be modeled very well using semilattices. And in fact, I think it's been done in the CATS book by, I want to say, Noel Welch and Dave Grinnell. Yeah, and basically any situation you might need idempotency, you can model it mostly as a semilattice or something similar. So yeah, that basically gives us this chart, which we should now be able to read more or less. So we've seen semigroup, we've seen commutative semigroup, monoid. Band is exactly like a semilattice, but it does not have commutativity, right? So band is just associative and idempotent, but doesn't have to be commutative. Yeah, and then we have group and commutative group and commutative monoid, which are just commutative forms of their structures. And then bounded semilattice is like a semilattice, but adds an identity. So yeah, that's the basic algebraic structures we learned. And now we're going to look at the two laws that I mentioned earlier that we haven't spoken about earlier. And those are absorption and distributivity. And for that, we have to look at ring-like structures. And ring-like structures are a bit more involved. So we're going to look first at a semi-ring. And a semi-ring can be seen kind of as something where we can take both, you both have like an additive method plus, but also a multiplicative method times. And then you also have this 0 right here that is basically like an empty for plus, right? So 0 is the identity for plus. And basically that's exactly what it is. Like plus and 0 have to form a monoid, and times has to be associative, so it has to be a semigroup. So in other words, plus forms a commutative monoid with 0 as an identity, and times forms a semigroup, and that is the whole definition of a semiring, or semi-ring, whatever you want to call it. Yeah, and this is a semi-ring, but there's tons of other ring-like structures. Actually, let's first go into absorption. Sorry about that. So the important part of this absorption law is that this 0 interacts with the times function. So if we multiply by 0, we know, like in numbers terms, that always becomes 0. And semi-ring is kind of like the abstraction of that. So if you multiply, or if you use this times method with this 0, then it becomes 0. So it absorbs anything you put into it, kind of. That's the intuition. And then we also have the distributivity, where plus has to distribute, times has to distribute over plus. And basically what this means is if we do A times B plus C, that has to be the same as A times B plus A times C. And this is something that probably most of you know happens with numbers, but there is lots of other things that also have the same kind of behavior. So we have a semi-ring, which is a commutative additive monoid and a multiplicative semigroup. So what if we kind of had a group in the additive part, right? So if you had a commutative additive group and a multiplicative semigroup, we get what's called a rung. Mathematicians. And if we have two monoids, one a commutative additive monoid and a multiplicative monoid, we have a rig. And if we have both a commutative additive group and a multiplicative monoid, we get a ring. And you can kind of see where these names come from, rung and rig, by basically saying rig is a ring without n, without negation, right? Because it's only a group on the additive, so you can't negate it. And rung is a ring without the I, without the identity, because it's just a semigroup that doesn't have an identity. So that's like something you can remember if you want. And then if both are field groups, right, if we can call the inverse on both of these, we get what's called a field. So those are ring-like structures. And then we have to also look at lattices, which are similar in a way that they have both have also two operations that kind of operate, but instead of forming on multiplicative and additive, they look a little bit differently. So basically, if we have two semi-lattices on the same type, we get a lattice. And if we have two bounded semi-lattices, we get a bounded lattice. And two semi-lattices that distribute over another, right? That is called a distributive lattice. Two bounded semi-lattices that distribute over another is called a bounded distributive lattice. It's quite a mouthful, but it is what it is. Yeah, sorry about that. So the next thing I want to talk about, this was the abstract algebra part. And the next thing I want to kind of talk about is the type 3 part, because Scala's type system is really, really interesting, and it's only going to get more interesting with the upcoming Scala 3. And so I want to look at something that is here in the title called monoids at the type level. And I'll show you in a second what that means. So we've talked about these algebraic structures at the value level, right? So if we combine two values of A to form a new A, but we can also do that same thing at the type level, right? So instead of combining two values of type A, we combine two different types. So we combine type A and B. And so, for example, one of these things are product types, right? So we can combine a type A and a type B by using a product type, which in Scala is a tuple, for example, right? So I'm going to claim that these product types are monoids at the type level because they are associative, right? So A tupled with B and C is equivalent or isomorphic to a tuple of A, B, and C, right? You can see that these things are exactly the same. And by isomorphic, I basically just mean that you can go from one side to the other side without losing any information. So you can go there and back, and it will still be the same thing. So they are associative, and they also follow the identity law, right? So if you tuple something with unit, that doesn't give it any extra information, right? So A tupled with unit, you can turn that into A, and you can go back to A with unit a million times, and the thing will always be the same because unit doesn't have any information. Yeah, and that is also unit tupled with A. It's also the same. So product types are monoids. What about sum types? So yeah, sorry. Product types are also basically, that's why they're called product types, is because they're akin to the Cartesian product of the set of inhabitants of the two types. So if you look at this in like this sort of Venn-ish diagram, it's not a real Venn diagram, we can see that the tuple of x, y, its inhabitants, right? So if x is a type that is either A, B, or C, and y is a type that is 1 or 2, the tuple of x and y, which is a new type in itself, now has the Cartesian product as its inhabitants. And if we do this with unit, we can kind of see here, oh, these things are pretty much the same, right? There's just like some extra parentheses and a comma. All right, so we can do the same thing with sum types. Getting ahead of myself, sorry. Where the associativity law still holds, right? So either A, either B, or C is the same as either A and B or C. And basically both of these types just mean there's at least one of an A or a B or a C in this type somewhere. And you can go from one or the other and back again easily. And the identity is formed with this special type called nothing. And nothing is a type that has no inhabitants, right? So there can never be a value for nothing unless you throw an exception or recurse indefinitely. But we're kind of like gonna discount that and not talk about it. So either A or nothing is always going to be a left, because it can't be a right, because then it would have a value of nothing, which it can't have. So basically it's always a left, and that means it's always an A. And this is akin to the disjoint union of the set of inhabitants, right? So if we look at a set of inhabitants using our same x applies earlier, we can kind of see that either x and y, its inhabitants are kind of like the disjoint union of those two sets, x and y. And here we have A, B, C, 1, 2. And the cool thing about this is that if we looked at the product type, tuple xy, we had 6 distinct inhabitants, because there was kind of like 3 times 2. And here we have 5, because it's kind of like 3 plus 2, right? So it's a sum, whereas with tuple, it was a product, right? We multiplied. So yeah, there's lots of these different analogies that kind of start to make sense if you think about the theory and how these kind of things work. And if you do the same thing here with nothing, which is 0, you basically add 0, which is always going to be the same, right? So 3 plus 0 is still 3. Yeah, and so these things, again, these two sets are isomorphic. They're pretty much identical. All right, so sum types are monoids, product types are monoids. How is this relevant? Actually, I'm glad you asked, even though you didn't. We have this thing called semigroupal in cats, and it is basically at the foundation of pretty much all libraries that depend on cats that I know of. And it defines this product function that takes an f of A and an f of B and turns that into an f of tuple AB. So basically, what we said earlier, is if we combine two types and form a tuple type, this is basically like that applied to a higher kinded functor, a higher kinded semigroup, sorry. So we have an f of A and an f of B, and we merge those two f's together into one f, and now what we get is, instead of A or B, we get the tuple of A and B. And this is then extended by apply, which makes apply basically, in mathematicians' terms, it makes it a semi-groupal functor, whereas applicative is a monoidal functor, which I'm going to get into. And yeah, if you have product and map, which you can get from functor right here, that basically gives you apply. So apply is nothing else but product plus map. And it is defined by this app function, which is basically just a different method to get to the same thing, right? So you can get product by using app, but you can also get app by using product and map. All right, so apply is a semi-groupal functor, and if we then kind of like went further and added a unit function to this, right, which returned an f of unit, you would get a monoidal. And actually, this is pretty much exactly what applicative is, right? So we use the identity of our product type monoid, right, of the tuple monoid, so to say, the higher, the type level tuple monoid, and added the unit identity, and that gave us a monoidal functor, which is called applicative. And applicative is defined in terms of pure, but pure and this unit function are identical, or they can be defined in terms of each other if you have map again, which we do because it's a functor. So yeah, and the cool thing is we can do the same with sum types again. So we have this sum semigroupal that takes an f of A and an f of B and returns, instead of an f of tuple AB, an f of either AB. And then we could make this a monoidal by adding this nothing method, which just returns an f of nothing. And actually, this kind of exists in cats already, and you might have come across it.